Most computer science courses emphasize acquiring various abilities, including web development, programming, data analysis, and many more. Students are still responsible for putting their talents into practice. If you are in college, it's quite necessary to work on projects that help you in skill development as well as improve your CV. Hello everyone and welcome to SimpliCode's YouTube channel. Today, we'll take you through certain projects related to technologies like Python, JavaScript, and Java. These projects are important and interesting if you are in the final year of your college. This video tutorial will help you with your final year college projects and your resume. But before we begin, let me tell you guys that we have regular updates on multiple programming videos. So if you are a programmer and want to learn something new, then consider getting subscribed to our YouTube channel and press that bell icon to never miss any updates from SimpliCode. So we'll start this video by going through some data analysis projects using Python, wherein we'll work on certain data sets like COVID and Olympics. Moving ahead, we'll go through some JavaScript projects as well, wherein we'll create certain apps like the calculator app, weather app, and the snake game app. In the end, we'll cover certain projects related to Java programming. We are covering these three languages because of their popularity and mass usage. So let's move on and start with our first project for the day. Over to our training experts.
Today, we are going to perform two hands-on projects on COVID data analysis using Python and Tableau. This is going to be a really interesting and fun session where I'll be asking you a few generic quiz questions related to coronavirus. Please make sure to answer them in the comment section of the video. We'll be happy to hear from you. COVID or coronavirus is an ongoing global pandemic of coronavirus disease that emerged in 2019 and was first identified in Wuhan, China. It is defined as an illness caused by a novel coronavirus called Severe Acute Respiratory Syndrome Coronavirus 2, commonly known as SARS-CoV-2. On March 11, 2020, the WHO declared COVID-19 a global health emergency. The virus has so far infected over 22 crore people and killed more than 4.5 million innocents. In India, there have been over 3.3 crore confirmed cases and nearly 4,41,000 deaths have been reported so far. This data is according to official figures released by the Union Ministry of Health and Family Welfare. As the world tries to cope up with this deadly virus, we request all our viewers and their family members to follow all the necessary precautions to avoid getting infected. Quiz time. Now let's see our first quiz in this project. What does corona in coronavirus mean? Here are the options. Is it A. beer, B. respiratory, is it C. crown, or is it D. sun? This is a very generic question. I'm sure a lot of you may already know, some of you may not. Please let us know your answers in the comment section of the video. We'll be glad to hear from you. Now in this video, we will use three different COVID-19 datasets and perform data analysis using Python and Tableau. The project will give you hands-on experience working on real-world datasets and how you can use the different Python libraries to analyze and visualize data and draw conclusions. You will learn how to create different plots in Tableau and then make a dashboard from the visuals. The project will give you an idea about the impact of coronavirus globally in terms of confirmed cases, deaths reported, the number of recoveries, as well as active cases. We will also see how India has been affected since the pandemic started and dive into the different states and union territories to learn more about the COVID-19 influence and the vaccination status. First, let me show you the two datasets that we'll be using. So for our first project using Python, we'll be using the first two datasets, COVID-19 India and COVID vaccine statewise. Let me open the two datasets. Okay, so this is the first dataset. You can see here we have the date, we have the time, then we have the different state names. If I scroll down, you can see we have Kerala, Tamil Nadu, Delhi, Haryana, Rajasthan, Ladakh, Punjab, Telangana and other states. Then we have something called as confirmed Indian national. So actually this two datasets, confirmed Indian national and confirmed foreign national, we won't be using. So in the demo itself, we'll be dropping these two columns. What we are concerned about are the last three columns, the cured cases or the recoveries, the number of deaths reported, and then we have the total number of confirmed cases. Let me just sort the B column, that is the date column, so that you have an idea about the recent data we have. I'll continue with the current selection and sort it. You can see here, this is till 11th of August 2021. So this data was collected from Kaggle. It has some discrepancies that we will see in the demo. The data is available for free. We will provide the link to the datasets in the description of the video, so please go ahead and download them. The visualizations and results that you will see in the demo are based on the datasets that we will be using. We haven't pre-processed the data to remove outliers or any missing values. Now before I jump into the demo, let me show you the second dataset that we are going to use. Okay, so COVID vaccine state-wise is my second dataset. Let me open it. There you go. So this is the second dataset that we'll be using in the Python project. You can see we have a column called updated on, then we have the state. Again, you can see here there are a few discrepancies here. It has taken the country name and not the state name. Below you can see there are the different state names, and you can also see we have information about the total doses administered. We have the sessions, sites, first dose administered, then we have the second dose, then we have information about male and female doses. You can see here the different vaccines administered, Covaxin and Covishield. You have Sputnik V, and here are the different age groups as well. And finally, if you see, we have male individuals vaccinated, the total number of female individuals vaccinated for a particular day. We have information about transgender individuals vaccinated, and finally we have the total individuals vaccinated each day. Alright, before we jump into the hands-on part, let's have a look at the second quiz in this project. So here is the second quiz question. Which is the first country to start COVID vaccination for toddlers? Is it A, Japan, B, Israel, C, Portugal, or is it D, Cuba? This is a very recent development that took place. If you watch daily news updates on coronavirus, you will be definitely able to answer the question. Please give it a try and put your answers in the comment section of the video. It is really important for our viewers to know the right answer. Alright, so now let's begin with our demo. So I am on my Jupyter notebook. So the first project we are going to use Python Jupyter notebook. I'll just rename this notebook as COVID Data Analysis Project. I'll click on rename. Alright, so first and foremost, we need to import all the necessary libraries that we are going to use. So first I'm importing pandas as PD. This is for data manipulation. Then we have numpy as NP. Numpy is used for numerical computation. Then we are importing matplotlib, seaborn, and plotly. These three libraries will be used for plotting our data and creating interesting visualizations. Finally, I'm also importing my datetime function. Alright, so I'll hit Shift Enter to run the first cell. Now it's time to load our first dataset, which is related to the COVID-19 cases in India for the different states and union territories. So I'll create a variable called COVID_df. df is for data frame. I'll use my pandas library and then give the read_CSV function, since our datasets are CSV files, and inside double quotes I'll pass in the location where my datasets are present. So I'll just copy this location, I'll paste it here. We'll change the backslash to /, and after that I'm going to give my file name followed by the extension of the file. I'll say COVID-19 India.csv. Let's go ahead and run it. Alright, Now to see the first few rows of the data frame, I'm going to use the head function. I'll say head, and within brackets, let's say I'll pass in 10, which means I want to see the first 10 rows of data. If I run it, there you go. Here you can see from 0 till 9. So we have 10 rows of information, and these are the different column names. You have S number, date, time, state or union territory, then you have confirmed Indian national, confirmed foreign national, cured cases, deaths reported, and the confirmed cases. Alright, now moving ahead, let's use the info function to get some idea about a data set. If I run it, you can see here it gives us the total number of columns. We have 9 columns. The total number of entries or the rows, we have 18,110 rows of information starting from 0 till 18,109. You see here the different types of variables or column names that we have. Then it has information about the memory usage as well. And this side you can see the data types. Cool. Now we'll use another very important function, which is to get some idea about statistical analysis, the basic statistics about your data set. For that, I'll be using the describe function. Okay, so if you can see here, the describe function is for numerical columns only, and you have the measures such as count, the mean, standard deviation, maximum, minimum, the 25th percentile, 50th percentile, and the 75th percentile value. Okay, now let's move ahead and import the second data set, which is related to vaccination. So I'll create a variable called vaccine_df. I'll write pd.read_csv function, which is present in pandas library. I'll move to the top and I'll copy the file location, and we'll change the name of the file. Copy this and let me paste it here. And instead of COVID_19_India, I'm going to say COVID_vaccine_statewise. Okay, so this is the dataset that we saw, COVID_vaccine_statewise. Alright, let me run it. Cool. And let's display the first 7 rows of information from this data frame. I'll be using the head function, and inside the function I'll pass in 7. There you go. So here you can see we have from 0 till 6. There are total 24 columns. A lot of them have null values, you can see here. Alright. Now from the first data set, which is the COVID_df data frame, we'll be dropping a few unnecessary columns such as the time column, confirmed Indian national and confirmed foreign national, as well as the S number. We don't need these columns, so it's better to learn how to drop the columns for our analysis. So I'll say COVID_df dot, I'll use the drop function, and within square brackets I'll pass in the column names. The first is S number. I'll give a comma. Within double quotes I'll say the next column is time. My third column that I want to drop is confirmed Indian national. Give another comma. Within double quotes I'll say confirmed foreign national. Outside the square brackets I'll give another comma and pass in my next argument, that is in place equal to, I'll say true, I'll give another comma and say axis equal to 1. Let's run it. Okay, it has thrown an error. Let's debug the error. Says confirmed Indian. Okay, it should be Indian national and not Indian nation. I'll just mention it as national. We'll run it again. Okay, now we have removed these 4 columns. Let me show you the dataset now. There you go. So we have only the date column, state or union territory, cured, deaths and confirmed. Now let's see how you can change the format of the date column. For that you have the function called toDateTime. I'll say COVID_df. I'll pass in my column name, that is date. I'll say equal to pd dot. I'll use the pandas function, that is to_datetime. I'll say COVID_df, which is my data frame name. Pass in my variable, which is date. Give a comma, and I'll use my argument, that is format equal to. I'll say %y. Give a dash, say %m. Give another dash and say %d. Let's run it, and I'll print the head of the data frame. Cool. Now moving ahead, now we will see how to find the total number of active cases. So active cases nothing but the total number of confirmed cases minus the sum of cured cases plus deaths reported. So let's find the active cases. I'll give a comment. Okay, I'll first write my data frame name, that is COVID_df. Within square brackets I'll give my new column, which is active_cases. I'll say equal to COVID_df, and my first column would be the confirmed cases column minus, I'll say COVID_df. Then I'll pass in my cured column plus, I'll again say COVID_df and add my deaths column. This time let's print the last 5 rows from the new data frame that we have created. Okay, let's run it. Okay, it has thrown an error. Let's debug it. Says data frame object has no attribute tails. This should be tail. There you go. You can see here we have added a new column called active cases, which is the confirmed cases minus the sum of cured and deaths reported column. Now we will learn how to create a pivot table using the pandas library. So in this table we'll be summing all the confirmed deaths and cured cases for each of the states and union territories. So we'll be using the pivot_table function for this. I'll create a variable called statewise and say pd dot. I'll use the pivot_table function. I'll pass in my data frame, that is COVID_df, and then I'll give my values parameter. Inside the square brackets I'll pass in my columns confirmed deaths, and then we'll have the cured column. I'll give a comma, and next argument would be index, which is going to be my state slash the union territory column. Let me bring this to the next line so it is more readable. I'll say union territory. I will give a comma now and pass in my last argument, which is agg function, that means aggregate function, and this function would be max. Alright, let's run it. Okay, now I'm going to find out the recovery rate. So recovery rate is basically the total number of cured cases divided by the total number of confirmed cases into 100. So I'll say state-wise, and within square brackets I'll pass in my variable that I want to create, which is recovery rate. This will be equal to the cured cases multiplied by 100 by the total number of confirmed cases. Within square brackets I'll give my column as confirmed. Let's run this. Okay, I'll just copy this column, paste it here. So this time we are going to find out the mortality rate. So mortality rate is nothing but the total number of deaths divided by the total number of confirmed cases into 100. So I'm just going to replace the names. Here I'll say mortality. Alright, and then instead of cured I'll say my deaths column into 100 divided by the confirmed cases. Let's run it. Okay, now we are going to sort the values based on the confirmed cases column, and we'll sort it in descending order. So let me show you how to do it. I'll say state-wise equal to, I'll use the function sort underscore values. So I'll pass in my variable state-wise dot and use the sort underscore values function. I'll say by, I want to sort it by my confirmed cases column. Give a comma and I'll say ascending equal to false. Let's run it. Now we are going to plot our pivot table using a nice visual. So for that I'm going to use my background underscore gradient function, and inside that function we'll pass in our CMap parameter. I'll show you how to do it. I'll say style dot background underscore gradient, and inside this we'll pass in a parameter called CMap. So CMap stands for color maps. This is present inside the matplotlib library. So here you can see there's a nice documentation on choosing color maps in matplotlib. This is provided by matplotlib.org. If I scroll down, you can see there are a number of CMaps that you can use. Purples, blues, you have something called reds. There are other things like magma, you have summer, autumn, spring, winter, cool, all these. You can use whichever color map that you want, and here you can see the different shades or the gradients. Okay, so I am going to use my color map as cube helix. Let me run it and show you the pivot table. There you go. Here you can see we have our pivot table ready. Now, as I said in the beginning, there are a few discrepancies in the data set. So here you can see there's one called Maharashtra, and there's also Maharashtra triple star. This you can ignore. Even if I scroll down, you have Madhya Pradesh followed by 3 asterisks. You can ignore this value as well. Even for Bihar we have. So these have been duplicated. And here you can see the different state names and union territories. Then on the top you have the confirmed cases, cured cases, the deaths reported, and the new columns that we created. These are calculated columns, recovery rate and mortality rate. And we have ordered it in descending order of confirmed cases. So far our data says that Maharashtra has the highest number of cases, followed by Kerala, Karnataka, Tamil Nadu, Andhra Pradesh and Uttar Pradesh. So these are the top 5 states which have the highest number of confirmed cases. Even if you see, the mortality rate is also high for Maharashtra. And if I scroll down, the mortality rate is also high for Uttarakhand, if you see here. If I scroll further, you have Punjab, the mortality rate is also high. Alright. So this was our first visual that we created in the COVID data analysis project. Now moving ahead, we'll see the top 10 states based on the number of active cases. So we'll start. I'll give a comment, top 10 active cases states. Okay. So we are going to explore another very important pandas function in this, which is known as group by. So I'll first pass in my data frame, which is COVID_df dot followed by the group by function. I'm going to group my data based on state/union territory column. Then I'll say dot max, which is to find the maximum value from the states that have the highest active cases. So I have passed in my active cases column, and we're also going to group it based on the date column. After that, we are going to sort the values. So I'll use my function that is sort_values. I'll say sort by my column that is active cases. Let me bring this to the next line. Underscore cases. I'll give a comma and say ascending equal to false. Say dot, and then reset my index. For that I'll use reset_index function. Okay, let's check if everything is fine. I have missed a square bracket here. Let me give another square bracket here. Okay, and all this we are going to store in our variable called top_10_active_cases. Okay, now let me go ahead and run this cell. Okay, there is a syntax error here. Now let's run it. Okay, now I'll create another variable called fig. Here we'll pass in the plt, which is for matplotlib library, and we'll give the figure size using the fig size argument is equal to, and within a tuple and passing the size, let's say 16,9. We'll run it. Okay, and let's give a title to our plot. So here we are going to create a bar plot. So using plt.title, we'll pass in the title, let's say top 10 states with most active cases in India. I'll give a comma and pass in the size of my title, let's say 25. Okay, you can see we are slowly being able to create our graph. The most important thing is to pass in the x-axis and the y-axis. I'll say ax, which is for axis. To pass in the axis, I'm going to use the bar plot function that is present inside the Seaborn library. I'll say sns.barplot. I'll say data equal to my variable, which is top underscore 10 underscore states. This is actually active states. Alright, and now I'm going to use the iloc function and take the first 10 states. So I'm using a colon and then giving 10 as my value. ILOC is for index location. I'll give a comma and say my y-axis to be active cases. Give another comma and say my x-axis to be state slash union territory. Give another comma. We are going to pass in the line width to 2. I'll say line width equal to 2, and we'll give an edge color. Let's say the edge color is red. Okay, so I have my axis defined now. Let's run it. There's an error here. It says top 10 active states not found. Let's go to the stop and see the exact. Okay, so this is top 10 active cases. Let me change it to cases here. Now run it. Okay, the x-axis also has a mistake. This should be state slash union territory. Now let me run it. There you go. We have our plot created, but as you can see here, the labels of the different states and union territories are overlapping. So for that, let me first pass in the x labels. I'll say plt.x label, and my x label would be states. Then I'll say plt.y label. My y label will have the total active cases. And finally, I'll write plt.show. Before I run it, let's collate all the lines of code that we have written for our top 10 states for most active cases in India into one cell. So what I'll do is I'll just copy this and we'll keep adding in this cell itself. Okay, I'll go to the top. Next, we'll copy my figure size and we'll paste it here. Next, let's take the title and put it here. Give a space, and we are going to copy this cell and I'll paste it here. Alright, now it's time to run it. There you go. You see it here. We have a nice bar plot ready. On the top you can see the title, top 10 states with most active cases, and you see the edges are in red color for all the bars. On the x-axis you have the different state names: Maharashtra, Karnataka, Kerala. You also have Andhra Pradesh, Gujarat, West Bengal and Chhattisgarh. So as you can see, Maharashtra has the highest number of active cases based on our data, followed by Karnataka, Kerala and Tamil Nadu at 2nd, 3rd and 4th place respectively, and in the 9th place we have West Bengal, in the 10th place we have Chhattisgarh. On the y-axis you can see the total active cases, which are in lakhs. Okay, now moving ahead, now we'll see the top 10 states based on the total number of deaths reported. So I'll give a comment: top states with highest deaths. Okay, so I'll first create my variable saying top 10 underscore deaths. This will be very similar to what we did here, just that we need to change a few column names. So instead of active cases we'll be using deaths. Okay, so I'll start with my data frame, that is COVID underscore df, followed by using the group by function, and I want to group my data based on the state slash union territory column. Then I'll choose the max function, and within double square brackets I'll pass in my column names deaths and date. Let's make it consistent. I'll be using single quotes. Okay, I'll say dot, I'm gonna sort my result, therefore I'm using the sort underscore values function. I want to sort it by deaths column. I'll give another comma and say ascending equal to false, which means I want to order my result in descending order. Then I'll say dot reset underscore index. Okay, after that I'll give my figure size. I'll say plt dot figure, and within brackets I'll pass in my argument, which is fig size equal to, using a tuple I'll say 18 comma let's say 5. Now let's give a title. For that I'll use the title function, which is present in the matplotlib library. I'll say top 10 states with most deaths, and let's give a size to the title 25. Now it's time for us to give the access labels. I'll just scroll down. Okay, so I'll say ax equal to, again this will be a bar plot, so I'm using my Seaborn library followed by the bar plot function. My data will be top underscore 10 underscore deaths, which is this variable. I'll give my index location ILOC. I'm going to choose 12 states. The reason being, there are some discrepancies in the data. I'll show you once I plot this result. So in the y-axis we'll have deaths column. In the x-axis we'll take state slash union territory. Okay, I'll give another comma and say line width equal to 2, and we'll give an edge color to our bars like we did here. So I'll say edge color equal to, let's say, black. Okay, now finally we'll give the X label, the Y label. So I'll say plt dot X label. X label would be states. My Y label will be total death cases. Then I'll write plt dot show. Now let's run it. There you go. You can see here we have a nice bar plot. On the top we have the title, top 10 states with most deaths. Now what I specifically wanted you to see was these discrepancies in the data. You can see here Maharashtra is repeated twice, even in our data that we collected from Kaggle. Karnataka spelling has an error. You can see here we have a few rows of information where Karnataka is spelled as K-A-R-A-N instead of K-A-R-N-A. Alright, so to remove these two results or to ignore these two results, I had given my index location till 12. So we have Maharashtra, Karnataka, Tamil Nadu, Delhi, then Uttar Pradesh, West Bengal, Kerala, Punjab, Andhra Pradesh and Chhattisgarh with the states that have the most number of deaths reported. Okay, now we'll create a line plot to see the growth or the trend of active cases for top 5 states with most number of confirmed cases. So the states are Maharashtra, Karnataka, Kerala, Tamil Nadu and Uttar Pradesh. I can show you. So these are the states with highest number of active cases. Okay, I'll just give a comment saying growth trend. Alright, so for that we'll start with our figure size as plt.figure. I'll use my parameter fig size equal to 12,6. I'll say my axis as SNS dot. This time we are going to create a line plot. My data would be my original data frame, that is COVID_DF, and within square brackets I'll say COVID_DF, and we are going to pass in the state or the union territory column. I'll give a dot and use the isIn function. So the states should include Maharashtra, I'll give a comma. The next state should be Karnataka. Next we have Kerala. Give another comma. My fourth state is Tamil Nadu. Give a comma, and my fifth state would be Uttar Pradesh. Alright, so I'll give a comma here and then say X equal to the date column, Y will be active cases column, and I'm going to use another parameter called hue, which is to give different colors to the different states, the 5 states that we are looking for. So hue will be my state/union territory column. Okay, after this I'll say ax dot set title. My title will be top 5 affected states in India. We'll give a size, let's say 16. Alright, okay, this should be size equal to 16, and to make sure everything is fine, let me just move it to the above line. Okay, now we'll run it. Okay, there is some error again. It says invalid syntax. Let's see where we went wrong. Let me bring this to the above line. Okay, this should be COVID_df. Okay, make sure you keep these small errors in check. Let's try and run it again. Alright, if I scroll down, there you go. Here you can see we have the top 5 affected states in India. You see the different states here and the colors. So this violet or the purple color is for Maharashtra. You can see how the active cases surged around April and May, and then you can see even for Karnataka the active cases surged very rapidly around May and June. Then it has decreased, luckily. Similarly, you can see the plots for even Uttar Pradesh as well as for Tamil Nadu. So all the 5 states, you can see one common trend that after March, so around April, the cases started to emerge very rapidly, and later after July they started dipping. Okay, now we are going to use our second data set, which is related to vaccination. Alright, so first and foremost, let me go ahead and print the data frame for you so that you know the data that we are going to use. So this is the data we are going to use for our next set of analysis. Even this data has a few errors, and you can see there are a lot of missing values. It makes sense because not all the days you would have vaccination for people, and very crucial error that we are going to deal with is this state column. Here you can see in the state column we have India in a few rows, so we are going to ignore these rows. Alright, first let's rename our updated on column to just vaccine date. So you can use the rename function present in the pandas library to do it. So I'll say vaccine_df dot rename. I'll say columns equal to, within curly braces I'll write updated on, which is my original column name, give a colon. I want to change this to vaccine_date. I'll give a comma and say in place equal to true. So it will change my column name from updated on to vaccine_date in the original data frame. Let's run it. Now let me go ahead and print the first 10 rows in the dataset. You can see here we have successfully changed the column name to vaccine_date. The rest of the columns remain the same. Alright, now you can check the total number of columns, rows, the data types, and the memory usage using the info function. Here you can see it. We have total 24 columns, 7,845 entries, and these are the columns that are present. And if I scroll further, you see here says the memory usage, and here on the right you can see the data type. Cool. Now, as you saw, the data has a lot of missing values. Let's find the sum of all the missing values for each column. So I'll say vaccine underscore df dot is null, and then I'm going to use the sum function over it. If I run it, there you go. So almost all the columns have missing values, but columns such as male individuals vaccinated, female individuals vaccinated, even for columns like the age groups, there are a lot of missing values. Now in the next step, we are going to drop a few missing value columns. So I'll say a new variable called vaccination. I'll give the data frame name vaccine underscore df and use the drop function. And inside the drop function, we are going to write columns equal to, I'll pass in the column names that I want to drop. I'll say doses administered. So this is the column that I want to delete, Sputnik V doses administered. I'll give a comma. The second column is AEFI. The next column is 18 to 44 years. Within bracket, it has doses administered. Give a comma. I'll say 45 to 60 years, doses administered. Give another comma. The final column that we are going to drop is 60 plus, which is this one, 60 plus years. Doses administered. Okay. So these are the columns that we want to drop. And finally, I'll give my parameter access equal to 1. Okay, let me just recheck these column names. First one is Sputnik V doses administered, then we have AEFI followed by 18 to 44 years doses administered, then we have 45 to 60 years doses administered. Finally, we have 60 plus years. I have added a S here which was missing, and there should be a space as well because there's a space here in the column. Now let's run it. Alright, so we have successfully dropped the columns that we wanted to drop. Now I'll say vaccination.head. You can see here we have dropped those columns and we are left with these columns now. Okay, now we are going to create a plot, that is a pie plot, to see the vaccination for male and female individuals. So I'll give a comment as male versus female vaccination. To create this pie plot, I'm going to use the Plotly library that we had imported, which is this one, Plotly. Okay, so first of all we need to filter out the male individuals from our data frame. I'll say male equal to vaccination male. I'll passing in the column individuals vaccinated. We need to recheck the variable name whether it is correct or not. You see here male individuals vaccinated. Then I'll say dot sum. Similarly, we'll filter out the female individuals. I'll say female equal to vaccination, which is my new data frame. Within square brackets, I'll pass in the column name female individual, vaccinated. I'll say dot sum. Okay, these should be individuals as per the column name present in the data frame. Cool. Now I'm going to say px dot py function, which is present in the plotly library. I'm going to give the names of the pies. So first one is male and the second one is female. Give a comma and say values equal to male comma female. Then I'll give a comma and pass in my title, which is male and female vaccination. Okay, this should be names. Alright, now let's go ahead and run this cell. So it'll take some time to create the pie chart. Here we go. See, here I have my title, male and female vaccination. So these are the two pies or the areas. You have the label female and the value. Here you have the label male and the value. So from our data you can see 53% male individuals have been vaccinated compared to 47% for females. Okay, now we are going to drop all those rows where our state was mentioned as India in the original dataset. I had shown this to you in the beginning, so we are going to remove rows where state is India. Okay, so to do that I'll say vaccine. I'm creating another variable called vaccine and we'll use our original data frame that we had imported, which is vaccine underscore df. I'll say vaccine underscore df dot state not equal to India. Now let's print vaccine. Okay, you can see here we have our data frame printed, and from this data frame we are taking only those values or the rows where state is not equal to India. Cool. Now what we are going to do is we'll rename the last column, which is total individuals vaccinated, to just total. So I'll say vaccine dot rename. We'll use the parameter columns equal to, within curly braces I'll say total individuals vaccinated, give a colon, and we'll change this to just total, give a comma and say in place equal to true. And finally I'll print my head of the new data frame. This should be columns equal to. Okay, now you can see here, if I scroll to the right and if I check, we have successfully renamed our column. Alright, now moving on to the last two visualizations that we'll see in this first project using Python, that is to find the states with most number of vaccinated individuals and the state with the least number of vaccinated individuals. Okay, just give a comment, most vaccinated state. Okay, for this I'll first create a variable called vax_VAC, which is for maximum vaccination. I'm going to use my data frame vaccine followed by the group by function. I want to group it by state column, and we'll find the total sum of vaccinated individuals for each state. I'll convert this to frame. There should be a dot, 2_frame, and I'll pass in my column name, which is total. After that, I'll say max_VAC equal to max_VAC dot sort underscore values. I'm going to sort it by my total column and say ascending equal to false, which means I want to sort it in descending order so that we have the states with the highest number of individuals vaccinated. I want the top 5 states. Now let's go ahead and print it. So this will create a nice table for us. There you go. Here you can see we have Maharashtra, Uttar Pradesh, Rajasthan, Gujarat and West Bengal as the top 5 states with most number of vaccinated individuals. Now we are going to use this table and convert it into a chart. Now I had already written my code for the bar plot. I'm just going to paste it. So here I have defined my figure size as 10,5. Then I'm giving a title as top 5 vaccinated states in India and the size is 20. After that I've created a variable called x, which is going to store my bar plot. This bar plot we have created using the Seaborn library, and you see here I have my y-axis defined, then I have the line width and the edge color as well. I've given my x label as states, y label as vaccination, and I'm finally going to display my plot. So let's go ahead and run it. Okay, you can see it here. We have converted this table into a bar plot now. So first we have Maharashtra with the highest number of vaccination. Then we have Uttar Pradesh, Rajasthan, Gujarat and West Bengal. Now I want the viewers watching this video to find the states with least number of vaccinated individuals and convert that table into a bar plot that will show the bottom 5 vaccinated states in India, which means the states which have least number of individuals vaccinated. So please go ahead and put your codes in the comment section of the video. It will be very similar to these two cells, just that now we want to know the least 5 vaccinated states in India. So please put the code snippets in the comment section of this video. We'll be more than happy to know from you. In case you are not able to do it, we'll definitely give the answers in the comments itself. Alright, so this brings us to the end of the first project on COVID data analysis using Python. So in this project we used 2 datasets. One was on the COVID-19 India dataset for different states and union territories, and the second dataset that we used was for analyzing the status of vaccination in the different states in India. Now we'll move on to our second project. Okay, so before moving on to our Tableau project, let's see the final quiz. Which of the following is not a common coronavirus symptom? So this question is to make you aware of the correct COVID symptoms. Here are the options. Is it A, fever, B, vision loss, C, loss of taste and smell, or is it D, cough? Please put your answers in the comment section of the video and let us know what you think. Now we'll move on to our second COVID data analysis project. For this project we'll be using the Tableau software and a global coronavirus dataset. First we'll look at the dataset and the fields we have. Okay, so I am in my dataset folder. We have already seen the first two datasets in our Python project. This time we are going to use the global COVID data. Let me open it. Alright, so here you can see we have the different country names. There are 192 countries in our dataset. Let me go to the top. So we have country or region. We also have the code for each of the countries. Then we have a column called last updated. So here you can see our data is still 12th of March 2021, and there are two columns which don't have any information, that is people hospitalized and people tested. Then we have a column called active cases. Then we have a column for confirmed cases in the different countries. We have the number of deaths, and then we have the incident rate, the latitude and the longitude for the countries. Then we have the mortality rate, this is in fractions. Then we have the number of recovered cases, and finally we have a column called UID. So we'll be mostly using the country column, active, confirmed, deaths, and the recovered cases column. And we'll be using the Tableau software to create interesting visualizations, and we'll convert those visuals and put it in the form of a dashboard towards the end of the project. Okay, so let me close this file, or let it be open. I'll search for Tableau public. You can see here I have Tableau public installed. You can use the desktop version of Tableau or the public version of Tableau. So for this project we are going to use the Tableau public edition. So here you can see I have created a few visuals already. If you want you can clear them out. Okay, now the first thing we need to do is to connect our CSV dataset to Tableau. For that, under connect we have to a file. I'm going to use text file, and under Chrome downloads I'll search for my folder COVID-India, and here I have my global COVID data file. Let me open it. This will take some time to load. There you can see. So on the Tableau you can see the view here. It shows the country or the region. You have the last update. You have columns like active, confirmed, deaths, mortality rate, and recovered. And here you can see the symbols for the different columns. So this is a globe, which means this field is a region or a geographic field. ABC means it's a text field. Then we have the calendar, which is for a date field. ABC are text field, and this hash represents numeric fields. Alright, so now that we have loaded our data, let me just click on sheet 1. So this is the canvas where we are going to create our different reports. Alright, so on the left you can see there are two panes, the data pane and the analytics pane. In the data pane you can see the name of the dataset, global COVID data, and here you can see the different columns that we have in the dataset. So on the top, the ones marked in blue are called as dimensions, and at the bottom whatever you see are marked in green and are called as measures. So dimensions are always represented with blue icons and measures are in green icons. So Tableau has automatically detected the different data types for each of the columns. Alright, so First of all, we are going to create a simple table to see the total number of confirmed cases for each of the countries. So for that, I'm going to drag my country or the region column onto rows. Here you have rows. I'll just drag it and drop it here. There you go. It has populated all my country names starting from Afghanistan till Zimbabwe. So it has ordered in ascending order of alphabets. Now to see the total confirmed cases for each country, I'm going to drag my confirmed column onto text. So here under marks card you have the text option. I'll just drag it and drop it here. There you go. So Tableau how easily has shown me a table where you can see the different country names, and on the right you have the total number of cases that have emerged from these countries. Now this is not the most recent data. As I told you, this data was till March 2021. Cool. Now you can go ahead and sort the table based on the total confirmed cases. Here on the top you can see here there are two options to sort in ascending order or in descending order. Let's first sort in ascending order by sum of confirmed cases with few cases, and if I scroll down you have France, UK, Russia, Brazil, India and US with the highest number of COVID-19 cases. If you want, you can also sort it in descending order so that the countries with the highest number of confirmed cases appear at the top. You can see it here, and these are the countries that have very few COVID cases. Now you can convert this simple table into different charts and graphs. To do that, here on the right top corner you have an option called show me. Now I can just click on this horizontal bar graph, so that will automatically convert my table into a bar graph. Again, you can go ahead and sort the data. There you go. So here you have US, India, Brazil, Russia, UK, France, Spain and Italy. This is a horizontal bar graph sorted in descending order of confirmed cases. Now suppose you want to display only the top few countries with the highest number of confirmed cases. For that you can select these bars. So I'll select till, let's say, Germany, or let's say till Argentina. Okay, and I'll click on keep only. You can see it here, it says 12 items selected, that is the sum of confirmed cases. I'll just click on keep only. There you go. So this horizontal bar graph has information only for these few countries that have the highest number of confirmed cases. Now you can go ahead and play with the color formatting. So here under colors, let me choose a green color. Okay. Now you can mark here, since we selected only the top 12 countries with the highest number of confirmed cases. So what we did was we just filtered it to the top 12 countries. So Tableau has automatically added country region in the filters card. Now if you want, you can go ahead and edit this filter as well. Suppose you want to remove Argentina, you can just uncheck this, click on apply and OK. You see here Argentina has been removed. I click on undo, so Control Z to get it back. Cool. Now you can convert this horizontal bar plot into a vertical bar plot. Let me show you how to do it. I'll just remove these fields from my chart. Now what I'm going to do is I'll drag country or region onto columns, and I'll have a confirmed column under rows. There you go. Here you can see we have a vertical bar plot now, and again you can use the axis now to sort your data. This is in descending order. Similarly, you can sort it in ascending order. Here you have the option to sort your data. Okay, cool. And below you can see the different country names. Alright, now you can go ahead and give a name to this sheet. Let's say top 10 confirmed countries. Just apply and click on OK. You have the title to this plot. Similarly, you can change it here as well. Top 10 confirmed countries. Okay. Now let's move on to our second visualization, where we will create a global map. So this global map will show the different countries present in the map and the cases that they have. So to create the map, first I'll drag my longitude generated field onto columns, and then I'll drag latitude onto rows. You see here we have the map ready, and now I'll drag country region onto detail. So this will give you the different country names. You can see here we have Canada, the United States, Mexico. Here you have India, Sri Lanka, there's Australia, this is Brazil, and similarly we have Spain, France, Belgium, there's Italy here, we have also Greece. Similarly we have the African countries like Central African Republic, there's Congo, Angola, and on the top you have Russia, and this is Iceland, so on and so forth. Now I'm going to drag the active cases column onto detail again. Now if I hover the cursor, you can see the active numbers for Brazil, you can see for India, you have countries like China, then here you have Thailand, Algeria. Now I'm going to drag the confirmed cases column onto label, so that you have the labels here. You can see here the confirmed labels. Cool. Now if you only want to focus on a few countries present in a particular region, you can highlight that region. For example, suppose for Europe you want to focus on this region. If you select it, it will highlight only those countries, and if you hover your mouse over these points, it will show you the active cases and the total number of confirmed cases. Alright, now if you want, you can go ahead and change the color of the circles. Let's say I'll keep it as red. Okay, so this is how you can create a map to represent the different active and confirmed cases. I'll rename the title to global cases. I'll just click on apply and OK. Similarly, I'll change the sheet name as well to global cases. Okay, now from this map you can see the countries such as USA, Brazil, you have Russia and India with the highest number of COVID-19 cases. Even in countries such as Spain, the numbers are really high, and a lot of the African countries were also impacted. And these small countries like Solomon Islands, you have Fiji Islands with few number of cases, even for New Zealand as well. Alright, now moving to our next visual. Now we are going to see the top 10 countries where highest deaths have been reported so far due to the pandemic. For this we will create a tree map now. So first of all, I'll choose my country column and put it under columns, and then I'll select the deaths column and put it under rows. I have the bar plot ready. Next I'll go to show me, and here I have the option to select a tree map. You see here, for a tree map you need one or more dimensions and one or two measures. So I'll just click on this tree map. Okay, here you can see I have my tree map ready. So Tableau has automatically adjusted my fields. So it has removed my fields from rows and columns and put it under size, color and label. Next I will drag my country column and put it under filters, and from here I'm going to choose top. I'll filter by field. I'm going to select the top 10 countries based on the total number of deaths. Just click on apply and click on OK. So these are the countries: US, Brazil, Mexico, India, United Kingdom, Italy, Russia, Spain, France, Germany, which have the highest number of deaths reported. Now you can also give the label. I'll put the deaths column under label so that you have the labels here. Alright, so this was a tree map that we created to show the top 10 countries with the highest number of deaths. I'll just change the title, top 10 deaths cases. Now you can also edit the title in terms of the font, color and everything. I'll keep it Tableau bold and I'll choose this as 14. Click on apply and OK. There you go. Similarly, let's rename the sheet to death cases. Cool. Now moving to the next visualization, where we'll see about the recoveries. So before we move on to create a visualization for the top 10, or let's say the bottom 10 countries in terms of recoveries, let me show you how to change the color of this tree map. So here by default Tableau selects the automatic palette. If you want, you can change it to different palettes. Let's say I'll go with gold, purple, diverging. Click on apply and I'll click on OK. If this is not looking that great, you can select another one. Let's say red, green, white, diverging. Cool. Now let's go to our fourth visualization, which is about top 10 recoveries. I'll click on apply and OK. First I'll drag my country or the region column under columns, and then I'll take the recovered column under rows. This time, instead of sum, we are going to choose average. Okay, and here I'll select my packed bubble chart. After that, I'm going to drag my country or region onto colors, and then I'll also put country under filters. So I'll go to the top menu and I'll filter it by field. I want to show the top 10 countries based on the average number of recoveries. If I click on apply and OK, you can see here these are the countries that have the highest number of average recoveries. You have India, Brazil, Turkey, Italy, Argentina, Germany, Colombia, Russia, Poland and Mexico. I'll just rename this sheet to recovery cases. Cool. Now let's move on to our next visual. Okay, so here we are going to create a scatter plot to analyze the total confirmed cases versus the total number of deaths. So whenever you have two numeric fields, it is better to create a scatter plot to visualize the cases. So for that, I'm going to drag my confirmed cases to columns, and then I'll drag my deaths column onto rows. Okay. So by default, the shape is a circle, and to see all the countries, I'm going to drag country under color. I'll say add all members. There you go. Here you can see the legend for the different countries, and the top you have US with the highest number of confirmed cases and the highest number of deaths as per our data set. Then you also have Brazil here, which has the second highest number of deaths. Then you have Mexico followed by India. So this data is not a very recent data. This data was last updated on March. Now from this we are going to filter out the top 10 countries with the highest number of confirmed cases and the deaths. So for that I'll drag my country column onto filters, and I'll go to top, I'll filter by field, I'll say top 10, and I'll click on apply and OK. So here you can see we have Siberia, Sweden, Belgium, Netherlands, Spain, Italy, France, Russia, UK, and you have Brazil. So these are the countries which have the highest number of active cases. So instead of active, let's select deaths, click on apply and OK. Okay, now if you see, we have US here, Brazil, India, then Mexico, UK, Russia, France, Italy, Germany, and Spain, which have the highest number of deaths reported so far. Now if you want, you can change the size of the circles based on the highest number of active cases. So I can just drag my active column under size. So you can see here Spain, France, UK have the highest number of active cases. Now let's say instead of active, I'll just have my confirmed cases under size. Okay, and then you can also change the shape from circle to any other shape, let's say square or this asterisk. Okay, let's go with the triangle. Cool. I'll rename this sheet to confirmed versus deaths. Click on apply and OK. I'll rename this to confirmed versus deaths. Alright. Now moving on to our next visualization, where we will see the mortality for each of the countries and figure out which countries have the highest mortality rate. Okay. So first I'll drag mortality rate onto column, and then I'll have my country column under rows. So there you go. Now let me go ahead and sort it in descending order. So you can see here you have Yemen, there is Mexico, Syria, Sudan, Egypt, Ecuador, China, and other countries which have the highest mortality rate. And you can also select the country region under colors. Let's go ahead and edit the color. Instead of automatic, let's select summer, or you can go for some other palette. Let's say Tableau Classic Medium. I'll assign this palette. Yes, I'll apply and OK. Alright. Finally, we'll move ahead to our last visualization, where we'll create a dual axis chart. So the dual axis chart in Tableau will have one column and two different visualizations on the rows. So here you have one column, and on the right also you'll have one column with their own axis values. So this dual axis chart will be for recovered cases and the death cases. Let me show you how to do it. So I'll drag my country field onto columns, and then I'll choose recovered column onto rows. So here I have got my line chart, and the second column I'm going to choose is the deaths column. I'll hold my cursor and I'll place it when I get this green color rectangle. I'll place it here. There you go. So now we have created two measure names, deaths and recovered, and here you have the access values. You can synchronize the access values if you want. The recovered cases are in millions and the deaths are in thousands. Now let's go ahead and change the recovered line to bars, and we're going to short it. Okay, now let's change the color. We'll select, let's say, blue. I'll assign the palette, click on apply and OK. And if you want, you can also change the color for deaths from blue to, let's say, winter. I'll assign the palette, click on apply and OK. You can have whichever color you want. And to make the axis same, you can just right click on this axis and click on synchronize axis. So here you can see the values. Let's keep it in thousands only. Cool. I'll rename this sheet to dual axis. Okay. Now before we move ahead and create our final dashboard, I want to show you one more feature in Tableau, that is to format the labels. So you can see here, instead of writing 5,30,821, we can change this in terms of millions or thousands and write it as, let's say, 530k. To do that, what I'll do is I'll go to format, and here we have the option to select font, and in font I'll go to fields and click on sum of deaths, and here in this pane I'll choose number custom. Decimal places will be 0, and display units I'll select thousands. You can see here the values have been changed to 531k, 193k, 158k, so on and so forth. Cool. Now let's go ahead and create our final dashboard. Here is the option to create a new dashboard. So I'll just click on new dashboard, and we are going to increase the size here so that it fits our view. So we have selected the default view, and the size I'm going to choose here is automatic. So now we can drop our sheets one by one. First, let's drag the global cases sheet here. Okay, you can see we have our map. Now I'm going to choose the top 10 confirmed cases. Alright, and after that we'll choose the death cases sheet. So Tableau will prompt you to place the sheet at the right location. Okay, and now I'll choose my fifth visual, which is confirmed versus deaths, and if you want you can choose any one of these. Let's say I'll take the dual axis chart. Now you can just minimize the sheets and adjust the sizes to make it look better. Okay, so you can see here we have our dashboard ready. Now you can still go ahead and customize the dashboards in terms of adding different filters to it. We are not going to show that. Now you are getting some messages here, 2 unknown, 4 nulls. You can remove them as well. And here on the top you have the option to click on the presentation mode. There you go. So this is our final dashboard that we have created. Alright, so this brings us to the end of the second coronavirus data analysis project using Tableau. Now you can just click on escape to go back. Alright, now you can save this and this will be published in the Tableau public platform under your profile. So that brings us to the end of this video tutorial on COVID data analysis project using Python and Tableau. Welcome to this exciting video on Olympics dataset analysis using Python by Simplilearn. This is going to be a very interesting and interactive session where I'll give you a brief about the history of Olympics and throw some light into the recently held Tokyo Olympics. But we'll focus more on using Olympics dataset that is available on Kaggle and perform some exploratory data analysis. You will understand how to use different functions in Python to analyze and extract meaningful information. During the course of our discussion, I'll be asking you a few general questions related to the Olympics. Try to answer them in the comment section of the video. So let's begin. The Olympics is one of the biggest sporting events on the planet. It is held every 4 years. The first modern Olympics took place in Athens, Greece in 1896. As per National Geographic, the original Olympics took place in 776 BC, so they began as part of an ancient Greek festival which celebrated Zeus, the Greek god of sky and weather. The rings in the Olympics logo represent the 5 continents: Europe, Africa, Asia, the Americas and Oceania. From 1924 to 1992, the Winter and the Summer Olympics took place in the same year, but now they alternate every 2 years. Before I move on, here is an interesting question for you. Only 2 people have ever won gold medals at both the Summer and the Winter Olympics. Who are those 2 people? Please share your answers in the comment section of the video. We would like to know from you. The Summer Olympics in Tokyo began on the 23rd of July and recently concluded on the 8th of August. We got to witness some thriller matches that went down to the wire, some amazing victories, and sadly, there were a lot of heartbreaks as well. Winning and losing are part and parcel of any game. Fans across the world were really happy to see this global event happen this year following last year's postponement due to the coronavirus pandemic. With our Olympic fever high, let's take this opportunity to work around a project to perform exploratory data analysis using Python to analyze and visualize past Olympics data and answer specific questions. In this video, we will be using specific Python libraries such as NumPy, Pandas, Matplotlib and Seaborn to make sense of our data and extract meaningful information. We are going to visualize our results with different charts and graphs. Before I show you the dataset that we are going to use for our analysis, I have another general question for you. Which is the first Olympics where all the participating countries sent female athletes? I repeat, which is the first Olympics where all the participating countries sent female athletes? Put the year and the city name where the Olympics was held in the comment section of the video. We'll be more than happy to hear from you. Now, let me go ahead and show you the datasets that we'll be using in this video. So here you can see I have my Olympics dataset folder that has 2 datasets. These are CSV files. One is called the athlete_events and the other one is called NOC_regions. So we'll be using these 2 datasets. These datasets can be downloaded from Kaggle. We will post the dataset links in the description of the video. Please go ahead and download them. These datasets have been directly taken from the internet. Now I'll show you the datasets. So this is my first dataset. You can see on the top athlete_events. So I have around 15 columns. You can see the count here, and there are nearly 2,71,116 rows of information. So this is a huge data set that we are going to use. The other data set we are going to use in this demo is called NOC_regions. Now here one thing to note is NOC stands for National Olympic Committee. This is a 3-letter code that is given by the Olympic Committee. You have the region names, so AFG is for Afghanistan, you have ALB for Albania, ALG for Algeria. We have also a column called notes. You find some notes about the region. For example, here Antigua is actually Antigua and Barbuda. Alright, let's move to the first dataset that I showed you. This is our primary dataset for our demo. So these datasets have been directly taken from the internet and were not validated. So the results that you will see in the demo is purely based on the data that we have collected. So the file athlete_events.csv contains nearly 2,71,116 rows of information, and there are 15 columns. So each row corresponds to an individual athlete competing in an individual Olympic event. So here ID is actually a unique number for each athlete. Then we have the name, which is basically the athlete's name. We have the sex or the gender, which is male or F for female. Then we have the age of the athlete, which is in terms of integers. We have the height in centimeters of the athletes. Then we have the weight in kilograms. We have the team name. These are the country names. You have China, Denmark, Netherlands. There are around 200 country names. Then we have the NOC. As I said, NOC is a 3-letter code that stands for National Olympic Committee. We have the games. This games contains the year and the season. You can see here 1992 summer. You also have the Winter Olympic information. Alright. Then we have a specific year column to tell you in which year this event had occurred. Now the year column is also an integer column. We have the season, so whether it was Summer Olympics or Winter Olympics. Then we have the city name. This is the host city. Then we have the sport name. You can see here we have basketball, judo, football, tug of war, speed skating. There are so many. Then we have another column called event, which is the complete event name. As you can see, the sport name is basketball, but the event name is basketball, men's basketball, to be very specific. Again, for speed skating, you have different categories like women's 1000 meters, 500 meters. Alright. Now the final column is the medal column. So it has the information about the athlete, whether the athlete had won a medal, be it gold, silver, bronze, and NA means the athlete did not win any medals. So we'll use these two data sets. Now let's get started with the demo. We'll be using Jupyter Notebook for our analysis. So I'll take you to my Jupyter Notebook right away. I have opened it on Chrome. So this is my Jupyter Notebook that we are going to use. You can see here Olympics dataset analysis. I have already have a few cells that have been filled with some piece of code, and you can see there are some comments written as well. We are going to use this dataset. So let's get started. First and foremost, we'll import the datasets. So we are going to use NumPy, Pandas, Matplotlib, and Seaborn. Let me hit Shift Enter to import all the libraries. Alright. Now the next thing is to load the datasets using Pandas read_CSV function. So I'll create a variable called athletes. I'll say equal to pd dot. I'll use the read_CSV function, and inside this function we'll give the location of the files. So I'll copy this location and here I'll paste. Make sure this is within quotations, and these are all /. I'll give another /, and after that I'll give the file name, that is athlete_events.csv. I'll close the quotation. Let's run it. Okay. Similarly, we will load the second data set. I'll create another variable called regions. So it will have my data frame. I'll use the same function pd.read_csv. I'll just copy this file path till here. We'll paste it, and I'll give my second file name, which is noc_regions.csv. You can verify here. The first one is athlete_events. The second one is noc_regions. Okay, I'll close the quotation and we'll run it again. Okay, there seems to be some error. I think this is the regions. Cool. Now moving ahead, let's see the first few rows of both the datasets. I'll use the head function for that. I'll say athletes.head. So this will print the first 5 rows from my dataset athletes. You can see here from 0 to 4 you have 5 rows of information: the ID, name, sex or the gender, age, height, weight. If I go to the right, you have games, year, season, sport, event and medal. Now let's see the second dataset that we imported or loaded. I'll say regions.head. It says regions is not defined. Let me cross check it. Okay, I have taken it as region. Let's make it regions. Cool. Now let's run it. There you go. So these are the first 5 rows from our second dataset. You have NOC, region and some notes. Alright. Now the next step is to combine both the datasets. So we'll join the data frames using the pandas merge function. Let me show you how to do it. So this is going to be a horizontal join. I'll create a variable called athletes_df. Then I'll use my first variable, which is athletes. I'll say dot merge, which is my function name. I'm going to merge the regions data frame. I'll use the how parameter. In how, I'll give my value as I want to do a left join, and my common column in both the datasets is actually NOC. So I'm going to use the NOC column as my common column to merge both the datasets. Now let's go ahead and print the merged data frame. I'll say athletes_df.head. Let's run it. There you go. So if you see clearly, if I move to the right, you can see here we have added 2 more columns that were present in the second dataset, which was regions. So we have regions and notes added to my first dataset, that is athletes_events. Cool. Now one thing to note here is, see, the column names are not consistent. If you see here, the rest of the columns start with a capital letter, but if you see the last 2 columns that we just added now start with a lowercase letter. So we'll use the rename function to make the column names consistent. But before that, let's see the shape of the data frame. So I'll print the shape of the data frame to know the total number of rows and columns. I'll say athletes. If I hit tab, you will see it will give me the prompt. I'll select athletes_df. I'll use the shape attribute. Let's run it and see the result. You can see here it gives me the total number of rows. So 2,71,116 rows, and earlier we had 15 columns in the first dataset, and now that we have added 2 more columns, so the total number of columns becomes 17 now. Cool. So now it's time to make the column names consistent. So I'll show you how to do it. I'll say athletes underscore df dot, I'll use the rename function, and then I'll say columns equal to, I'll use curly braces, my first column, that is region, I want to change it to region, but the R should be capital now or uppercase. I'll give a comma and then say my second column, this should be region actually, my second column, that is notes, I want to change the first letter to uppercase, so I'll say capital N, the rest all remains same. I'll give a comma here and say in place equal to true. So it will change the column names and will reflect in this athletes underscore df data frame. Let's run it. Now to verify, you can again use the head function. I'll run this again. Let me scroll down and move to the right. You can see the difference. There you go. So we have successfully renamed the last two columns, region and notes. Alright. Now moving ahead. Now I'll show you how you can use the info method to print information about a data frame, including the index data type, the column data types, non-null values, and memory usage. So for that you just need to use the info function. So I'll write athletes underscore df dot info. Let's run it. There you go. So here we have the data columns. You can see total 17 columns. You have 2,71,116 rows or entries. Then you have the different column names, and it says non-null and the data type of the column. Below you can see some information about the memory usage. Alright. Next, the describe method is used for calculating statistical information such as mean, standard deviation, the percentiles of the numerical values of the data frame, and much more. It analyzes both numeric and object series and also the data frame column sets of mixed data types. So let me show you how using the describe function you can display some statistical summary. I'll just write describe and give parenthesis. Let's run it. Okay, if I scroll down, you can see here by default the describe function will only give information about numerical columns. So here you can see we have the total count, the mean of each of these columns, you have the standard deviation, the minimum and maximum value, and then we have the 25th percentile, the 50th percentile, and the 75th percentile value of the columns ID, age, height, weight, and year. Alright. Now one thing to notice here is, if you see the year column, the minimum year is 1896. So this is when Olympics started, and until recently the Rio Olympics that was held in 2016. Alright. Now moving ahead. Now let's check if there are any null values present in the columns of the dataset. So first I am going to create a variable called nan values, give equal to, I'll say athletes underscore df, and the function to check is, I'll say is na. I'll create another variable called nan underscore columns, and here I'll use the any function. I'll say nan underscore this variable which is underscore values dot, I'll say any, and I'll print my nan columns variable. So this will display the result in terms of Boolean values. So if there are any null or nan or missing values in any of the columns, it will say true, otherwise it will say false. let's display the result. There you go. So if you mark here clearly, so there are nearly 6 columns where we have missing values. You have age, height, weight, medal, region and notes columns that have missing values, so hence it has given us true. The rest of the columns do not have any NaN or missing values, hence they are false. Alright, let me scroll down. Now let's see the total number of null values for the above 6 columns. So I'll say athletes underscore df dot, I'll use the function is null, and again I'll use the sum function. Okay, this should be is null. If I run it, you can see it here. So our age column has 9474 rows where we have null values. Then we have some null values for the height column as well, for the weight column. So these are the total number of rows where we don't have any information regarding age, height, weight or region. Notes, this medal is self-explanatory because a lot of the athletes who participate in Olympics don't win any medals, so for them the value is NA. Now before I move ahead, I have a question for you people. So the question is, I want you to print the column names containing null values or missing values in the form of a list. So please answer this question and put it in the comment section of the video. We would be happy to know your approach. So the question, I'll repeat it again. I want you people to print the column names containing null values or missing values in the form of a list. So basically on the top we saw there were 6 columns that had null values. I want you to print these 6 columns in the form of a list. Alright, now moving ahead. Now let's see the data for specific countries. Let's say you want to see the athletes who have participated in the Olympic Games from the beginning for India. For that, you can filter your result using a function called query. So let me show you how to do it. I'll say athletes underscore df dot, we'll use the query function, and then I'll say team, which is my column name, should be equal to, and the value I'll give is India. Now let's display the first 5 rows of information or the details for the athletes who are from India. If I run this, okay, there is some error here. Okay, so we need to make sure this entire expression or the condition should be within single quote. I'll just delete this single quote from here and we'll add it in the end. Now let's run it. There you go. So here you can see we have the top 5 rows of the athletes who are from India. You can see here the region is India, you can see the NOC is India, the team is India, and let me go to the left. You can see the name of the athlete, the sex, age. So for age you have some missing values, you have the weight, team, year and everything. Alright, similarly you can also check for Japan. Let me just copy the above code, I'll paste it here, and instead of India I'll say Japan. I'll run it. There you go. So if you see here, you can see all the details are for the athletes who are from Japan. Alright, now moving ahead. Now I want to know the top 10 countries who have participated since the inception of Olympics in 1896. So for that I'll create a variable called top underscore 10 underscore countries. I'll say equal to I'll use my data frame, that is athletes underscore tf. I'll say dot team. Then I'll use the function value underscore counts. I'm going to sort my count in ascending order. Just mark the way in which I'm writing the functions. Any error in terms of syntax or the flow will throw you an error. I want to display the top 10 countries. Now let's go ahead and print it. I'll say top underscore 10 underscore countries. Alright, let me run it. Okay, it has given us an error. Let's debug it. Okay, so this should be value counts and not count. Let's run it again. Another error. Okay, so this should be short underscore values and not value. Let's run it again. There you go. So here you can see the top 10 countries participating in Olympics since 1896. You have United States, then we have France. So these are the number of participants who have taken part since 1896. So the most number of participants have come from US, then we have France, Great Britain, Italy, Germany, Canada, Japan, Sweden. We also have Australia and Hungary. I'll scroll down. Now we are going to convert this table that we got, or the output that we got, in the form of a graph. So I'm trying to create a bar plot to plot the top 10 countries who have participated in Olympics. So here I'm using the figure function to give the figure size. So these are the dimensions 12,6. Now I'll tell you what this pltxtix means. Just wait for a while. I have given a title to my plot saying overall participation by country, and then using the Seaborn library and the bar plot function, I am plotting the x and the y-axis. So my x-axis has top. I should make this top 10 countries because above we used top underscore 10 underscore countries. Similarly for y-axis, I'll make it top underscore 10 underscore countries, and then I'm using a color palette called set2. Let's run it. There you go. So if I scroll down, you can see here we have a nice bar plot. This is a vertical bar plot, and here you can see the bars which represent the different country names. First we have United States, which has the highest participation since the beginning of the Olympics. Then we have France, Great Britain, Italy, Germany, Canada, and we have the rest of the countries. Cool. Now moving ahead, the next visualization we are going to see is the age distribution of the athletes. So for this, we are going to create a histogram. I'll be using the matplotlib library specifically for this visualization. So I'll say plt.figure. We'll give the figure size using the argument fig size equal to, and this will be a tuple actually. My size is going to be 12,6. I'll say plt dot title. Now you can give any title that you want. I'll say age distribution of the athletes. Then we'll also give the x labels. I'll say plt dot x label. This will have age. Then we'll say plt dot y label, and this will have the label as number of participants. Next, I'm going to use the hist function. So I'll say plt.hist, and I'll pass in my data frame, that is athletes underscore df dot age, which is my column name, comma, I'm going to pass in the bins. For that I'm going to use the np.arange function. So np is for numpy, and inside this I'll say 10 comma 80 comma 2. So my bins will start from the value 10 and go until 80 with a size of 2, comma, I'll give another parameter that is going to specify the color of the bins. I want my color to be orange, and then I'll use the edge color to separate the bins. I'll say edge color, this is the parameter or the argument name, and the color I want is white. Let's give a semicolon here, and this should be edge color. There's a spelling mistake here. Now let's run it and we'll see the output. So there you go. So this is a nice histogram that shows the distribution of the age of the athletes. You can see the title age distribution of the athletes. On the y-axis you have the number of participants. On the x-axis we have the age values ranging from 10 to 80 with a size of 2. And if you see this, we have most number of athletes who have an age between 20 to 30. You can see here. So early 20s we have maximum number of athletes participating in the Olympics. We also have a few athletes who are beyond 40 years of age. You can see here we have a few athletes even closer to 60 also, and similarly we have a few athletes who are under 18 years of age. Alright, now you can see here the bins we had taken orange color, so all the bars are represented in orange color, and the edge you can see here we have the white color. Alright, now moving ahead. Now in the initial slides of the video we discussed the summer and winter Olympic Games. Let's look at the different sporting events that are part of the summer and winter Olympic Games. Just to give you a heads up, the winter Olympic Games are held once every 4 years for sports practiced on snow and ice. So here I have my variable name winter underscore sports, so I'm extracting for season equal to winter, and I am going to display only the unique values. Now let me run this cell. Okay, so you can see here these are the different winter sports that are held during the winter Olympics. Now similarly, let's see for summer Olympics. So what I'm going to do here is I'll just copy this cell of code and we'll edit the variables. I'll say summer underscore sports, athletes underscore df remains the same. Here season we'll change it to summer, dot sport dot unique remains the same, and here I'll say summer underscore sports. This should be small. Now let's run it. There you go. So here you can see we have more number of Olympic sports that are held during the summer Olympics compared to winter Olympics. So these are the sports that are played on snow and ice, and these are the sports that are played during summer. Moving ahead, now it's time to analyze the total number of male and female participants who have taken part in different games since 1896 till 2016 Rio Olympics. Alright, so I'll say gender underscore counts, which is my variable name. I'll use my data frame, that is athletes underscore df dot my variable name, that is sex, dot value underscore counts, and then we are going to print gender underscore counts. Let's run this. There you go. So since the inception of Olympics we have more number of male participants than female participants. Now here in this current cell, you can see we are trying to plot a pie chart for male and female athletes. So I have given my figure size, then I have my title as gender distribution. I'm using the matplotlib library and the pie function. I'm using the variable gender counts that we used here. Then I'm giving my labels as gender underscore counts.index. Now I'm using this auto PCT. The auto PCT parameter enables you to display the percent value using Python string formatting. So this is my string formatting that I have used, and I'm initialized my start angle for the pie chart as 150 degrees, and I'm also giving shadow to my pie chart. So I have written shadow equal to true. Let's run it. Alright, so you can see here this is my pie chart that shows you the distribution of the male and female participation. So for male it is 72.5%, for female so far it is 27.5% as per the dataset that we have. Now you can change this start angle to, let's say, 180 degree, and it will change the pie chart to this direction. Cool. Now moving ahead, this time we are going to find the total number of medals that the athletes have won. So I'll use my data frame athletes underscore df dot, and then my column, that is medal, I'll say dot value underscore counts. Let's run it. There you go. So you can see the gold medals, the bronze medals and the silver medals are very much similar to each other. The numbers are pretty much the same. Alright, now it's time to focus on the total female athletes who have taken part in each Olympics. So I'll create a variable called female underscore participants. I'll say equal to, and then use my data frame name, that is athletes underscore df. Using square brackets, I'll say athletes underscore df dot, the gender should be equal to female, and I'll use ampersand. I'll say, just copy this, paste it here. I'll say dot season equal to, we'll check for Summer Olympics, and I want to extract only the gender column. So here it is sex, comma, my year column, which is year. Okay, and then I'll say female underscore participants equal to, I'll just copy this, paste it here, and then I'll use the group by function. Say group by, which is part of the pandas library. I'll say year, and then I want to find the count. I'll reset the index, say reset underscore index. Alright, now we'll run it and see the result. There you go. So you can see here from 1900, 1904, all these years you can see the female participation. Let me change it to tail so that we have the recent data of the Olympics. You can see it here. For the Beijing Olympics, 5,816 women athletes participated. In 2012 London Olympics, we had 5,815 Olympics. Similarly, for the 2016 Rio Olympics, we had more participation than the London Olympics. So 6,223 women athletes had participated. Alright, now here this is another way in which you can filter your data for female athletes. So I'm using two parameters. My gender should be equal to female, and season is Summer Olympics. Let me just run it. I have stored it in a variable called Women Olympics. Now here I am trying to find a count plot, or I am trying to create a count plot using my Seaborn SNS library. I have set my style to dark grid. Then my figure size I have given as 20,10. My count plot will have the x-axis as year. The data is Women Olympics, and palette I'm using as spectral, and then I've given a title Women Participation. Let's run and see the output. There you go. If I scroll down, you can see on the top I have the title for my count plot, which says Women Participation, and on the y-axis I have the count, and at the bottom you can see the different year values from 1900 till 2016, and 2016 had the highest number of female participation. Cool. Let me scroll down. So in this cell of code we are trying to plot a line graph. Let me run it and show you the output. So this line graph shows the trend, which says plot for female athletes over time. So here you can see the line graph. So gradually the women participation has increased in Olympics since its inception. There was a slight decrease here. This is around 1950s, and again you can see here there's a decrease with the women participation in 1980, but since then, since 1980, there has been continuous increase in the participation of female athlete numbers. Cool. Now coming to the next section of our analysis, now we are going to filter the data to see the details of the athletes who have won gold medals. So I'll create a variable called gold medals. It's equal to, I'll use my data frame as athletes underscore df, and within parenthesis I'll use my data frame name, which is athletes underscore df dot, I'll use the condition medal equal to, and my value would be gold. Next, I'm going to say gold medals dot head. Let's run it. There you go. So here we have the top 5 rows of the athletes who have won a gold medal. You can see all the records have medal as gold. Now we are going to use this subset of the data and perform some more analysis. So here I want to take only the values that are different from NaN. So I'm going to use is finite function, and inside that I have set gold medals age. Let me just run it. Cool. Now I want to see the athletes who have secured a gold medal beyond the age of 60 years, which is very rare. So we'll see the total number of athletes with more than 60 years of age having won a gold medal. So here I'm going to say gold medals. I'll use my column as ID, and then I'll use my variable gold medals, and then I'll say age should be greater than 60, and then I'll close my square bracket and say count. Okay, let me just verify if everything's fine. Yeah, I'll run it and we'll see the result. So there are total 6 athletes who have won a gold medal having age more than 60 years. Cool. Now let me check for which sport these 6 gold medals have come. So I'll say sporting underscore event, this is going to be my variable name, equal to, I'll use the same variable name, gold medals. I'll going to choose my sport column, and then I'll give my condition age greater than 60. Now let's go ahead and we'll print the variable sporting event. If I run this, you can see it here. So for art competitions, even for archery and shooting, and this one called rook, we have had gold medals from athletes who had an age more than 60 years. Now we are going to plot this result or the table that we achieved on the top. So I'll say plt dot figure. I'll give my figure size equal to, let's say 10,5. Then I'll say plt dot, we'll use the tight layout, say tight underscore layout. Then I'm going to use the Seaborn library and create a count plot for my variable sporting underscore event. Then I'll say plt dot title. I'll give the title as gold medals for athletes over 60 years of age. Let's run it, and if I scroll down, you can see here we have a nice count plot. I have my title gold medals for athletes over 60 years, and since for archery we had 3 players who secured a gold medal having an age more than 60 years. You can see here archery is 3, art competition 1, rook is 1, and shooting we had 1 medal. Alright, now we'll see the total gold medals from each country. So for that I'll say gold medals dot, we'll use the region column, and followed by that I'll use the value underscore counts function, and I'll reset the index with name equal to, I'll provide the medal column. Then we are going to print the head for the top 5 countries. Let me run it. You can see it here. So USA has secured the most number of gold medals. Then we have Russia, Germany, UK, and then we have Italy. Cool. Now in this cell I am going to create a plot to visualize the table that I got above. So I've used my labels, my titles. I'm using the cat plot function that is present in the Seaborn library. I have my x-axis, my y-axis, the data which is total gold medals. Let me just verify. Okay, and we'll run it. If I scroll down, you can see this is a different palette that I had used, which is a rocket, and you can see USA has got the most number of gold medals. Then we have Russia, Germany, UK, Italy, and France. Now we also have included France here, which was not present in this table. The reason being I have used head as 6, so it will give me the top 6 countries. Alright, now we will analyze and look at the data for the most recent Olympic event that is present in our dataset. I'm talking about the 2016 Rio Summer Olympics. So first of all, I'll create a variable called max year, which will be equal to my data frame name athletes underscore df, my column name year, and I'll use the max function. Then let's go ahead and print my max year. I'll just show you the output. You can see here my max year present in the dataset is 2016, the Rio Olympics. Next, we will create another variable called team underscore names that will be equal to my data frame name athletes underscore df. Within square brackets, I'll give parenthesis and then say athletes underscore df dot year should be equal to my output, that is max year, which is actually 2016, and then I'll say ampersand. I'll just copy this, we'll paste it here. This time I'll use the medal column and say equal to gold. I'll say dot team. Then I'll say team underscore names dot value underscore counts dot head, and will display the top 10 countries. Let me run this. There you go. So in Rio Olympics, United States secured the most number of gold medals. Now the reason this is 137 is we have also counted the team events, for example basketball. Similarly, Great Britain had 64 gold medals in total, Russia 50, we have Brazil 34, Argentina 21, France 20, and Japan 17. Alright. Now using the above result, we are going to create a bar plot. I'll just change this team underscore list to team underscore names. Similarly here also I'll make the corrections as team underscore names. Cool. Now we'll run it, and you can see here we have a nice horizontal bar plot. So we have United States at the top, Great Britain, Russia, Germany, China, Brazil. So here I am displaying the top 20 nations since I have used head as 20. So these are the top 20 nations who secured the most number of gold medals in the Rio Olympics. Alright. Now in the final section of this video, we will create a scatter plot to visualize the height and weight of male and female athletes who have won a medal. Now it can be a gold medal, a silver medal, or a bronze medal. But before that, we need to filter the data only for athletes who have won a medal. Now if you had noticed here, our medals column also had a few null values, so we are not going to consider those null values here. We are only going to consider for the athletes who have won a medal. So for that, I'll create a variable called not underscore null underscore medals equal to, I'll say athletes underscore df, then I'll give my, let's make it df, I'll give my condition. Let me just copy this, I'll paste it here, and then I'll give my condition height and use the not null function, and then I'll say ampersand, create another parenthesis. I'll say athletes underscore df. This time we'll consider the weight column. Again, I'll use the function as not null. And I'll close the parenthesis. Okay, I had missed one S here. Cool. Let me just run it now. Alright. Now we are going to create our final plot. I'll say plt.figure. I'll give my figure size equal to, I'll say 12,10. I'll say axis equal to SNS dot. We'll be creating a scatter plot to plot the height and weight of the athletes who have won a medal. I'll say scatter plot. In my x-axis I'll have height, comma. In my y-axis I'll have weight, comma. My data should be not underscore null underscore medals. So this is what we created here, not underscore null underscore medals, comma. I'll use hue equal to my sex column. Cool. Finally, I'll say plt dot, I'll give a title to my plot saying height versus weight of Olympic medalists. Cool. Now let's see our scatter plot. This might take some time to give the result because there are so many athletes present in a dataset who have won a medal, and also we are filtering in terms of hue, which is for male and female. There you go. So if I scroll down, you can see here we have a nice scatter plot. On the top we have the title of the plot saying height versus weight of Olympic medalists. You can see our age as the hue. So blue points are for the male athletes and orange points are for the female athletes. And on the y-axis we have the weight in terms of kilograms, and you have the height in terms of centimeters. Cool. So that brings us to the end of this demo session on Olympics dataset analysis. So we used two datasets to carry out this exploratory data analysis, and we created some visualizations to analyze and visualize the data. Alright. So that brings us to the end of this video tutorial on Olympics dataset analysis. Indian Premier League, that is IPL, is one of the most popular and exciting events in world cricket. IPL 2022 will begin on 26th of March, so it's the best time for us and our viewers to learn about how to perform exploratory data analysis using the recently held IPL auction dataset. So in this video, all the results and insights that you will see are totally based on the data we have collected from Kaggle. We will leave a link to the dataset in the description of the video. You can go ahead and download it. For this demo, we'll be using Python and Jupyter Notebook to answer specific questions. So let's get started. We'll move over to our Jupyter Notebook. Okay, so I'm on my Jupyter Notebook and this is the file that we are going to use. So here you can see I have some of the cells already filled in. So this will save us some time and we can explore this dataset in depth. So this is the file that I'll be using, or the IPython notebook. Cool. So first let's go ahead and import all the crucial libraries that will be needed for our analysis. So here you can see I am importing the pandas library, the numpy library. These are for data manipulation and numerical computation. Then we have seaborn and matplotlib for data visualization. Then I have imported this warnings module so that we do not get any warnings while running the code. Cool. So let me just hit Shift Enter to run the first cell. So here we will import all the libraries. Okay, it's done. Now the next step is I'm going to create a data frame in the name of IPL, and here I'm importing the dataset using the read_csv function, which is part of the pandas library. So PD here has been imported as pandas. I'm giving the dataset location followed by the name of the dataset. So here the name is IPL_2022_dataset.csv is the extension of the file. So let me go ahead and run this as well. Alright, so now we have successfully imported or loaded our dataset. Now the next step, let's go ahead and explore our dataset. So I'll use the head function for this, IPL.head. Okay, so here you can see the different columns. We have an unnamed column which is actually unnecessary for our analysis, so we'll see how to drop this column. Apart from that, we have the name of the players, the base price at which the player was sold, or whether the player was a draft pick. So here Rashid Khan from Afghanistan, Hardik Pandya, then we have Subman Gill. These are all draft pick, and then we have the price at which the players were listed in the IPL auction. Then we have the type of player, whether the player is a bowler, an all-rounder, a batsman, or a wicket-keeper. Then we have the cost in rupees. This is in crores. So basically this column tells us the price at which the player was sold in the auction. Then we have the price or the cost in dollars. After that we have 2021 squad. Basically this means in last year's IPL, where was the player? So here you can see Rashid Khan was playing for SRH, the Sunrisers Hyderabad, in 2021. But this year in 2022, he'll be playing for Gujarat Titans. Similarly, Hardik Pandya was playing for Mumbai Indians for past few seasons, including 2021. But this season is going to play for Gujarat Titans. So on and so forth. Now, let's see the total number of players that are present in the dataset and the total columns that are there. For this, I'm going to use the shape attribute. So I'll write IPL.shape. You can see here there are total 633 players that were part of the auction, and this includes the players who were draft pick also. And there are total 8 columns in my data frame IPL. Next, let's use the info function to check the columns, the data types, and the total non-null objects. So I'll say IPL.info, which is a function, so I have to use brackets. There you go. So here you can see it says total 633 entries from 0 to 632. Data columns, we have total 8 columns, and then these are the different column names, and here you can see the total non-null objects present in the column, and here you can see the data types, and at the bottom you can see the memory usage as well. Cool. Now the dot columns attribute will return the name of the columns in the dataset. So if I say IPL.columns and run it, it will give me all the different column names that are present in the data frame. Now, as I said, the first column, which is unnamed :0, is actually unnecessary. So we are going to drop it. For that, we are going to use the dot drop function, and then I have passed in my column name followed by the axis, on which axis is it there, and then I say in place equal to true, which means it will replace and permanently remove the unnamed column from the data frame. So let's run it, and now we'll again check the head of the data frame. You can see before we had the unnamed column, which was the first column in the data frame, and now we have successfully removed it. So player becomes the first column in the data frame. Alright, now moving ahead, let's see the total number of null values that are present in each column of the dataset. So I'll say IPL dot, I'm going to use the isNull function followed by the sum function. If I run this, you can see here the player column doesn't have any null values. Similarly, base price and type column also don't have any null values, but you can see cost in rupees and cost in dollars have nearly 396 missing or null values. The reason being those players were not picked in the IPL auction and hence there was no price associated. And then you can see there were a few players who were not part of the IPL squad in 2021. So those are being reflected as null as well. Now we'll check the rows that have cost in dollar as null or NaN. So here I have used IPL and after that I'm passing in the column name which is cost in dollars and then I've used the isNull function. If I run this, you can notice the cost in dollars column, all these values are NaN or null, and even the same rows have NaN for cost in rupees as well. Cool. Now the next task is to fill these null values or NaN values with zeros. So for that I'm going to use the fill NA function and here I have passed in 0. So all the null values in the dataset will be replaced with 0 for cost in rupees column and cost in dollars column. Let me just run it. Alright. Okay. Now we will see the players who were unsold in the 2021 auction, which means we will check the rows that have null values for the 2021 squad column. So what I'll do is I'll say IPL within square brackets, I'll say IPL and then I'll pass in my column name which is 2021 squad and then after this I'll say dot is null. So this cell will give us the unsold players in the 2021 auction. If I run this, you see here you mark the 2021 squad column, all these players were unsold or did not participate, so hence it has NaN values. Alright. Now what we are going to do is we will replace all the null values that are present in the 2021 squad column with not participated. Like how we did in the previous example, we replaced all the null values with 0. Here we'll replace with a text value called not participated. So I'll say IPL, I'll pass in my column name which is 2021 squad equal to, I'll say IPL 2021 squad dot fill NA, which is the function, and here I'll pass in a text or a string saying not participated. Alright, let's run it. Before that, let me just scroll it down. Now I'll run it. Cool. Now that we have treated the null values successfully, let's verify it again. So I'll just say IPL dot is null and then I'm going to use the sum function. If I run this, okay, this is also a function. Cool. Now if you see, we have successfully removed all the null values and replaced with either zeros or not participated, and hence now you can see none of the columns in the IPL data frame have null values, so it shows 0. Great. Now moving ahead. Now we are going to add another column called status, which will hold two values, sold and unsold. But before that, we are going to slice our data frame. So here I am looking for all the rows where cost in rupees is greater than 0 and those should be unique, and I'm storing the value in a variable called teams. So here you can see we have the different teams where the cost in rupees is greater than 0. Now I'm going to create another column called status. So I have written IPL within square brackets. I'm passing in the column name, which is status, and that will be equal to the team replaced by sold value. Let me just run it and show you the result. There you go. So here you can see we have added a new column called status, and it has values sold and unsold. If I just say IPL, at the bottom you can see the unsold values as well. Cool. Now in the next cell, we are going to check for duplicated players. So there are duplicate rows in the data frame, but here the names of the players are same, but in reality the players are different. So it is quite understood that different players can have the same name. So to get those names, I am using the duplicated function, and I'll say keep equal to false, which means I don't want to keep those players. Now let's run it. There you go. So here you can see Lalit Yadav, we have 2 entries. So Lalit Yadav here is an all-rounder whose base price was 20 lakh for 2022 IPL, and last year he was playing for the Delhi Capitals, and this year also he is sold to Delhi Capitals. Next we have Lalit Yadav, who happens to be a bowler. So this is again different Lalit Yadav. So last year he was unsold, and even this year he remains unsold. Similarly, we have Amit Mishra, who earlier used to play with the Delhi Capitals, but this time he remains unsold, so on and so forth. So you can see 2 entries for Subham Singh as well and Shivam Mishra. Alright. Now let's answer a very basic question. We're going to find out how many players have participated in the 2022 IPL auction. For that, we have already seen the total number of rows that were present, but again I'm going to use the shape function, and within square brackets I'm going to say 0, which means it will give me the total number of rows, and you can see 633 players were part of the auction. This is as per our data that we have collected from Kaggle. Up next, we are going to find how many types of players have participated. So I'm going to say types equal to, say, IPL. I'll use the column name, which is type, and I'm going to find the count of each type of players that are present in the data frame. I'm going to use the values underscore counts function, and then I'll say types dot reset underscore index. If I run it, okay, there is an error here. Let me debug the error. Okay, so this should be value underscore counts, and the variable name is types and not type. So let's run it. You can see here we have the different types of players. So all-rounders, there are total 242 all-rounders who are part of the auction. Then we have 215 bowlers, 112 batsmen, and 64 wicket keepers. Now using the above table that we just created, I'm going to plot my first pie chart. So for that I'm going to use the matplotlib pie function. So plt.pie, I'm using types.values since I want only the values from this table, and then I'm saying labels equal to types.index. I've used a label distance of 1.2 to maintain some space, and then this is my format in which I want to print or show or display the percentage of distribution. I am going to use shadow So it says shadow equal to true, which is another parameter or an argument. And then I'm going to start my angle at 60 degrees. And here I have used a title called roll of players participated that will have a font size of 15. And finally I'm saying plt.plot. So let me just run it. There you go. So here we have a nice pie chart or a pie plot. So you can see the different pies here. We have all-rounder, wicketkeeper, batter and bowler. So majorly there are all-rounders in the auction followed by bowlers. Then we have 17.69% batters and 10.11% wicketkeepers, which is the lowest. Cool. Now we are going to create another bar plot or a bar graph that will tell us how many players were sold and unsold. So for this I'm going to use a count plot. So we'll create two bars, one for sold and the other one for unsold, and each of the bars will have different colors. One will have orange, the other one will have pink, and I'm using labels. So to label the x-axis and y-axis, I have sold or unsold. Y label will have number of players. The title of my bar graph would be sold versus unsold. I've given a font size of 15 and I'm saying plt.plot. Now the function that you see here at the bottom will display the data labels for each of the bars. Let me just run it and show you the result. There you go. So I have used a figure size of 10,5. Alright, now you can see we have a really good bar plot which says there were total 237 players sold and 396 players were unsold as per the data we have. Cool. Now you can also print the total sold and unsold values. Let me show you how to do it. I'll say IPL dot, we can use the group by function, and I want to group it by status column, and the value that I want to measure is the players count. So I'll say players, rather player, and then I'm going to use the count function. If I run this, you can see here I've successfully grouped the unsold and sold players. The values are matching with the bar plot that we just created. So sold were 237 players and unsold are 396. Cool. Now we are going to see the total number of players bought by each team. Again, this is going to be a count plot, so basically a bar plot. So here the condition I'm passing is in the teams column the value shouldn't be unsold. So players bought means the value should be sold. So here I'm using this condition and the rest of the things remains the same. One improvement I have done here is I'm using x-text rotation equal to 70 degrees. This basically means the x labels would be tilted by 70 degrees. Now let's see the bar plot. There you go. So here you can see I have the title players bought by each team. On the y-axis we have the number of players, and on the x-axis you can see the values have been tilted by 70 degrees. Let me just zoom in so that you can see it better. And this is the bar plot. So the maximum a team can purchase is 25 players. Some of the teams have also purchased 24, 22 and 23 players. Let me just show you. So Gujarat Titans have totally purchased 22 players. Then Delhi Capitals have total 24 players in their squad. Again, Lucknow Super Giants have 22 players. If I scroll and see again, Bangalore Royal Challengers or RCB, the Royal Challengers Bangalore have 22 players in the team, and Rajasthan Royals and Sunrisers Hyderabad have 24 and 23 players respectively in their teams. Alright, now we will create 3 more columns called retention, base price and base price unit. For that, first of all I am creating a new column called retention, which is equal to IPL base price. Let me just run it. And then I'm going to replace these values that are present in the list, 2 crore, 40 lakh, 20 lakh, 1 crore, 30 lakh, 1.5 crore with from auction. And I'm saying in place equal to true. Let me just run it. Then we are going to treat the base price. So here in the base price column, I'm going to replace draft pick value as 0. So let's run that as well. And now I'm going to split the base price value into two separate values called base price unit and base price. So basically I'm splitting on the space that I have. Let me show you how it is going to split. So this is, let's say, our base price column. What I did was I replaced the draft pick values to 0, and then the rest of the values will be split into two columns called base price unit. So basically it will have the unit of the base price, let's say crores or lakhs, and the base underscore price column will have the value, which is 2, here 40, 20, 20, so on and so forth. Let me just scroll down and run that particular cell. Now to create these two columns, the base price unit column and the base underscore price column, I have used the lambda function and I'm splitting based on the space. Let's just run it. Now I have replaced retained with 0, and let me show you the final data frame that I have. So here you can see we have replaced the draft pick values in the base price column to 0, and on the right side you can see the three different columns that I wanted to create. So one is called retention. So zeros refer to draft pick. Any other value will say the player was picked from the auction. Then you have the base price unit. So here you can see crores, lakhs, and the value base price is 2, 40, so on and so forth. Cool.
Choose from over 300 in-demand skills and get access to 1,000 plus hours of video content for free. Visit SkillUp by Simplilearn. Click on the link in the description to know more.
Now let's check how many players were retained and bought from the auction by each of the teams. So I'll say IPL, let me just scroll down, dot, I'm going to use the group by function. Then I'll say team, comma, retention. Then I'm going to use the value as retention because I want to find the count of retained players. And then I'll say colon -1. Let me run it. You can see here the different team names because I have grouped by team and then retention. So I have Chennai Super Kings. From the auction they had picked 21 players and they had retained 4 players. Coming to Delhi Capitals. Delhi Capitals in the 2022 IPL auction, they picked total 20 players and they have retained 4. Similarly, if I scroll down, let me talk about, let's say, Punjab Kings. They have picked 23 players from the auction and retained 2 players from the team last year. Talking about RCB or Royal Challengers Bangalore, they have picked 19 players from the auction and they have retained 3 players. All right. Now in the next cell of code, we are going to display the players in each team based on the different types of players. So let me just run it and show you the result. So here I am using the same condition. The value shouldn't be equal to unsold, and I'm going to use another parameter called hue for the different colors. So here I have used hue as type because I want to show the players in each team based on the different types. Again, I have given my title to the bar plot, and then I have the X label, the Y label, and my rotation is 50 degrees now. If I scroll down, you can see the different types of players. Here is the legend. So blue is for bowler, orange or yellow is for all-rounder, green is for batter, and red, which also looks like maroon, is for wicket keepers. And on the x-axis you can see the different team names. Alright, now let's answer another couple of questions. So here I have, what is the highest amount spent on a single player by each team? So to solve this question, I'll say my data frame name, that is IPL. Then I'm going to say retention equal to this should be from auction, because we want to see the highest amount spent and not from the retained players. Then I'm going to group by, I'll say team, and then I'll say cost in, let me just copy it from here, cost in rupees, that is in crores, and I'll say max colon -1 dot sort underscore values, I'll say ascending equal to false, which means I want the sorted result in descending order. Okay, let me just bring this to the left side and we'll run it. There seems to be some error. Let me check the error. It says there's a spelling mistake. This should be team. Let me run it again. There you go. So you can see Mumbai Indians have spent 15.25 crores for one of the players, and this player happens to be Ishan Kishan. Then Chennai Super Kings have spent the highest amount for a player who happens to be a bowler. The name is Deepak Chahar. They have bought him for 14 crores. Kolkata Knight Riders bought Shreyas Iyer for 12.25 crores, and so on and so forth. So these are the highest amounts spent on a single player by each of the teams. Let me scroll down. Now we are going to see the player retained at maximum value or maximum price. Now if you follow IPL, the maximum price at which a player was retained happens to be Ravindra Jadeja. So let's see at what price was he retained. I'll say retention equal to I'll say retained, then I'll say sort underscore values by equal to, I'll use the same column, cost in rupees, that's in crores. I'll say ascending equal to false dot head, and I want to find the top player. Again there's some error. Let's see where is the error. It says ascending equal to false dot head. Okay, this should be sort underscore values, within bracket I should say by. I think this should be fine now. Let's run it. There you go. So you can see here our result is player name Ravindra Jadeja, who was retained for 16 crores by Chennai Super Kings. Cool. Now the next cell of code will display or print the top 5 bowlers who have been picked in this year's IPL based on their cost in INR. Let me just run it and show you the result. You can see here Deepak Chahar went for 14 crores. Then we have Shardul Thakur, who was bought by Delhi Capitals. Earlier he was part of CSK for 10.75 crores. Then we have Prasidha Krishna, who has been bought by Rajasthan Royals this time. Last year he was with KKR and he has been bought for 10 crores. Similarly, Lockie Ferguson has been bought by Gujarat Titans and he played for KKR last season. He has been bought for 10 crores while his base price was 2 crores. Then we have Avesh Khan. You can see Avesh Khan's base price was just 20 lakhs and he has been bought for 10 crores by Lucknow Super Giants again. And last year he was part of the Delhi Capitals. Now you can replace this value. Suppose, let's say you want to find the top 5 batsmen picked or batters picked with the highest amount. You can just say batter instead of bowler, and if I run this, you can see here Shreyas Iyer was bought by Kolkata Knight Riders for 12.25 crores. Last year he was part of Delhi Capitals. Then you have Shimran Hetmeyer, who's from West Indies. He has been picked by the Rajasthan Royals for 8.5 crores. Then we have Rahul Tripathi, Shikha Dhawan and Devdutt Padikkal. Now if you wanted to check for, let's say, all-rounders, you can replace batter with all-rounder. If I run this, you can see Liam Livingstone has been bought by Punjab Kings this season for 11.5 crores. His base price was just 1 crore and last year he was part of the Rajasthan Royals. Then we have a player from Sri Lanka, Hasaranga. Then we have Harshal Patel, Shah Rukh Khan and Rahul Tewatia, who have been the top 5 all-rounders picked at highest amount. Cool. Now finally, we want to see the players who were part of the IPL last season but were not picked for this year's IPL. So for that, what I'm doing is, first I'm renaming my 2021 squad column. This column I want to rename it as previous team. Let's run it. Then I'm going to find out the unsold players. So here I'm saying previous team not equal to not participated, and then I'm using another condition. The team should be equal to unsold, and I'm going to find out only the player and the previous team. So let's run it and see the result. So here you can see these players were part of the IPL last season but they haven't been picked this season, and last season they had played for, let's say, Suresh Raina played for CSK, Steve Smith was part of the Delhi Capitals, Saqib Al Hasan was part of KKR. If I scroll down, you have David Malan, who played for Punjab Kings in 2021, Owen Morgan, who played for KKR. He also captained KKR but unfortunately he was not picked this season. Chris Lane from Australia also remained unsold this season. Andrew Tye, we have Ben Cutting, Aditya Tare. There are other players as well. We have Kane Richardson, Dhaval Kulkarni. Cool. So these were the players who were part of the IPL season 2021 but unfortunately were not picked and remained unsold for 2022 season. Cool. And that brings us to our end of this demo session on IPL Data Analysis 2022. So we learned how to use the different functions and attributes that are part of the Python libraries, and we manipulated the data, we visualized the data and answered some specific questions. In this video, we'll be using 4 publicly available datasets about Formula 1 that has information from 1950 to the 2019 F1 season. We'll see how using the Python libraries you can perform exploratory data analysis and draw valuable insights. So let's begin by understanding what Formula 1 is. Formula 1, also known as F1, is a motorsport defined by open-wheeled single-seat race cars. It features the best drivers in the most powerful and technically advanced cars. The sport is governed by the FIA, that is International Automobile Federation. Here 10 teams comprising of 2 drivers each compete in a series of races over a period of 1 year to find out the ultimate driver and a constructor champion. In our demonstration, we'll be using 4 datasets. Let me show them one by one. These are all CSV files. Now this is the first dataset that we'll be using in our demo. So if you notice, the dataset does not have column names. In fact, none of the datasets have column names. So while importing the dataset, we'll assign the column names using the names parameter. I'll show that in a while. Now this is the results dataset. The results dataset has information about the result ID. Then we have the race ID, driver ID. We have the constructor ID, grid, position. Then we also have information about the fastest lap. Then we also have information about rank, the fastest lap speed, and the status ID. Now moving on to the second dataset, which is about races. Now this is the second dataset which is about races. So it has information about the race ID, the year in which the race was held. Then we have the round number, circuit ID, then the name of the Grand Prix. So you can see here Australian, Malaysian, Chinese, Spanish, Monaco, Turkish, British, German, and others. Then we have the date on which the GP was held or the Grand Prix was held. We have the time and a URL which basically leads to the Wikipedia page of that particular Grand Prix for that year. Now moving on to our third dataset. So this is our third dataset which is about drivers. Now it has the driver ID, the name of the driver. You can see here Hamilton, Rosberg, Alonso, Raikkonen. Then we have Sato, Massa, Button, Weber, and all. After that we have the number code. Then we have the forename of the driver, the surname of the driver, and then we have the date of birth of that particular driver. We have the nationality as well. And we have the Wikipedia page for the driver. Now moving on to the last dataset, which is about constructors. So this is the fourth and the final dataset that we'll be using in our data analysis project. So here we have the constructor ID, then the constructor reference in Formula 1, and this is the actual name of the constructor. So we have McLaren, we have BMW Sauber, Williams, then we have Ferrari, Toyota, Red Bull, Force India. We also have Jordan, Jaguar, and all. Next we have the nationality and the URL, that is the Wikipedia page of that particular constructor. Now let's head over to our Jupyter notebook and we'll start with our analysis. Here is my Jupyter notebook that I'll be using for this demo. You can see some of the cells are already filled. This is just to make sure we save some time. So using these datasets that we just saw and our libraries such as NumPy, Pandas, Matplotlib, and Seaborn, we'll answer specific questions such as the drivers and constructors who have been the most successful throughout the history of F1 sport. Then we'll explore the impact of starting and finishing positions and if the speed of the cars has changed over the years. So let's begin with our analysis. First and foremost, we are going to import all the necessary libraries. So here I'm importing NumPy, Pandas, Matplotlib, and Seaborn. And after that I'm writing %matplotlib inline. That is to ensure that all the plots are embedded inline. I'll hit Shift Enter to run it. It'll take some time. There you go. So we have successfully imported all the libraries. Now the next step is to load the data and assign column names. So I'll load my first data, which is results. I'll say pd dot read underscore csv. I'll give my file name, which is results dot csv, and then using the names parameter I'll pass in the column names. So actually I have written the column names in a notepad. Let me open that. So I have this F1 notepad created which has the column names. I'll just start copying the column names. Within the names parameter I'll paste it. If I scroll to the right, you can see the different column names that have been assigned, and for that I'm going to say comma, and I'll write header equal to none. I'll close the bracket. Cool. Similarly, let's import the second data set, which is about races. I'll say pd dot read underscore csv. I'll give my file name, which is races dot csv, and then I'll give the names parameter. This is actually names and not name. Okay. I'm going to copy the second line and I'll paste it here, and again I'll say header equal to none. Next, we'll import our third data set, which is about drivers. So I'll say pd dot read underscore csv. I'll say drivers dot csv, and then again use the names parameter, and I'll copy the third line now, which has the column names for the drivers dataset. Here I need to give another parameter, which is header equal to none. Finally, we are going to import our constructors dataset. We'll say constructors equal to pd dot read underscore csv, which is the function present in the pandas library. I'll say constructors.csv, which is my file name, and then again I'll use the names, the fourth line, which has the column names for the constructors dataset. I'll paste it, and here I'll give my final parameter, that is header equal to none. Alright, now let me hit shift enter to run it. Okay, we see some error here. Let's debug the error. It says no such file or directory, drivers.csv. Let's see where was the issue. Okay, this should be driver.csv. Cool. Now we have successfully loaded the data and assigned the columns to the various data sets. Now the next analysis is to merge all the data set. So here I'll create a data frame called df, and I'll use pd dot merge function. First I'll use the results data frame that we just imported above, this one, and I'm going to merge it with races data frame, and from the races data frame I'm going to take specific columns like the race ID, then I need the year, After that, I need name. Next, I'm going to take the round column as well, and I'm going to use on parameter. So on parameter is actually the column that is common to both the data frames, that is results and races. So here my common column is going to be the race ID because it is present in both the data sets, and I would like to merge. So for that I'm going to use how. So I'm going to use a left join. So if you know SQL, you will be aware of left join. It takes all the rows from the left table and only the matching rows from the right table. I'm again going to use the merge function. So I'll write df equal to pd dot merge. I'll say df comma, and now I'm going to merge the diverse data set, and I'm going to select specific columns. So I'll say driver ID. Make sure there are no spelling mistakes in the column names. Then I'll say driver ref, which is the name of the driver or reference, comma, and then I want the nationality of the driver. All right, I'll give a comma. I'll say on which column I want to merge. So here the common column is going to be the driver ID. Again, how is going to be a left join. Going to the final merge part, I'll say again df equal to pd dot merge. I'll pass in my data frame, and my final data set which I have is about constructors. From constructors, we are going to choose specific columns. So I'll take the constructor ID, then I'll take the name column, and again the nationality column of the manufacturer. Here I'll say on equal to the common column I'll use is constructor ID. Give a comma and say how equal to left again. Cool. Make sure you're merging it with the right column names. So let's run this cell to merge all the 4 data sets. I'll hit shift enter. Oops, there is some error. Let's see. It says constructor ID index. Okay, there's a spelling mistake. This should be constructor ID. Cool. Let's run it. There you go. Now the next thing we want to do is to drop the unnecessary columns. So I'll say df dot drop. Within the drop function, we are going to pass in the column names. I'll say number. Then we also don't want the position column. Next we have position underscore text. After that we have laps. Next we are going to drop fastest lap. Then we'll also drop the status ID, comma, we'll drop the result underscore ID column. Then going to drop the race underscore ID column. We'll also drop driver underscore ID column, and finally we are going to drop the constructor underscore ID column, and I'll say access equal to 1, and in place I'll say equal to true because I want to remove it from my original data frame, that is df. There you go. Now the next thing I want to do is I want to rename some of the columns. So I'll say df dot rename, I'll say columns equal to, now we are going to pass in a dictionary. I'm going to change the rank to test underscore lab underscore rank. Let me give a comma. Now I'll say name underscore x equal to, I'll say the Grand Prix name, so I'll say gp underscore name. Next column I'm going to focus is the nationality column, so I'll say nationality underscore x. I'll give a colon. The value I'm going to pass in is driver nationality. Alright. Up next we have one column called underscore y, and that I'm going to change it to constructor name. Another comma, I'm going to say nationality underscore y colon, change it to constructor nationality underscore nationality. Finally we have driver underscore ref column, and that I'm going to replace with just driver. Finally I'll say in place equal to true. Cool. Just verify if all the column names are correct. Let's run it. Alright, so now we have successfully renamed the columns. After that, in the next cell I'm going to rearrange the columns. So here I'm using the same data frame and we have just renamed the columns. So starting with year, Grand Prix name, round, driver, nationality, and others. Let's run this. Up next, we're going to drop the 2019 season data because it is incomplete. So I'll say df equal to df, then I'll say year not equal to 2019. Let's see how to sort the values. So I'll say df equal to df dot sort underscore values, which is the function name. I'm going to sort it by year followed by round followed by the position underscore order, comma, I'll say ascending equal to, first let's say is false, next I have true, and then I'll have true. Alright, moving ahead, now we are going to see how to replace the /n values in the time column with something called NaN, because the time column was not registered when a driver did not finish a race or was lagged by another driver. So to do this, I'm going to say df dot time dot, I'm going to use the replace function, and here I'll say / or /n, and I'm going to replace with numpy's NaN. I'll say in place equal to true. Let me just copy this because we are going to use the same meters. Next, I'm going to replace the milliseconds value. The milliseconds dot replace, I'll paste it here. Then I'll say df dot fastest underscore lap underscore rank dot replace, paste it. Next I have df dot fastest dot lap dot time, say replace. To that I have the next column, which is speed, so I'll say fastest underscore lap underscore speed dot replace. I'll paste it. So here I'm going to replace this particular value, the backward /n, with NaN. Let me run it. Cool. Step, I'm going to change the data types for fastest underscore lap underscore speed to float, then fastest underscore lap underscore rank to float again. Now problem here is we cannot convert it into an integer because there are missing values, so we are going to change it to float. Again, for milliseconds also we are changing it to float values. Let me run it. Now I'll reset the index. Let me show you how to reset the index. I'll say df dot reset underscore index. I'll say drop equal to true. I'll give a comma and say in place equal to true. All right. That we have done our initial processing step of the dataset. Now we'll check the shape of the dataset. Then we see all the datasets, the total number of non-null values, the memory usage, and we'll check the head of the dataset. Now to see the total number of rows and columns, I'll say print df dot shape. You can see here there are total 24,197 rows in my dataset, and there are total of 15 columns. Now let's use df dot info function. So it gives me the year, the Grand Prix name, the round number, driver, constructor name, grid, position order, total number of points, time, then time in milliseconds, the fastest lap rank, the fastest lap speed, the nationality of the driver, the nationality of the constructor. Then here we have the total number of non-null objects, and then you also have the memory usage at the bottom. Finally, let's see the head of the data frame. So I'll say df dot head. Let's say I want to check the first 10 rows. There you go. If I scroll down, you can see here we have the top 10 rows printed, and you have the year, the Grand Prix name, round, driver, constructor name, and other columns. Now let me just brief you about what these column names stand for. So the year column that you see here is the season that the Grand Prix took place, and then we have the name of the Grand Prix. Now the round column is the number of the race in each season. For example, 1 means it was the first race of the season, and then 2 means it was the second race of the season, so on and so forth. Then we have the name of the driver. For that we have the name of the car constructor, so you can see Ferrari, Mercedes, Red Bull, Renault. Then we have the grid, that is the starting position before the race. Actually this depends on the qualifications which occur 1 day before the race. Then we have the position underscore order column. This means the final position at the end of the race. Then we have the points column, that is the total number of points scored in the race. Next we have the time, that is the amount of time that took to finish the race. Only the winner's time is displayed, and drivers behind the winner are shown how far behind the winner they are. Then we have the milliseconds column, that is the amount of time that took to finish the race in milliseconds. If I just scroll down, I'll just move to the right, go to the top. Then we have the fastest underscore lap underscore rank, that is the order of the fastest lap during a race. Next we have fastest lap time, that is the shortest amount of time that took to complete a lap in the race. Then we have the lap speed, that is the average speed of the fastest lap. Then we have the country to which the driver belongs to, and then we have the constructor nationality, that is the country where the car constructor is based out of. Okay. Now here I'm going to set my figure size to 10,6. This is going to be for all the plots that we are going to create afterwards. Cool. Now we'll create a data frame that will have all the Grand Prix winners. So here I'm going to say driver underscore winner equal to, use my data frame df dot, I'll say loc, then I'll say df, I want the position underscore order, and that should be equal to 1, so which means the driver won the race. And then I'm going to use the group by function. I'm going to group it by driver, and for values I'll say position underscore order, use the count function followed by sort underscore values. I'll say ascending equal to false. Change it to 2 underscore frame dot reset underscore index. So what essentially I am doing here is I am finding out all the drivers that have participated and won a Grand Prix. Next, I'm going to create a bar plot. So this is going to be the first visualization of our analysis. So I'll say SB, which we have taken in our analysis. Ideally it should be SNS, but SB also will work. So I'll say SB dot bar plot. I'm going to say data equal to driver underscore winner. In the y-axis I'll have driver. In the x-axis I'll have position underscore order. Then I have color equal to green, that I'll set my alpha value to 0.5, or let's say 0.8. Then we are going to give a title to our plot. So I'll say plt dot title, let's say most Grand Prix winners in F1. Then we are going to label our axis. So for Y label, I'll have driver name. We have the X label that will have number of Grand Prix wins, and I'll say plt dot y ticks. Cool. Let's run it, and you can see we have our first bar plot here. Now the bar plot shows that there are a large distribution of Grand Prix wins. Only a few drivers in history of F1 have won over 20 Grand Prix in their careers, and there are some drivers who completely dominated the F1 racing and have won over 50 Grand Prix in their careers. So we are going to focus on those top 5 or top 10 drivers in the next section. So what I am doing here is, from the above result that we just got, I'm going to filter out only the top 10. So I'm going to use the head function, and inside that I passed in 10. If I print it, you can see here, as per the data that we have Michael Schumacher, who is the position order leader with 91 GP wins. Then we have Hamilton, Vettel, Prost, Senna, Alonso. Then we have Stewart, Clark, and Lauda. The data that we have is not the most recent one. So if you check the actual stats, Hamilton has actually overtaken Michael Schumacher and has won over 103, close to 103 races as of now. And next we have Michael Schumacher. So this is not the most recent data. Cool. Now using this data, we'll create another bar plot for the top 10 drivers. So I'll say sb dot bar plot. I'll say data equal to the name that we have used, that is top 10 drivers. So I'll say top 10 drivers. In the y-axis, we'll have the driver name. In the x-axis, we'll have position underscore order. For the bars, I'm going to use a color equal to, let's say, blue this time. I'll set my alpha value to be 0.8, and I'll say, let's say, line width equal to 0.8, and I'll also give an edge color of, let's say, black. Cool. Follow the same drill. I'm going to give a title to my plot. So I'll say plt dot title most GP winners in F1. I'll give a Y label that says driver name, and then I'll have X label which will have number of Grand Prix wins. Cool. Let me see if everything is fine, and then we'll run this. There you go. You can see we have a very nice horizontal bar plot that shows the top drivers in F1. So as per our data that we have Michael Schumacher, who has won over 91 or close to 91 races. Then we have Hamilton, Vettel, Alonso, Clark, and others. All right. In the same way, we are going to create bar plot for the top constructors that have participated in F1. So here I'm finding out all the constructor winners. So here I'm using my position underscore order equal to 1, and then I'm using the group by based on the constructor name, and then I'm finding the count of position order and sorting the values in descending order, and I'm changing it to frame or to a data frame. And to create my bar plot, I'm using the bar plot function, the data which is constructor underscore winner. In the y-axis I'll have the constructor name, on the x-axis I'll have the position order. So you can see here I've used color as pink, and I've given a title, x label, y label, and y ticks. Let's run it. There you go. So here you can see again the data is widely spread. So we have a lot of constructor names. Now our next task is to check the top 10 GPA constructor winners. So here I'm using the head function and finding out the top 10. If I run it, you can see here the manufacturing companies or the constructors who have won the most number of races are Ferrari, McLaren, Williams, then we have Mercedes, Red Bull, Team Lotus, Renault, and others. Okay, now we'll convert this data into a horizontal bar graph or a bar chart. So that will show the bar plot for the top 10 constructors. Now let me show you how to do it. So I'll say SB, which is for Cbond dot bar plot, going to say data equal to top 10. Let me just confirm the name. We have top 10 constructors. Scroll down, I'll say constructors. The y-axis I'll have constructor on the x-axis I'll have position underscore order. Then I'll say color equal to, let's say we'll use the red color for the bars. Then I'll set my alpha to 0.8. I'll say line width equal to 0.8, and my edge color I'll say black. That I'll say plt dot title, say top 10 most GP wins. Plt dot y label would be constructor name. Then I'll have plt dot x label as number of GP wins. Cool. Let's run it. There you go. So here you can see we have Ferrari at the top, then we have McLaren, Williams, Mercedes. I'm pretty certain by the end of 2021 season, Mercedes would have gained a lot of wins, since Hamilton has been on the top for Mercedes for quite some time now. All right. Now, finally, we are going to create a regression plot that will show how two variables, that is the starting position and finishing position, vary. So to do that, I'm going to exclude the data points with grid 0 because it skews the data. So 0 means that the driver started from the pit lane. So I'm using this function called regplot to plot my regression line. Let me run it and show you the result. There you go. So if you see here, we can easily see there's a linear relationship between the starting and finishing position. So on the x-axis we have the starting position, on the y-axis we have the finishing or the finished place. So which is what is actually expected, right? Now we can also see that most races had up to 25 drivers. You can see the density of the points here, but some of the races also had over 30 drivers. You can see the light color blue dots. Next, we are going to check whether the speed of the cars changed over the years. Now, since this data is only available from 2004 onwards, so we have taken years that start from 2004 onwards. Now let me show you the result of this data. So essentially we are plotting the average speed amongst all teams during the fastest lap at individual Grand Prix, and here on the y-axis you have the average fastest speed in kilometer per hour, and then you have the different GPs, and you can see here the year values. Now in general what we see is there's a decrease in the average fastest lap from 2004 till around 2015 for almost all the circuits, and again from 2015 onward the speed started to increase. You can see here there's an increase after 2015, there's an increase here as well. You can also notice that the speed is very different on each track. For instance, if you check the Italian Grand Prix, which is here, Italian GP has the fastest race in the calendar with average speed exceeding over 240 kilometers per hour. On the other hand, if you talk about the Monaco Grand Prix, let me show you. If you see here, the Monaco GP is the slowest race with average speed below 160 kilometers per hour. Now this is actually expected because the Monaco Grand Prix has very narrow streets and hence the drivers cannot drive fast in this circuit. Alright.
Hey everyone, welcome to this interesting video in JavaScript. The best way to master a language is by programming in it. If you enjoy watching such tech videos, make sure to subscribe to our channel and hit the bell icon to never miss an update. So what's in store for you? We'll first create some simple beginner level projects like how to build a calculator app. Then we'll move on to more advanced apps like the weather app, the tic-tac-toe game, and finally we'll conclude the session by creating a snake game application. Now I'm sure you're excited to dive deep into it. So let's begin.
So we have decided to basically develop a very interesting project in JavaScript that is known as called calculator application. Like you have seen earlier some projects like in tic-tac-toe, you talk about snake game, you talk about the quiz application. This time we're going to introduce you another very interesting project using this JavaScript, HTML and CSS, so-called calculator application. So let's get started. Let me try to delete first those files which we really do not need it now. We delete those all. Yeah. Now I'll be creating a new folder now and give the name called calculator app. And in this calculator app, once again we need some new files which is called index.html, and we also need one more that is called app.css, and another one that is called app.js. So these three files required. Now first of all I would start with index.html file where we'll be creating a template of my code. Now let me go and create this template, and here I have got body with me. Let's start with the first tag here, that is called h1, and this h1 we are giving the name called calculator. So that will be my h1 heading. After that we'll start working with the div tag. Now within this div I have to create lot many classes. I may not have lot many CSS classes, but we can give some classes here. So we can say class equal to container. Okay, so within this div tag we're going to create a table now because I want to organize it. So I'm starting with the table. Within this table, a tr tag, and within this tr tag I need a td. Now in this td I need few things call span equal to 3 as the value, and here I want to offer the text box input type equal to text. Okay, input up to text, id equal to, give the name called result. That will be the final outcome while pressing all the different buttons, id equal to result and class equal to screen. Remember, I haven't created those CSS classes, but we're giving some names, but later on we can utilize it while creating those CSS classes. Table data is getting closed. Let's get started with another TD. Now inside this TD, we need another text box. Input type equal to text, and here in this input type to text, sorry, I would like to better say button because I'll be having buttons. Okay, input type equal to button, value equal to C, and on click equal to, I may not have any function right now, but yes, I can create a function, but let me give some dummy name here. I'm saying clear screen. Okay, so that will be the function we get called, and after that class equal to clear. Yeah, so this is my button tag. After this, the TD tag is getting closed. After the TD tag, the table row is also getting closed. After the table row, which is getting closed, we're going to start working with another table row. Okay, and in this table row, I'm going to create one more TD. So let's go and create another TD here, and inside this TD, I'll be having another button to be get created. So I'll just say this is my another button now. Input equal to button, value equal to 1, on click equal to, I'll be calling another function called display. Okay, and inside this we're giving the value called 1. Okay, and class equal to number. Class equal to number, and here after that the TD tag is getting closed. Okay, now we have to start another TD tag here. Okay, like that we have to keep on creating the multiple buttons. So let me copy and paste another table data. Now here again value equal to 2, on click equal to display, give the value called 2, and class equal to what? Number. Like that I'll keep on creating multiple buttons, but first check how it actually looks like it. Now I can see the buttons like in C 1, 2, 3, but yes, I'm going to create few more buttons one after another. Okay, so I'll go here and create few more buttons. So this is where the table data is getting closed. Okay, I'll copy this and paste it again. So I have to create the button like in 3, 4, something like that. So after this 2, we're giving the value called 3. Yeah, I'll give the value called 3. So value equal to 2, value equal to 3, display 3. And then afterwards, just giving the value called forward slash. And here also we're going to give the value called forward slash. And here class equal to operator. After that, we have to give the value called 4 and then followed by 5, 6, 7. So here we give 4, 4, 5, 5, 6, 6. After 6, we're giving call minus. Okay, once again it will be what? Type of operator. Okay, after this minus, we'll be talking about call 7. Then we have to have 8. Okay, 9. Okay, after that we're giving call plus and display plus class equal to operator. Okay, so here you can see the table data is getting closed, and here the table row is also getting closed. And after this table row, you can start working with another table row here. And after this table row, we can start working with again TD. Let me have this again. Inside this, I'll be giving the option called decimal, which is value equal to dot, and here we give the value called decimal. Okay, now display 0. So after giving this dot, it will basically take what? The value 0, which we haven't put now. We'll be talking about value called 0. So here the decimal value we have given it, TD is getting closed. Let me have the other one. 0, 0. So like that we have to give this now. After that, we'll be once again taking this, and this time rather than giving this 0, we'll be using this call as a button, and value equal to on click equal to solve. Okay, and in this solve will not be passing anything. It will be like a normal function, and class equal to equal. Okay, so table data is getting closed, so we will be using another table data now. So here it will be the button only. Okay, we will be using value equal to multiplication, display asterisk, and here we'll be using operator. Okay, so table data is getting closed, table row is getting closed, table is also getting closed here. Okay, so your div tag is also getting closed here. Okay, that's it. Okay, so that's the only thing which we wanted to make. Let me try to refresh and check. Awesome. So we have got all those necessary calculator behavior which we wanted to reveal. Okay, now our next statement will be, once we are giving this C, then we have to call 1, 2, 3, and then forward slash followed by 4, 5, 6 will come down. Okay, so let me check whether we have used 6 or not. Okay, so we haven't used 6. So let me check here. 4, 5, 6. So let me go back here. 4, 5, 6. Let me copy this and paste it later on. Before minus. Six equal to number. Okay, so we're almost set now. So we are having this look and feel. In this we are giving 1, 2, 3, 4, 5, 6, and after this we have a call minus and then plus related behavior. So we are all set now, and after that we'll be basically applying the CSS as well as the JavaScript look towards my code. Okay, thank you. Well everybody, we're all good to go now, but I just want to first check whether my this outlook is looking properly or not. See, what my expectation is, after 1, 2, 3 forward slash, I really want to bring 4, 5, 6 to the next, and then 7, 8, 9 and again forward slash, but I can think this is absolutely unorganized. So after this, when we say this forward slash which we have used after hyphen, okay, your TD is getting closed here. Okay, so here the TR I also want to close here. Okay, and after this TR I also want to start another TR here. Okay, so that I can put them into the another level now. So under this TR I can use this TD now. So after this minus, after 4, 5, 6 minus, once again I would like to start another table row here. Okay, so that it likes go to the next row. So here after TD we're closing this TR and starting another TR now. Okay, we're starting another TR. After that we talk about 7, 8, 9. Okay, plus, see here, talking about 7, 8, 9 plus, here the table row is getting closed and it is starting right now like this. See, that looks better now. Okay, but still few more things which I would like to make it even more organized, but that's not a problem. We will do it later on. Okay, because you can see 8 is missing right now. So here 7, we copy this, equal to 8. Yeah, that looks better now. So now they are basically completely organized. So the moment I expect my application, so we have a call dot here, then 0, then equal to, and then we have a call multiplication. Okay, so looks better now. Now I just would like to perform the overall look and feel. So I need to go ahead and use what CSS, because without CSS I really can't utilize this in a proper way. So I have to start working with the CSS front now. In CSS front, how to start? First we will go back to my code, and here in my CSS we'll start working with font family. But before font family, I would like to start with the body part now. Body, background color I'm using called teal. That looks nice. Okay, so I will be using this app.css in my HTML to see the look how it is being appeared right now. So in my index.html file, on the top under my head section, link, style sheet, okay, now see, it looks better now. Going forward, in my CSS, we want to use some H1 color too. So here, we would like to use the H1, text align, center, color, white, margin top, we would like to use 50 pixels. This is for H1. Let's check. Perfect. So it is now coming in between. Next statement will be called screen. So we say dot screen. So in this screen we use the background color gray, and after that border solid black and with 2 pixels. After that color white, font size medium. Next width, we are using this 100%. Then we talk about cursor. We'll be saying what the default cursor is. Okay. Then padding, we would like to say 10 pixels, and then margin, say auto. Then margin bottom, that I'll be using 10 pixels. So it is the proper alignment. Okay. Look, that's how exactly we want. That's for a screen where the exact outcome will be visible to me. And rest of the details will be showing you one by one. Now we'll be talking about called input. Okay. Input type equal to button. For input type equal to button. Okay. Input type equal to button of type what? Hover. The moment I hover on my button, I say background color change to what? White, or else I can say white smoke. Okay. And when the button is active, what I want, let me copy input equal to button, and here I say active, and this color should be orange red. Like this. You can see now how it is basically looking like it. Okay, active, the color will be like this. Okay, I'll be talking about called operators. Operators should behave different. So I'm saying dot operator. In this operator we are saying background color orange. Okay, then padding, I want 5 pixels. Okay, then I want color, that should be black. After this I'm using called border. That border, I'm using this called solid, and then black and 2 pixels. After this width, I'm using 100%. Then height, we're using 40 pixels. Then cursor, it has to be pointed type. Okay, that's it. Let's check. Perfect. So they should turn back to what? To your orange color. And you can see the moment I take my cursor on it turns to white. Perfect. And now those who are type number, I also want to change them. So for number, I want to say the same option. Padding, I want 5 pixels. Then I need height of type 40 pixels. Then I say color. It looks, I want to say called black. Then border, I want solid, black and 2 pixels. Solid, black and 2 pixels. Then width, I would say 100%. And cursor, once again, point. That is for number. Let's check. Awesome. So they looks nice. Now we left with few other type of options like a dot and equal to. Okay, that I'm talking about called decimal. For decimal, I need to have a different options with me. Okay, so let me try to copy this, paste it, and I say for decimal. So for decimal, background color will be light blue, padding 5 pixels, color black, border solid. Okay, black 2 pixels with 100%, height 40 pixels, fine, cursor, pointer. Perfect. Okay, looks nice, but I have changed the color to light blue now. Now I talk about clear. Okay, now come back and say clear. Okay, in this color, background color is I'm changed to light salmon, padding 5 pixels, color black, border same, width 100%, height 40 pixels, fine. So cursor, pointer, fine, margin, auto, and margin bottom 10 pixels. Let's check. Perfect. Now it looks beautiful. Okay. Now here, after giving these details, we're talking about called equal part, dot equal. So for dot equal also, I'm just copying the same. So give a call, background color, padding color, just change to light green. And after this, since it is an equal, so we say padding 5 pixels is okay, color black, fine, border, fine, width 100%, height 40 pixels, color and cursor pointers, just I don't need to. This is for dot equal, and I want for container. In this container, width I want 40%, width 40%, background color white, okay. Now here padding is 15 pixels, so display block, so first of all we have call width, we say display block, which we're taking margin, okay. In margin we are saying 100 pixels, auto, okay. Now align cells equal to center, okay. Border radius, which is saying 10 pixels, okay. Now we are saying box shadow, 5 pixels, black, and padding So these are the details I have it now. Okay, we have it. Background color, we are taking it now. Align self, display block, border radius, padding, and all. Padding 15 pixels we have given already. I don't need to give it again. Margin, okay, fine. Box shadow, let's try. Awesome. So it's looking beautiful now. Okay, so this is where exactly my application works like that. And table, when we talk about, here we're saying width 100%. Okay, that's it. Super. So it's now giving me the proper look of how my application should behave like it. Just see about the container what we have done. Width 40% we're taking, background color. Let's bring it below. Then align self, display block, okay, margin, okay, and border radius, and fine. So I think we're all good now. So that's it. So we'll try and implement the JavaScript part. Well, everyone, so our CSS file is ready, our HTML is ready. It's time to just go ahead and talk about my final portion, that is called JS part, where I want to basically perform some calculators. Now here I just say function display which takes var as in parameter and say document dot get element by id. Here I'm saying result, okay, dot value, okay, plus equal to var. Whatever we are adding it, just it basically try to apply calculation on the top of that. Okay, that is the function. After that, we have another function available here called function solve. Here in the solve, we just use the value called let x equal to document dot get element by id result, okay, dot value, dot value, okay, and say let y equal to perform the calculations. For that, we'll be using one function called eval and type x as an parameter. Now the next statement will be again document dot get element by id result dot value equal to y. Okay, now later on I'll like to use another function here, function clear screen, and here we say document dot get element by id. Here we say result dot value equal to, like that. So clear screen, solve, and display, three functions are associated with me, and these three functions are the part of this JavaScript file which I'll be calling it at the end before the body tag gets closed. So here script equal to app.js. That's it. Okay, let's try to execute now. Here 2, you can see the values. I will say plus 6 equal to 8. Absolutely. As I say C is clear the screen. 6 divided by 2 equal to 3. Awesome. So friends, your calculator application is ready. Congratulations to all. So it is a very simplest form which we have developed. This is your HTML, which is a template for you. This is the CSS, which is your complete the area of like how the look and feel will look like in of this template beautification. And here last we have a JS, which is smaller logic but really meaningful. Okay. Hello everyone, and welcome to the another very exciting project for our development in JavaScript that is known as called Weather Pro. It is in a continuation to the series of the previous project what we have developed in JavaScript, and this is once again a very competitive project I'm going to present to you, which is called Weather Pro, where I would like to offer you the real-time weather application into your browser taken from the real-time weather applications. Okay, so let's get started with the new development of our application, which is called a Weather Pro. Now once again, compared to the previous project what we have seen, these projects were working more a kind of static in nature, where like you talk about snake game, you talk about Tic-tac-toe or other type of games like an online quiz, where the data was very much static in nature, but we were presenting the data in the form of more dynamic in nature. This time, this project we are presenting you while connecting with a real-time weather application, where I'll be making a one REST API call, or else you can say asynchronous call. And since JavaScript is working as about a pure asynchronous nature, you will be enjoying the way how the JavaScript can communicate with your backend, load the data and represent the records in a very beautiful manner. So once again, we would need this VS Code editor only just to develop our code. And once again, for developing a presentation part, we'll be using HTML. For formatting part, we'll be using CSS, and to make some dynamic update, we'll be using JavaScript. Now here, I'm going to create a new file name called index.html. Parallelly, I just want one more that is known as called app.css, and another file we needed, and that is called your JS file. So we are saying app.js file. So total number of 3 files are available to us. Now I'll start working with an HTML now, and here we'll start with this HTML templates. Now here, first of all, I would like to load my CSS file, which I do not have right now, but certainly I can use it. Okay, so I can just say link rel equal to style sheet and href equal to app.css. Well, that is my CSS location. Now I just want to create this link rel I would better use inside my head tag. That will be the more convenient place. Now in my body, I want to have some of the div tags, and there I can decide where the weather to be displayed. So I can just start with my div tag now. With my div tag, I say class equal to, I can just create a class which later on I can offer different size of or different type of style. So we can say container. So we're saying div class equal to container. Now within a div tag, we like to use another div tag, which is a nested one. So this div will have another class called class equal to app hyphen title. App hyphen title. In the same div tag, we can use this typical paragraph tag, and here we say weather info. Weather info. Now after this paragraph tag, we want to have a text box, because I would expect a client to enter the detail on which city or for which city he or she would like to get the details. So we can say input some properties like ID equal to search, second type equal to text, next placeholder equal to enter the city, next autocomplete. I'm saying autocomplete of The reason because I do not want the previous value user can see. In this case, we can say autocomplete off. I do not want any autocomplete in this. Okay. Now, here it is getting close now. After that, we also want the locations. For that, I may use some of the PNG files and all. But right now, I just want to display the details of the user, like which city he belongs to, and accordingly I can display the records right in your application. So for that I really need some of the div tags once again, where I can display the details of this particular city. So I'm just having this only text box. Let me go back and check how it looks. So I have a call, enter the city. So here I'll be picking up the city, and somewhere down the line I have to display the records. So after this div, we can also have some of the locations to be displayed. So we can just use the notifications and also the location where you want the details to be displayed. Okay, so we can use div class equal to temperature value, temperature hyphen value. Okay, so div class equal to temperature hyphen value. Inside this I'll be using paragraph tag, and here in my paragraph I'll say hyphen and this degree centigrade or whatever you want to display it here, and we'll use a span tag within this and show in degree centigrade. That's it. And if you want to define the temperature description, after this div tag we can use another div tag, and inside my div tag I can define the temperature description. Okay, so we can say div class equal to temperature hyphen description, temperature hyphen description, and within this I'll be using what, a paragraph tag. Here I'll be displaying all the description. So right now that is the only thing which I want. Let me check. Okay, so it's here right now. So now let me try to collect the value from the client and perform some JavaScript tag within this. Okay, now it's time for us to go back and try to bring some of the CSS features into my code now. Now, few things I would like to say is I have basically downloaded some fonts which I would like to use it in my application, and I also have some of the icons which I would like to use during my application presentation. So there are some PNG files are there which I've downloaded from the internet just to bring more beautiful experience towards my application development. Well, this is another background image which is called bg.jpg, which I would like to make it as a background of my existing application. So I'll start with my CSS and see how this CSS can really bring some new features to my code. Well, first thing, I need to have a called font face. So to make this font face, we are using this statement name called here @font face, and I like to use font family. Font family, I'm using Montserrat. Okay, it is already there with me, Montserrat, and the URL what is looking forward for. So we are saying src URL, and I'm saying under the font, so we have a file called ttf. Okay, that is called bold.ttf. That is the file which is there with me. Next thing, so for every location I want to use the font family, font hyphen family. I want to use same Montserrat, and the next thing is like in my body. So in my body, few details like background image, I need URL, and in this URL we can say bg.jpg in my background. Next thing is background color. that I need it still blue. Then I need height. I'll say 500 pixels. Next, your background position. This I need it is center. Next is your background repeat. I say no repeat. Next is your background size. This I'm saying cover. This is my body part. Okay, let's check. Okay, looks awesome now. You see this now. This is how my weather info is looking like it. You can see like the background looks awesome now. Now, next thing we require a container. So we are saying dot container. Container we say width 50%. Next, background color. We're just using white. Next, we need it is your align self. That will be center. Display will be block. Margin. So in margin we can say 100 pixels. After that, border radius. Border radius we are saying 10 pixels. And then padding bottom. This padding bottom will be 50 pixels. Then box shadow. This box shadow we are giving 5 pixels, 10 pixels, 20 pixels, and black. This will be with my container. So index.html file we have a called container. Now, okay, looks awesome now. So this is where exactly the details will be. Okay, now after this CSS container we have used, we can talk about called title. You can say hyphen title. Inside this we will say width will be 100%. Then height will be 150 pixels. Then border radius 10 pixels. 10 pixels. Then we need display. Display we need flex. And then we need align items. This align items we are just saying center. Next we need justify content. That will be the justify content will be just center. Then flex direction would be column. So this option we are using for our tool name called what? app-title. Okay, so here in my index.html file we have a called div class equal to what? app-title equal to weather info. Let's check. Okay, so this is the another we have used that is called app title. Now we need to use it for paragraph. Inside my app title, what should be alignment for my paragraph? So here, this app title is space p, but it should be the class. So we are saying dot, and there also we have to use what? Dot, because both have to be the class type. Okay, so here you can see now there is a difference. I forgot to add dot, and now you can see it looks better comparatively. Paragraph. So once again in my paragraph I'll be having text align, center, padding, I want 15 pixels. Then I need margin. Margin would be 0 and auto, followed by font size. Font size, this I'm saying is called 1.2. Yeah. This is position. Then color, here giving hash value called 333. Okay. Now here, okay, so some changes in a paragraph. Well, going forward for the search, because if you remember, we have an index.html file, we have a call id equal to what? Search. So here in my app.css I have to use hash search. Okay, so this search conditions I want to use it. Now inside my search I need few things. One is called display, I need block, after that I need margin left, auto, margin right, auto, width, I'm looking forward for 5 pixels, height, that I'm looking forward for 20 pixels, then border radius, I'm looking forward for 5 pixels, then outline, that is called none. When we say border, okay, in this border what we can say 3 pixels, space solid, okay, and once again see blue. That's what. Let's check. So this is actually the text box. So once again, search you've used display block, margin, left auto, margin right auto, width 5 pixels, width, padding, sorry, one thing I said, padding should be 5 pixels, width should be 40%, that's why it is smaller, width it will be 40%. Let's check. Yeah, that's look better now. Okay, so my text box is now ready. I'll be having some of the details for the notifications also. So what I need for the notifications, let me go back and create a class for notification. So dot notification. Okay, now in the notifications I would like to give some value called background color, and in this background color we are just giving white, and after that we are saying display, and we are saying none. This is for notification, and followed by the notification, we're talking about the same notification, okay, and followed by its paragraph. We are giving the color. First of all, we are saying color. Color is basically red, okay, or else if you want to give maroon, it will be maroon. And after this, the next property we are taking is called font size. Font size we are taking is called 1.2 em, followed by margin. Margin we are taking is 0. After that, text align, center, padding 10 pixels, 0. So this is for notification P. And then the weather container, okay, in my weather container I will say width 100%, width 100%, height we're giving 260 pixels, or if to you 250 pixels if you want. Background color, this background color we are giving is called once again white, and followed by margin top 20 pixels. This is for weather container. Now for the weather icon, weather icon, I'm saying width is 100% and height 128 pixels, just to give in a better look. Now the next thing, we're using dot weather icon space img. Here we're getting display none, and display not none, I will say rather block, display block, and margin giving 0 space auto. This for icon. And location icon, if I want to give, then location icon. This location icon I can say with same width, height. So width I'm giving is 100%, then height I'm giving 40 pixels, and then we give this option called padding, then 10 pixels. So it's for location icon. Now followed by location icon, we are also giving call location icon img. Okay, dot location hyphen icon space img. Here we're giving the value called display block. Display block width we're giving is called 32 pixels, and then we're looking forward for margin. Margin would be 10 pixels and auto. Then cursor, so cursor will be pointer for sure, and then we require padding. Padding we're looking forward for 5 pixels, followed by border. Border we are looking forward for steel blue solid, and 2 pixels. Then border radius, we're looking forward for 10 pixels, and followed by your color steel blue. So these are the look and feel we have to basically offer it for my current application, which I yet to discuss in my next development. Then I'll be having some small properties here. Okay, and those properties are nothing but to give you the details of like temperature values. So we say dot temperature hyphen value. Okay, this temperature hyphen value we can give width is 100%, and height we give this called 60 pixels. Okay, this is for temperature value. Let me copy this again, and I'm giving this temperature value space paragraph. Here I'm gonna give padding 0, margin 0, then color, which color we're looking forward for, so we can just say dark gray, Okay, or any color which you're looking forward for, it's up to you now. But if you want, you can change the color also to the another one. We're giving this called hash 293. Okay, 251. Okay, that is a more perfect color for this development. Now font size 4 EM, then followed by text align, and once again center. So this is for temperature value P. We haven't used much, but you can see now it looks somewhere in much more better way. Okay, that is called temperature value P. Then you can use a temperature value span here, dot temperature value span space span, and here we'll remove the additional dot. Now within this span, say color, once again same, and font size this is for span, and in the same temperature description paragraph you can use it dot temperature hyphen description space P. So this will be having the padding of 8 pixels, then margin 0, followed by color, same color, the one which we have used it earlier, after this color just a text align, center, font size 1.2 EM. This is for temperature description. Okay, last which is available for your location. So let me give the location now, dot location space P. Here we can say margin 0, then padding 0, then color, same color I would like to use. After this color, text align and font size. I'll copy, text align center, and here we'll be giving some different value called 0.8. Okay, and last which is left with called div. In that relative, here position I'll be using absolute, top, from top I'm using 600 pixels. Okay, and right I'm using 120 pixels. That's it. Okay, so all set. So you can see now here we have to basically offer the details how my pictures will be taken it up. So this is what my CSS. Now we'll be applying some of the CSS into my HTML to see how it really looks like it.
If getting your learning started is half the battle, what if you could do that for free? Visit SkillUp by Simplilearn. Click on the link in the description to know more.
Okay, so we have seen some of the CSS classes we have introduced. In my HTML, we have used this autocomplete equal to off, then we have used div class equal to temperature value. Okay, if you just check carefully, we have used this temperature, and div we have used temperature hyphen value. But before that, we would like to use some other properties too. Okay, after this autocomplete equal to off, we want to use another div class. Okay, before my previous div tag is closed here. So here, after this, we would like to use another div tag, div here in my div I'll say class equal to location hyphen icon. Location hyphen icon. Okay, and here I'll be using img src equal to what? Under icons I'm using the file name called location.png, and alt equal to, we leave it as it is a blank. Okay, now here the div tag is getting closed. Okay, now there's another div tag is getting closed here. So two div tags are closed. After that we'll be using another div class for notification. Here div class equal to notification. Div class equal to notification, and this div tag is getting closed right here. Okay, now another div for the weather condition, another div tag, and here we say class equal to weather hyphen condition. Weather hyphen what? A condition, or I can say weather hyphen container, whichever. So I can say weather hyphen container. Under this weather container I like to use another div for weather icon, div for class equal to weather hyphen icon, weather hyphen icon, and within this I want to use another img src equal to, once again, icons slash unknown dot png. Okay, div tag is getting closed. So after this div tag is closed, I'm going to use temperature value. So the temperature value is anyways used here. If you see, using call temperature value after the first div tag is closed, you see like temperature value we have used. After that the paragraph tag and the temperature hyphen description p. After the p there's a div tag is getting closed. Okay, and after this we are using div class equal to location. So we want to use div class equal to location, and within this location we want to use one more paragraph tag with this hyphen. After this paragraph it's closed. This div tag, and another div tag. 3 div tags are closed. That's it. And at the last, before my body tag is closed, I would like to use script src equal to app.js. That's it. Let's check. Great, my application looks pretty beautiful now. So this I want to be displayed only when I don't find the weather and the location and all. So look and feel is absolutely good, and now I'll start working on my JavaScript front. Okay, so let's go ahead and start writing our JavaScript code. So in just JavaScript code, first of all, I need few things. First thing what I need is call individual elements or individual properties of my application. I need const icon element equal to document dot query selector, and I'll be using the name call dot weather hyphen icon. Okay, now copy this. Now we will call icon element, we can say location icon. Call location icon. Here we are saying dot location hyphen icon. Now next I need it is called temp element. Here we are using the property called dot temperature hyphen value space p. Next we are looking forward for DESC element, which is called description. Here we are giving temperature hyphen description hyphen temperature hyphen description space what p. Then location element okay, we need a location element and we use dot location space p. Next we need notification element and here we're going to give the call notification. So 4 properties we have taken. So we are selecting all the elements. Next statement what we're going to talk about. See, this statement is all about selecting the elements. The next step we are talking about call get the input field. So we are saying var input equal to document dot get element by id. Here we give the name called search, which is the name or id of my text box. Let city equal to blank. Next we're going to give call let latitude equal to 0.0. We are initializing this value, and let longitude equal to again 0.0. So we are getting the coordinates right now. So this is how to get the input fields. Next we want to apply the events here. We are saying input the variable dot add event listener. The variable what we're talking about, which event listener we're talking about, key up, and what event you want to apply. So we are saying function with a parameter name called what, event, and now we would like to attach the logic. Now we are saying if what is the condition, event dot key code equal to 13. Okay, then that means number 13 is basically the enter. See, the key code means what, 13 represent the enter keyword. So event dot key code equal to what, 13. So we are saying event dot prevent default. Why we are using this? Because I do not want my page to be get refreshed. Just to avoid this we are using this. And after that we are saying city equal to input dot value. Now you'll be using this another function because I do not have function created. Otherwise I have to call the function name called get search weather and we'll be passing this as a parameter. So we're using get search weather. I do not have this function, I yet to create this, and pass it here as a what, city, and we say console dot log city, whatever we are basically printing it. Okay, so that is the first thing. Later on we need to get the data. So to get the data we are just using this variable name called const weather equal to const weather equal to curly braces. After that we are saying weather dot temperature equal to this, and which temperature conditions you want. I'm saying unit of type what, Celsius. I want it in Celsius. Put it in double quotes. Okay. So next statement will be getting the details in Kelvin. I'm saying const Kelvin equal to value of the Kelvin is what, 273, and after that const C. Ultimately what we need is we need to interact with our backend API from where I will get or receive the updated weather applications. Okay, now to get this I'll be using one very popular API here that is known as called openweathermap.org. This is one very popular app which people use it, and it's used and trusted by many companies. Clear? So here what you can do, this openweathermap.org, so you need to basically first of all get yourself registered, because if any third-party application is interacting, it requires that particular unique API key. Since as a visitor you really can't get it unless you register yourself, so I have my API key with me, so I'll go here. It'll ask me for the registration. So I already signed up, so if you're not, you need to sign it. There's an API key for me which I need to copy, and this API key I'll be using it in my project. So I just use this property called const key equal to paste my key here. Okay, after this pasting the key, but make sure that you're rather using my key, you use your key, otherwise this application sometimes won't work. So I'm basically trying to use this tool name called geolocation. I'm saying if geolocation, okay, in navigator is, there's a browser object model element. So here we are using navigator, okay, navigator dot geolocation dot get current position, in which I'll be passing the first parameter name called what, set position, and second parameter will be show error, in case if any error is received. Okay, else, in this else condition what would happen, I'm using this statement name called notification element. You see this notification element dot style dot notification element dot get elements by class name, but I don't need this, rather I will use what, the style dot display equal to block. Then I'll be using the same notification element dot inner HTML equal to, you're gonna use a paragraph saying what, browser doesn't support, so you have to enable the current location of yours. Okay, that's where exactly. So after that we have to basically set what, the user position. Okay, if the user is having that support available. So after this location we'll be just using another function here, function set position. It will, I'll be taking position as a parameter and take latitude equal to position dot chords for coordinates dot latitude. Okay, like that. longitude equal to what? Position dot chords dot longitude. After this, we'll be using this function called what? Get weather. So this get weather will be the function in which we'll be passing it. So this function will be soon seen. I'll be having it defined below. But as of now, we are just saying get weather, and in which this we are passing latitude and longitude. That's it. So we have this function name called what? Set position, in which we'll be passing all the values. Okay. At the same time, I'll be using one more function here, that is called function. Not function, in fact, I would like to use location icon, the one which you defined at the top, dot add event listener. Which event listener? I'm saying on click. Second function which take event as a parameter, and inside this I'm saying console, just to confirm whether the records are being taken, console.log hey just, and we say get weather. Okay, once again we'll be passing what? Latitude and longitude. Same, I just copy this and pasted it here. Okay everyone, so we have written till here. When I try to run my browser, so I should see there is a message name called show error is not defined. But obvious, because this message what we're writing it here is called show error. Okay, this as a function, as a parameter, it is not defined. Let me define this function called show error. So we are saying function show error, which take error as an, just take error as a parameter. Now in this we are using notification dot style dot display equal to what? Block. After that, once again, notification element dot inner HTML equal to what? We're just using this as a paragraph, and here error dot message. Okay, and after that paragraph. So this is how we are basically writing it down. And now see, it is immediately asking you to know your location. Okay, if I say allow, that's okay. Okay, so nothing. You can see now it is saying get weather is not defined, because right now the moment I click on this, so it is saying like get weather is not defined, but obvious, because I told you this get weather function I need to develop. So I get to develop this function called get weather, but before that I'm using another function called function get search weather. Get search weather, in which I'll be passing what? City name. Now what exactly my API will be, in case if I want to make a call, I will be using let API equal to, now the URL will be what? http://API dot open weathermap.org. Now open weathermap.org slash data slash 2.5, that is a version, slash weather. Okay, question mark. I have to take the city dynamically, so I'm saying weather question mark q equal to, here we're using what? City, and we're using ampersand app id equal to the one app id we have used it already. Okay, what is that? That key. So that is a key which we've already written. That app ID we are passing it right over here. Okay, Q equal to city and app ID equal to this. Now after that, to make the RESTful API call, I'll be using one independent or by default API which is available to us, that is known as called what? Fetch. Okay, so if you just check this fetch, it is basically a take request info and give you the what? A promise response. So return type will be the promise type. In this fetch, I'll be passing what? The API, and we'll be using dot then. Then means if the request is successful, we are saying function response. Then function is a parameter response. We are saying let data equal to response dot. I'm expecting the response of type of what? JSON. We're saying JSON now, and return what? Data. So it will be returning data back to me. Now if it is successful, then what? Then I'm saying dot. Then once again it is chaining, again function, again data as a parameter. Now in this case we'll be getting a lot of things. I'm saying weather, okay, dot temperature, it's a predefined, dot value equal to, I'm using what? Math dot floor. Inside this we are passing what? Data dot main dot temp. It is a predefined property. We are receiving it now. Hyphen Kelvin. Whatever the Kelvin value is, basically we're taking is called 273 on the top, minus Kelvin, followed by another property, what? Weather dot description, weather dot description equal to, we're using data dot weather 0th position because it contains a lot of data, but I will be taking what? Description out of that. Then weather dot icon ID, weather dot icon ID equal to data dot weather dot icon, then dot icon. Then once again weather dot city, okay, equal to data dot name. After this, weather dot country dot equal to data dot sys dot. So these are the properties. I have it right now with me. Okay, and once I received all the property, I'll be using dot, then I'll be using one function, and I will say what? Display. There is no function written called display weather, but I'm gonna say there's a one function name called display weather. This function I yet to write, but this function I'm just putting it here. Okay, now this is closed. After that, since I need to get a weather from the API provider, so I have to also pass what? The latitude and longitude, which I'm receiving it from the client, because here I just want to have two things, the properties as well as weather, both, and both I'll be using it one by one. Okay, so here we have kept this get search weather, and now I'll be calling one more function after this logic, and I'm giving the name called function get weather. Okay, it takes two parameters. One is called what? Latitude, and second is called longitude. So we have two things called latitude and longitude, and here I'm using this property called what? Let API equal to. Once again, if you remember, I have used this statement. I'll just copy the same and pass it here. challenge would be this time, I will not be passing city name because there are two options are available. Either you type the city name or else you click on the icon and let your application identify the location which you belong to. So after this weather question mark, here I will not be using Q, I will be using what? LAT equal to latitude. Okay, and we're using and LON equal to we're using longitude. Okay, and app ID equal to what? Key. So this is the variable which we have it now. Okay, now similar thing which we have used it on the top, okay, called fetch API. So I just copy this same fetch API again because I really don't want to waste time on keep on typing the code. When we know it very well, it can be similarly done. I just copy and paste it here. So the same fetch API dot then response data equal to response dot JSON return data, then weather dot temperature mat dot floor says country dot display weather. So we have used the same thing here, and after that we have to use the last function here that is called display weather. Display weather, and here in my display weather I can use what? Icon element dot inner HTML equal to, I'll be using img src equal to icons slash dollar, and we'll be passing what? Weather. Okay, dot icon ID. Okay, dot png. Okay, so that we are basically putting it here, dot png, and after that we're just closing that. Okay, and this icon we also needs to close here. So rather than closing this, I'll be closing that, and this I'll be closing it here. Now we'll be using temp element dot inner HTML equal to what? We'll be using this dollar weather dot temperature dot value. Okay, and after this value we can just use this asterisk sign, the one which I told you. Okay, and use span Okay, next we are using called talk element so we have DAC element. So we have called DAC element dot inner HTML equal to weather dot description, and last but not least location element dot inner HTML equal to what? I'll be using once again this, and here weather dot city comma dollar weather dot. That's it. These two properties we have to use it, and we are all done. Let's check with my code if I get any error. Now allow. So awesome, you can see now 27 broken clouds, globe undefined, that's perfectly fine. Intercity, you can see awesome, beautifully it is showing you the conditions. It's saying smoke 28 degrees centigrade and all. Let me put another city here. I'm gonna say called Pune. Awesome, your application is working perfectly fine. And let's see one more. I would say awesome.
If getting your learning started is half the battle, what if you could do that for free? Visit SkillUp by Simplilearn. Click on the link in the description to know more.
And now we are planning to develop one very special game for you in JavaScript. And now it's time to talk about another very interesting game that is known called Tic-tac. Tic-tac-toe is world's favorite game. We have already played a lot in our childhood days and it's still my favorite game. So I have decided to basically offer you this tic-tac-toe game developed in JavaScript, HTML plus CSS, which can create something really very great effects for the end users. So let's go and start developing our next game that's called tic-tac-toe. So in this tic-tac-toe, I will start working with creating a folder called tic-tac, and inside this I'm going to create a new file name called index.html. Now here onwards the same thing, I'll be creating this HTML tags, and now here onwards we want our some classes for headers and footer, but so we're going to create some div tag now. So in this div tag I'll be creating some of the tags in which the CSS class will be applied. So we're just going to create a classes. We're going to just use those classes, but we'll create it later on. So just go ahead and create those. So we are saying div. Okay. So now this point onwards, this is my first div tag. Inside this, I'll keep my h1 tag, and under this h1, I will be offering some of the headings which will be useful to contain some necessary information with regards to this game. So div, here we say h1. And inside this h1 we give the message called class equal to header, and here I'll give the name called is a tic-tac-toe game. After this div class, here we will start working with our form tag. Within my form tag I will start my div. After div tag, I will use label. So label for player 1, or else I can say player 1, and inside this let's give the name called player 1. Label is closed, and after this label we'll start working with our input tag. Input. Now in this input, what are the details I need? First I need called type equal to text number 1. Second, placeholder equal to enter name. Next, name equal to player 1. Next we want id equal to player 1, and then any class if I want to apply. Anyways, we're going to close this. This is my first text box, and same thing I would like to create for my another one. So the first div tag we have used, let me go and create another div tag. In this div tag I'll use the same label, copy the same, paste it here, and this is for player 2. So we have this 2 players with me, and after this div tag I'll offer the submit button now. Input tab to submit. Start game. Now the form tag is closed here, div tag is also closed. So you want the div tag to be closed, or before that, that's up to you now. So here we have a called div class, whichever we have taken. So if you want, you can basically put it later or before, whatever. So we have a basically form tag with us. So form tag is there. Later on you can just show some containers where the details will be visible to me. So here after the form tag, let me try to offer, but first check whether it is really working fine. So here we have this option called enter name after this tic-tac-toe. So so here the details we have taken, inputable text and inputable text. Okay, so two values we are taking now, and accordingly we will go ahead now. Finally, after the form tag, we would like to start with working with the div tag again, div, and inside this div, since I haven't created any CSS classes, so those we can use it later on, but let's have this div, and inside this div I would like to use one more div tag. Okay, and here we want to use one more div tag. So inside this div we will be using one more div tag. So in this div we can just give the value called data id equal to 0, id equal to 0. It's just the value we're passing it. Div data id equal to 0. The div tag is getting closed. Fine. So that's how we want it now. So here the first div tag is closed. Like that we can create another data id. So 0, 1, 2, total number of 3 we want to create it. So I want to create 0, 1, 2, 3, 4, 5 like this. So the way we have created here, for this div, let's go and create one more div tag, id equal to 1, 2. 3 options we have it now. Okay, like that I can keep on creating the others also. 2, 3, 4, 5. So 0, 1, 2, 3, 4, 5. Total number of 5 we have created. One more I would like to create it now here for 6. There will be no difference because we haven't changed anything here. Okay, so the div tag is getting closed here. Okay, and that's it. And if you want to create some clear board or button, that you can basically offer it a little later on, but here we can use one more div, and here we say div class equal to relative, and within this div tag I can use any image tag if I want. So I just leave it as it is, and after this I can create one more div tag, and inside this another div, okay, and under this I'm going to create a button. Okay, and in this button we'll be having some value. Okay, we can give the value name called replay. This button is created, and now we can create a clear board span, and here is a clear board. That's it. Okay, so here is just a small game I want to develop it. Better. Now there's no user interface has been used, so this user interface will be using it later on. by offering them a pure look and feel, so that it gives me more better look when your application will start. But most importantly, I need to start working with the JavaScript part where the logic will get calculated here. Okay, so we want to start with the JavaScript, so let's get included the JavaScript in my code. So here I can say here script tag, script equal to, now the file I haven't created, so let it be as it is. That's it. So this is my script tag, and let me try to include my style sheet also. So I just say link rel equals style sheet, and give the name called app.css, though I haven't created, but I'm giving it. Okay, that's it. So we have taken this HTML into our consideration. Now we'll be creating this CSS as well as the JavaScript to make this example complete. Well, we are ready with our HTML. Now it's time to basically go back and spend time on our JavaScript. So we're going to create a new file now with the name called app.js, and inside this we will start writing the logic with our main application. Okay, now the first thing is how we're going to start now. Yeah, so first thing what we need to do is we need to attach window dot add event listener, and when the window will load, some logic should happen. So I'm saying load. Second is the name of the function. So the name of the function perhaps does not exist, but I can give the name called app, which I'm going to create it shortly. Now here, first of all, let me try to create a game board. I'm saying let game board equal to, now let me have some of the values, because it is 8-digit, so we just make it like that, and one more for making it 9. Okay, so that's how we're going to create it now. Okay, now this is all empty right now. After that, we're going to create let turn, just a new variable, equal to 0. What this is, it keep tracking if X or 0 player its turn, like which player turns it to be, so just it is trying to mention it. Now I'm saying let winner equal to false. Okay, now let's go and create the player. So create player. How are you going to create a player? We say const player equal to, what we're going to pass, name. Okay, equal to, now inside this we can say name equal to name. Next we say return name. That's it. Okay, after that I'm defining let player x equal to player with the empty value, and again player y equal to player as an empty value. Now let's try to initialize the app. Okay, initialize the app. Now inside this initialize the app, we're going to create a new function app, and inside this we're going to create a variable like by saying let input field equal to, first of all, document dot get element by id. Here we're going to take the class name of this particular text field, so we are saying input hyphen field. Okay, dot focus. Okay, now after this we have to say const add players equal to, once again, document dot get element by id. We'll just give the name called player form. Okay, next we are saying add player. Okay, dot add event listener. We want to attach to the event. On which event? Submit event. And what logic? Add players. Okay, after that, once the players are added, we are saying let replay button equal to, once again, document dot get element by id, or rather I would say document dot query selector. Document dot query selector replay hyphen btn. Okay, it will be just the name, we are basically taking that, and here we say replay button dot add event listener. Which event I want to say? Click. Okay, that is the first event. Second, reset board. Reset board. That we are basically passing that. Okay, now this is the initial case which we have it. Now beyond that, I will add, this is the players what we have added it right now. It slides to add the players. So this is how we have initialized. After that, let's add players. How to basically add the players? Here we have to just define the function add players. Okay, which will take event as a parameter and say event dot prevent default. This prevent default will try to prevent the default behavior which is submitting to be get avoided. And now here we say if this dot player 1, so we just define the property called player 1. If this dot player 1 dot what value, okay, is blank, okay, or this dot player 2, this dot player 2. Now I just want to find it out its value also. Value blank. Then what I should do? In this case I'm saying alert you must enter the name for each field. The user has to add the values, and after that return. Okay, now the next thing is like we would like to select the players in this inside this by saying const player form container. Again, const player from container equal to document dot query selector. Document dot query selector. Here we will just pass the value called enter hyphen player. players. Okay, now we say const board main equal to document dot once again query selector board underscore main. Okay, after that player form container dot class list dot class list dot add. Here we're giving the name called what? Height container. Height hyphen container. And after that we just say board main dot class list dot remove height hyphen container. Okay, so we have basically taken that. And after this, what I will do, I'll just say player x dot name equal to this dot player1 dot value. Okay, this for player x. Copy this. Player y 2. And after that, that's it. So we have done it now. So we'll be calling other functions one by one, but that is the first thing which we have implemented. Well, so add player function is added right now, and after this add player we have to basically call one more, that is called, which returns the current player. So I'm saying return current player, and here what I will do is we'll just write function, and here we say current player, and in this current player what we will do is we will say return turn just variable, okay, percentile 2, we're just adding it with this 0. Okay, if it is, then x turn, I'm telling you, okay, or else so we are adding like the current player. Who says the current player right now? Well, after this adding the return current player, we're going to add another function that is known as called return the current player. Return current player is having this value, and after that we need to say resize the square in event browser is resized. Once again, if the browser is getting resized, automatically the square size of your tic-tac-toe should also get increased. So we just say resize squares, and here we're gonna say this option equal window dot add event listener. Now we have a call option called resize here, and the second parameter what we are passing is called on resize. Okay, on resize. Now let's try to add it. After this we are writing this function called function on resize. That is the function name for me, the one which we are passing into the second parameter. We are saying let all cells equal to document dot query selector all. In this we are passing board underscore cell. Okay, and then we are using another option called what? Let cell height equal to all cells with the position, okay, dot offset width. After that we are saying all cells dot for each. Here we are passing cell, and after that we are using cell dot style dot height equal to, now here we are using this backtick and use this dollar sign and say cell height, and that too in a pixel. So this will be taking the dynamic values. Okay, that's it over. Now we have to just launch our build board. Now build board. So how are we gonna build our board now? For this we are saying function build board, and inside this build board we will see this option called let reset container equal to document dot, once again query selector, and pass the value called dot reset. Okay, and after that we are saying reset container dot class list dot remove, and we are passing the value called reset hyphen hidden, this value. And after that we may call some other type of functions also. Okay, so for those functions I can say first will be called on resize. After that we are calling add cell click listener, but I do not have that function with me. So these functions we need to create it by our own. Okay, so we will just leave those for a time being. Let's go back and create another functions now. So we just want to write another event with cell click event for player to attempt to make move. So here we are trying to say cell click event for player to attempt to make move. Now this function we need to create it, so we just say function now. We just say function and give the name of the function to make move now. Function make move. It takes event as a parameter, and here we are saying console.log and say turn. Now let's go back and try to check the another condition, that is called let current cell equal to %, because we have to read the value from there, and here we are saying what, event dot current target, event dot current target dot first element child, okay, dot dataset dot id. So we're reading these values. After that we use another variable called let cell to add token. Now here we are typing document dot query selector, and here in using backtick I'm using this value called data hyphen id, okay, equal to, here we are using once again in a single quotes current cell. Okay, so this value we are taking it like that. After that, we are using this situation called if cell to add token dot inner HTML exclamatory mark blank. Once again, if cell to add token dot inner HTML equal to blank, then what next? So cell to add token dot inner HTML equal to blank, then what you should do? I'm saying console dot log and give the value the one which you want. Okay, so in this console.log, what value we can give it? Cell to add token, we have it. It is taking this value to the current cell dot inner HTML console.log, and inside my console.log we can say this cell is already taken. So values are already taken for this, and now we will be returning those values. After that, we will be using else condition, and here we use once again if current player, okay, is X, then we'll be using this option called cell. See, we have this property option available called cell to add token. So we are saying cell to add token, okay, dot text content equal to current player. Okay, and we say game board, the one which you have created, pass in this game board this value called current cell, and in this current cell value will be equal to X. Okay, else we can say cell to add token dot text content equal to current player, okay, and say game board current cell equal to like this. Okay, so here we are adding the values like that. So it is closed. After that, we can just use the function name called isWinner to check whether the user is winner or not. So we are saying is winner, okay, and after that we are saying turn plus plus. After that we are saying change. We do not have the function name called change board header names. Okay, so it's just like that we're giving it. So as usual, we can leave this function for a time being, and we'll call this little later on. So leave it as a for a time being. Okay, so your function is now ready. So the next thing what we need to check whether it is tie or not. Okay, so we are saying function check if tie. We're just checking the function whether this game is tie or not. So here we say if the condition is turn greater than 7, alert, game over. Okay, we can say game over, or we can say a tie. Okay, well, after that we are saying winner. Function is winner. Now what we will check is we will check const winning sequences. Winning sequences, and here we are having this array and having the different conditions associated. We say 0, 1, 2, probability we are checking it, and then I just copy it. Well, we are saying 0, 1, 2, and here we are saying 3, 4, 5, 6, 7, 8, and 0, 3, 6 again. 0, 3, 6, and once again 1, 4, 7, 4, 7, and next we have a call 258, 8. Then we are checking the value called 048, 8, and one more last option we'll put is called 246, 6. So these conditions we are adding it now. After this array, we can say winning sequences dot for each, and give the name called winning combos. Winning combos. And inside this winning combos, we are giving let cell1 equal to winning combos position 0. Then let copy and paste 3 times cell 2, cell 3, and here we get the value called what? 1, 2. 3 values we're giving it, and after that we are checking the condition. Let's say if, and here the conditions we are checking. What exactly that will be? For the game board, we are saying game board cell 1, current player ampersand come down, game board cell 2. I just copy this the same line and paste it multiple times. Now here we are checking the condition for cell 2 and cell 3 and cell 3, and after that we are starting the position. So after that we are starting the position call by calling this condition call const cells, and then equal to document dot get element by, document dot query selector all, and here let's select the position dot board underscore cell. Okay, then after that we will be using cells dot for each cell, and inside is what we are passing. We are saying let cell id equal to cell dot first element child. Okay, dot dataset dot id. So this is the value which we are basically adding it now, and we are using one more if condition. We are saying if cell id, now we are talking about call cell id triple equal to cell 1 or cell id cell 2 or cell ID equal to cell 3. Okay, and in that case we can use cell dot class list dot add, give the name called board, just give the class name winner. So here we'll be giving the winner, and a part of that we can use the other conditions too. Okay, so here it is adding the value, and now let's say let current player equal to document dot get element by id. So you can basically define it. So current player you want, so we can use the current player or whichever conditions you want. So here we use what? The cell winner. Now small change, rather than using current player we can use the current player text. The new variable we are creating it, current player text document dot, rather than saying get element by id we can say query selector, and in this query selector we'll be giving the value by saying dot board player hyphen turn, the value which we are giving it here. And that query selector value whichever you given this, let me try to put it in a parenthesis like this. Okay, now here we just check if current player x, then what? Then in this case we can say current player, whatever the value we are using, current player text dot inner HTML equal to, now we can define the value whichever you want to offer it. We just use a condition called div class equal to okay, so we are saying congratulations. Okay, and here we say congratulations along with dollar sign, and here we pass player by dot name, and here the div tag is getting closed like this. Okay, so that's the message we are basically printing it, and after that we give this value and say this message called winner equal to true, and after that if you want to apply remove that function we haven't written, we'll be talking about a little later on, and just say return true again. So your function is ready now, and later on we can just check the condition if winner, or we can say check if tie and return false. That's it. Now in a continuation to this example, we're gonna develop another function which the name is called change board header names. So let's continue by defining the new function called function change board header names. So this change board header names will be the new function for us, and here we would like to check whether the user is winner or not. So here we say if not winner, then what? Then in that case we have to say let current player text equal to document dot query selector. In this we'll be getting the details like dot board, and here we're gonna give the name called player and hyphen turn. Player hyphen turn. Now later on, after this particular variable, we have to just check the condition by saying if current player equal to x, if the position is x, sorry, let me try to put it in capital letter here, x, then we have to say current player dot inner HTML equal to, now here we have to just use the same option called backticks because I want to go multi-lines. That's the benefit of this backtick. And here we say in our inner HTML span class equal to name hyphen hyphen style, close this, and here we want to use the statement. Now this value we want to write it with name attribute, so it is getting closed, and here we are saying dollar with this player x dot name, and then close the span tag, and we say you are up, like this. And after that we say div class equal to, we're just going to create a class which later on we can apply the CSS style on the top of that, u hyphen r hyphen winner, and here we say closing the div tag. So the div tag is closed. That's it. And now after this line, what next we have this called else condition. Else. What else? Here we say current player text dot inner HTML equal to, after this we're going to write the span class equal to, here we say name hyphen hyphen, same option we're going to use it. So in this condition, so winner conditions, so let me try to copy the same rather than copying it again and again. I'll just copy the whole text. Span class equal to name hyphen hyphen style player, rather than saying x we have to use y, you are up, you are winner. Okay, so here it's getting closed. Well, after this what we have to do, create another function called reset board. Function reset board. Now in this function reset board we just say console.log a small message resetting is added. Now afterwards we will be using the game board, and the same game board what we have used it earlier, I'll be using the same conditions. On the top, if you remember, that was the game board for me, so I'll be using the same game board. We copy this, yeah, with the same condition. Okay, game board equal to this. After that line we will say let cell to add token, cell to add token equal to document dot query selector all. Here in this I'll be using another class called letter. Now cell to add token, whichever we've used, dot for each square, and within this square we would like to use square dot text content equal to blank. After that, square dot parent element dot class list dot remove, and here we would like to say board, okay, underscore cell winner. So these classes we yet to create, because these CSS classes we are just using this, but we haven't created. We'll be using it little later on. So that was the point. Now after that, we are defining the turn value, turn equal to 0, because we are resetting it, and winner equal to false. After that, winner equal to false, we just define another variable called define let current player text equal to document dot query selector all, document query selector all. So here we're going to use the name called board define player hyphen turn. After that, current player text dot inner HTML equal to, once again we have to use the condition for up and winner point. So let me try to copy this. Inner HTML equal to, okay, and in this we have to say player x dot name. Okay, just everything is same, no change at all. Okay, now here after that we're gonna write one more function called function add cell click listener. That means when I will be adding or clicking something to my cell, what kind of event I would like to listen. Here we are saying const cells equal to document dot query selector all. Let's check the condition board cell, and here once again we say cells dot for each dot for each, and here we say cell dot add event listener, which event I want to listen, click, and the second parameter will be handler. Once call make move. Okay, and this function which we have created called add cell clicks listener, okay, this I'll be calling it here. Perfect. Later on, once it is done, let's try to add one more function called function remove cell click listener. Remove cell click listener. Now here we say let all cells equal to document dot query selector all. Let's pass board cell, and now we say all cells dot for each cell, and here we say cell dot remove event listener, which event click and second parameter will be make. That's it. So friends, now here most of our JavaScript code is written now. So going forward, we would like to use CSS, and finally we'll be applying everything into our HTML file. Well, after the JavaScript file is ready towards my application, now it's time to go and create our HTML file now. Sorry, the CSS. So inside my Tic-tac, I have got app.js and index.html ready. Now here I'm going to create another file here called app.css. See, you can basically put this app.css in any other folder like in static folder, but I have just kept it outside. Now from this point onwards, I would like to start with my basic functionalities. Okay, what those are? Let's start with the first feature called body. With my body, some basic settings I would like to do, like in background image, background color. So I just start with background color. Background color, I can just use it as a white. Okay, but I don't think so it's really needed it. So if you want, you can have it. Otherwise, leave this background color because it's by default going to be white only. And now, next would be called height. Height will be 800 pixels. Next, background position. Background position, I just say like center. Next, background repeat, in case if you do not want to repeat the image. Background repeat, and here I say no repeat. Next, background size. Here we are saying cover. Okay, so it resizes the background image to cover the entire container. Okay, so that's what the body part. Now the next thing is we have to select the rest of the CSS classes. So first select div dot relative. Inside this div dot relative is first say called position. Position we are saying absolute. Next is top. From the top, I'm just making 760 pixels. Next, right. Right, we are just saying 120 pixels. Next, after this, we are saying height container, height dot container, height hyphen container. Here in height hyphen container, we will just display colon none. Well, after that we have to use the header point. Header. Inside this header we will say color will be by default white, but still we just say color and white. Next text line, we just say center. Next margin will be 15 pixels. Next, font family. Font family I'm selecting called permanent marker. Permanent marker. Okay, next class we are talking about called interplayer. That's called dot inter hyphen players. Now in inter hyphen players we will say color. Will once again we can use any other color, but we can just use white or any color you want, or else you can just use hash. Okay, margin we are giving it's called 0. Auto width we are looking forward for 80%. Next, text align, center, position, relative. Now, next we're going forward for input field. In this input field, we just say border 2 pixels, solid and black. Next, outline none. I do not want any outline to be there. Next, padding, I can take 4 pixels, 8 pixels, 4 pixels, 8 pixels. Now margin, we are saying 0, 0, 10 pixels. Okay, and finally 4 pixels. After this margin, we say font size 18 pixels. Okay, so that is your input field. Next, we are talking about something called input field focus. Input hyphen field, okay, colon focus. Now here, border 2 pixel, solid red, or any other color which you want to use it. Next, how you want your submit button to be. So I'm saying dot submit hyphen btn, border 2 pixels, solid and black, padding 8 pixels and again 8 pixels, font size 18 pixels. Now width 250 pixels, followed by border radius 5 pixels. Next, your margin from top, let's take 10 pixels. After that, background color, let's take white only. Okay, so this is the property. Now going forward, you can associate with your submit button active and submit button focus. So we are saying dot submit hyphen btn colon active, and two options we are taking, followed by condition outline none. Next, border, we're talking about called 2 pixels, solid, and the color red. Okay, so that's the one. And after that, we like to use hover dot submit hyphen button colon hover. What you want? Change the background color to what? White. You can use white smoke. Well, here we like to use dot board. Here we'd like to use player hyphen. These are the classes we were using in our JavaScript, we remember. And here we say color we are using once again white, or you can use this white smoke, whichever you want. So Well, later on, text align, center, margin, 10 pixels, 0 and 10 pixels. Height 54 pixels. Okay, so these are the properties initially we have taken. Okay, so after this turn, let's go and start the another classes here. I'm saying dot name hyphen hyphen style, and here we are saying color red, and then font size 22 pixels. Well, now coming back to the another properties, now we're talking about the next important called border container, called board container. Dot board container. Here we define width, which is 40 pixels we are taking, or sorry, 40% we can rather take. After that, background color, that we can say quadrant blue. Okay, next margin we are taking is a 0 and auto. After that, font size we are taking 0. Next, border we are taking 2 pixels, then solid, and then black, followed by box shadow. We remember this box shadow is one of the very CSS3 popular property. Here we are defining 3 pixels, 3 pixels, 3 pixels, 0 pixels, and RGB we can talk about called black. Okay, so my border color will be, shading color will be black. After that, we're offering this board cell dot now in this board cell we are defining width, now in this width we are using calculation CALC, and in this calculation we are defining 100%, okay, divided by 3. This calculation. After this, the next property will be display. Display will be inline block. Next, font size, we are taking 40 pixels. Well, text align, center, border, we are taking 2 pixels, solid, and black. Adding 20 pixels. Vertical align, top. Next, font family. This family I can use permanent markers. Okay, now next option, a part of this we have a call your board cell will board cell hyphen winner, I would say rather hyphen winner. Now, spelling wrong, this has to be D. Yeah, board cell winner. Let's make background color red. Okay, and later on just use letter. Now in this letter we just give the color combination, so color will be white. Next position, relative, top 50%. Next transform, translate y to minus 50%. After that, font family, we are making it once again permanent marker. Let me copy. Okay, now here next option will be called winner container. Here we're giving winner with dot winner hyphen container. Okay, so for this winner container, what are the values we want to use it? That's you want to basically do it. So if for this winner container, what I would rather suggest is you can use dot reset text align center margin 20 pixels out. That is for reset. And now reset hidden. Inside this reset hidden, we will set display none. Display none. Okay. After this, the replay button. Now we're going to talk about replay button dot replay hyphen btn, and here width we make it to 25%. Okay, and followed by padding 10 pixels. We take it from here and 20 pixels. Border, this border we are taking is called 2 pixels, followed by solid, okay, and black color. Now later on, border radius we are taking 5 pixels. Later on, outline, I'm saying none. After this outline, we say letter spacing. Now this letter spacing would be again 0. After that, text transform. This text transform value we are talking about called uppercase. Next, font size. Font size, we are taking 16 pixels. Then margin top. Margin top would be 12 pixels. Then word spacing, that you are taking 3 pixels, followed by background color. This you are taking white as usual. So this is for your replay button. Okay. Now in a similar line, we can also have call dot replay hyphen btn colon hover, followed by dot replay hyphen active. Now apply the common style outline. We are making it none. Then color, we are making it as called white. Then background color will be black. Okay, and when it comes to the congratulations, so we'll be using this dot. Okay, so this congratulations class will be using font size to what, 24 pixels, and after this we are using this called winner dot u hyphen r dot winner. In this winner we'll be taking font size, okay, that's 18 pixels. After that, height, we are taking 18 pixels again. Then line height, we are taking 18 pixels. And then margin, 2 pixels. And then 0. Okay, that's it. So last but not least, we would like to use this dot replay hyphen btn. This I'm saying width 50%. 50%. So this is what my CSS file is all set. I know it was pretty lengthy, but it is required for this particular application. Okay everyone, so we are all ready with our CSS also. Now it's time to go back to our index.html file and take care about the final finishing touch. So we have this index.html file with us, and now the CSS class which we were using it in our application, that is known as called this permanent marker. This class is not by default available, so we have to include this using this external API. So here where we have a call CSS with us, before that we want link. So within this link we want a one variable name called href equal to, now we have to give the proper location by saying https://fonts dot google apis okay .com/css question mark family equal to permanent plus marker. Okay, so if you just copy this into your browser, you will get to know where exactly it is using. Okay, if I just copy and paste it, so I just need to say https before, yeah, https fonts dot google apis.com/ oh, spelling wrong, css family equal to permanent marker. That is the main URL from where I can take this kind of font. So here CSS, so that's what I was cross verifying it. Well, it's there, we have included our CSS also, but in which class we need to use, that is an important now. JS, I also want to include it. So here in my head tag only, I would like to include script src equal to app.js. So here my script is actually loaded now. After that, if I just go back and check the final outcome of my code, which is index.html file, well, it pretty much looked like in basic. Nothing else has started when we talk about called start game. Okay, so it needs to start because there is no CSS class are attached. So I need to attach those classes within my code. So here onwards, we have to start with offering those CSS classes so that at least I can apply those common behaviors to my application. Okay, like here we have a call div. We haven't attached any class to this. After this body, we have a call div h1 class equal to header tic-tac-toe. Then we have a call div. We have a call body. Under this, we have a call another div tag. So just imagine how many type of classes are available. One, we have a call div class equal to header. Div class is closed. Again, we have a call one more div tag. So like that, multiple CSS files are there where we have to apply the new CSS class to make it happen. So now we have to just go back and change our HTML and to apply our main class. So this is what my final HTML, which looks like the same. You can see we have added all those type of CSS classes which we had, that is called enter player, player form, player container, label, placeholder, and player container. And if you see all different type of classes, we have attached this to. Okay, because here only my CSS class will get applied, and the JavaScript will apply those kind of dynamic CSS based on certain conditions. So these CSS classes are already there, added inside your HTML page. Our app CSS is ready, app.js is also ready. Now let's go back and try to reveal how it looks like. Awesome. So it looks like pretty nice. Tic-tac-toe is a game. It is expecting. When I say start game, it says you must enter a name for each field. Validation is working. Let me try to add 2 names and say start game. Awesome. So now you can see it is saying, hey, you are up. Now let me try to give the values. Awesome. Now you can see it's saying like, hey, you are a winner. Great. So guys, congratulations on this, the first example of how the tic-tac-toe game is used. So it is a classical example of CSS, JavaScript and HTML together. So this time we're going to talk about our next very interesting feature that is known as called dealing with another example that is called snake game. So snake game is one of the very powerful example which I'm going to share with you, which will help you to understand like how we offer a very simplest way of developing a mini project. Okay, that is something which is a snake game. Let's see how the snake game is important and how we're going to deal with this. These are our previous examples which we have seen, which I will call a project which we have created, that is called quiz application. And now we're going to start working with our new project. Now here, first of all, I'm going to create a new folder that is called snake game. And inside this snake game, we need some new folders. First folder I'm going to create it inside this, that is called images. And within this snake games, I'm going to create few new files that is called index.html. And here I'm going to create a new file name called app.js. And at the same time, I'll be having some of the CSS files if I need, so I can say app.css. So total number of 3 files I have it now. Let me close down all the files whichever I have opened it earlier. So now that looks cleaner approach. So this is a snake game for us from where we need to start. And we have a called index.html file. And here I will, as usual, create our basic HTML syntax. And here I would like to include our script tag, script src equal to app.js. That's it. And now going forward, we will start developing our next implementation of snake game. Now inside my body tag, I would like to have some basic property called speed. Okay, and later on I'll be taking the input from the client. So we are saying input type equal to. So here we can justify the speed and we can give id equal to game speed and followed by value equal to, we can give the value called 5, initial value, and min equal to 1, that is the minimum value, and max equal to 9. That is the maximum and minimum value we can offer. Beyond that, I won't allow the users to go. And step, that means the increment value, that is 1. Well, that is the input type. And now another input, we are taking input type equal to button, and value equal to start, and then id equal to game start. Okay, so we're giving these values. After that, I can give some breaks. So 2 breaks we are giving it, and start working with the div tag now. And in this div tag, I'll be using the canvas. It is a HTML5 feature. We use canvas, and I just give id equal to game area. That is the canvas, and after this canvas, we will, that div tag is closed here. After the div tag, I can use another div tag, div. Here I can say class equal to, I may not have any class written, but I can say class equal to relative. So later on, if I want to apply any CSS style, I can certainly apply. And after that, I can offer the images. Okay, so I may not have any images right now, so I just leave this image blank right now. Okay, and this script src, I'll load it only before my body tag get closed. It is always a good practice to keeping this script tag on a bottom of the body tag, always designed for good practice. Now this is almost ready for me. Let me check. Okay, so I can see values. Now it will go maximum 9, that is how we have given, and minimum is 1. Start is the button which is not doing anything, but later on we can allow some logic inside this. Now we have to start working with our main JavaScript tag. This is my app.js, and here onwards we will use some of the properties, okay, which I want to initialize it. So we are saying var game start equal to null, initialized. Second, game speed equal to null. Next, game area equal to null. Game area context equal to null. Then game area width equal to 0, that is in integer value. Game area height equal to 0 again. Then cell width equal to 0. Play score equal to 0 again. Next, snake equal to null. Next, snake food equal to null. Next, snake direction equal to null. Snake speed, or else I can say speed size equal to 0. Next we have a timer equal to null. So these number of properties we have initialized. Okay, Now after that we will be writing a function by saying function name is called initialize. Okay, and here in initialized we would like to use some of the properties. First we are saying game start equal to document dot get element by id. Here I can give the value called hash game start. Let me put it in double quotes, game start. Now game speed, now these all basically the values are there, game start, game speed, these all values we have to take it. Okay, so we will be seeing these values one by one. So let me say the another one that is called game speed equal to again document dot get element by id. Now we are passing the game speed, game speed. Now here once again I take another point, game area. I say game area. Here you have to give the value called game area. Okay, so these values we have taken. Now we'll be talking about called game area context. Game area context equal to game area dot get context, get, and in this game context we will be using what type of context? We are saying 2D. Okay, because I want to have the kind of 2D, so this is how the kind of environment we want to set. Next we talk about game area width equal to just initialize to 400. Next game area height equal to 600. Now cell width we are initializing with 20. Next game area dot width. Okay, so game area dot width equal to game area width, and then we define game area dot height dot equal to game area height. So these are the values we are initializing this. Okay, now after that we have to start writing the logic. Here I'm saying game start dot, now we have to line which event you would like to take. So I will say on click. So when I basically click, what should happen? So on click equal to function. So what you want to write it here? I'm saying this dot disabled equal to true. So I want to disable these values, and after that we want to call another function inside this. But which function? Let's do that. So here we are saying function start game, and here in start game we want to define the initial score. See, the initial score for the player will be certainly 0, so we say player score equal to 0. After that, direction, in which direction you want the snake to move. So we are saying snake direction equal to right, in the right direction. Then speed size, the variable which we have defined, so speed size equal to, because it will be accepting the value from the text boxes or from the drop down, so it certainly will be string type, so we have to use %. So we are using this option called %, and here we are using game speed dot value Okay, so we are using this value game speed dot value. Now here we would like to calculate certain things. What those are? First we are saying if, okay, what if condition. See, this function we are writing called start game because there are certain things which you need to make it. So like that we have to define it. So function initialize, we have started, okay, and then after that we have written on click within this. So this is what the on click we had, and there onwards we have to finish this point. And after that we've started start game, and now we'll be writing the logic for this. So here we are saying if we are saying speed size, we're saying equal to 9. We basically initialize to what? 9. Here we say else if speed size is 0, we say speed size, speed size equal to 1. That means if it is less than 0, I'll be making it minimum to 1. If it is greater than 9, I'll be making it to 9 maximum. And that's it. Okay, so after this else if condition is getting closed, we are saying speed size equal to 1. So here we just say snake equal to array. So that is my array for me. And after that we are saying snake dot push because it needs to move ahead, and here we'll be pushing it towards by saying x position 0, and then the y, and here the y value will be what? Cell width. That means how far it can go. So it will go within the width of this application. Okay, so that's how exactly we would like to make it. Okay, so here we have a call cell width which we have given here. After that, what we have to do is we have to define our own function called clear interval, and this clear interval perform any logic whichever I would like to make it. Okay, so here after that snake.push value has been given. Here I will be creating one more function here that's known as called create food. Okay, so here we're saying create food. So create food will be the function for me. Now you might be thinking where this function is, but this function will be declared soon within your application. But here first we are saying the function called clear interval with a timer. Okay, whatever the timer will be passing it, and after that this clear interval will be saying timer equal to set interval. With this we are saying create game area, create. Now here in our application, whatever the value we are giving it, that we need to basically implement. We are giving this called create food is a function we are calling. After that we are calling this clear interval. Clear interval will be just like in a typical function which is there, using this option called create game area. So this will be available to me on which the value will be taken that. Okay, and then we will be telling you how you can call this function create food and how to create it first. Well, so we are talking about a functionality called create game interval. So this create game timer is the one which we have to create it by our own. So this function which we are passing it after the saying set interval, this function is not yet there, so we have to basically go back and create this function within my application. Fine, so what we will do is just particular one we will try to comment it for a time being. Okay, so here we have a call what? Create interval. In this create interval we'll be passing any parameters which we are passed as a timer here, and here we are calling this called create food. So here after that we'll be calling this function called create food. So let's go and say function create food. and this function create food. Let's go and write the logic here. And what logic we want to write it in a create food? We say snake food equal to, and here in our curly braces we use two directions, x and y. We say in x we say math dot round, and inside this we say math dot random. After this math dot random function, we have to just take this calculation and check the another parameter called game area width minus cell width, the one which you are passing it. And here after that we'll be performing the calculation by saying cell width. Okay, so this is for our x coordinate. Similar way we would like to use for my y coordinate also. Now math dot round dot number, game area height, but here rather than using width we'll be using height, minus cell width. Let me give some space, divided by cell width. Okay, so that's where exactly it's got closed. Okay, now here our application is now ready by calling the function called create food. Like that we'll be going to create another function called create game area. Let me go and create all the functions first. So we are saying function create game area, create game area. There's another function for me. After this create game area, there will be another function I'm going to create it, that is called control. Function control. Okay, after that we're going to write one more function called function write score. There's another function available for us, control. We have a called write score. There's another function which you're going to write it down here, that is called function write score is done. Now we say create square. Create square. There's another function, and finally we'll have a call change direction. Function change direction. So that's it. So these many functions we wanted to create it here in our system. Well, we know it very well that we have taken this called create food. Create food function is already ready now. Now we're going to talk about our next function called create game area. And in this create game area, we are defining two locations, var x direction and y direction. So we say snake x equal to snake. The position we are taking is called 0, and we are saying dot x. For the x direction, we are saying var snake y equal to snake. Position we are taking once again 0 and dot y. So two directions we have taken, x direction and y direction. Now here we are starting game area context dot fill style, that you know it very well, it is a property. Fill style equal to which color you want to fill this up. So I'm saying hash white color. Okay, and then we are using this game area context again dot fill react. Now give the position values. I'm saying 0, 0, game area width, game area height. So we are basically filling the values. With color we want to use it called stroke style. Let me take this game area context again dot stroke style. stroke style equal to, now we give the another color here by saying hash. Okay, and then the next option called same, game area context dot stroke react, stroke react, and here we pass the values again 0, 0, game area width, game area height. So we're passing those values like that. And now after this we have to write a logic of the directions. Now see, when you talk about snake game, it moves left, right and center, up and down. So now in this case we have to increment the situations accordingly. So we say if the snake direction equal to right, then we say snake x plus plus. Now else if same, let's copy this, snake direction left, then what should happen? Here we say snake x minus. Okay, so we're taking like that. Let me copy this again. Now here we're taking about left, right, we say down. So in this case we say snake y plus plus, and in this case if it is up, then we say snake y minus. So these conditions we are taking it now. Now here after this else if condition, we would like to take another if condition. Now here in my if condition we are using some more lengthy statements. What's that? We say if snake x minus 1 or snake x double equal to game area width, which we have taken, divided by cell width. Okay, or we are taking this condition called snake y double equal to minus 1. Okay, so we're giving this call minus 1, or snake y equal to game area height to cell width, or here we will take the another condition here. Yeah, we will take the another condition here called, we will have another function called control, which we have created it some time back, and inside this control it will take some parameters. So what those parameters we can pass? Here we can say snake x comma snake y comma third parameter will be snake. So this would be my another function. Okay, so here we are passing the conditions just like that. Okay, now here this is available to me as a parenthesis, and here we are writing the situation for right score, which is so far the function is only created, not described more. So we are writing the right score. The score will be written here, and here we are saying clear interval because the timer will be stopped. Okay, and we are saying game start dot disabled equal to false, and after that return. That's it. So this is the logic for we have written to this particular example. Now we can use another if more conditions here just to check the behavior of my code.
If getting your learning started is half the battle, what if you could do that for free? Visit SkillUp by Simplilearn. Click on the link in the description to know more.
Well, here we have finished till this game start.disable equal to false, and we returned. Now, going forward after this return, we would like to have another condition for the snake x. So we say if snake x double equal to snake food dot x. Okay, snake food dot x ampersand snake y double equal to snake food dot y. Then in this case I will say var new head var new head equal to here x colon snake x y colon snake y. Snake x and y colon snake y. These options we are taking it. Now after that we are using this option called player score plus equal to speed size, and then we are calling create food method again, and here after that we are using the else condition, and in this else condition we are saying var new head equal to snake dot pop. Okay, and we are saying new head dot x equal to snake x, and new head dot y equal to snake y. So these values are basically associating with your heads, and after that we are saying snake dot unshift snake dot unshift, and here we are passing this option called new head. That's it. And after that we'll be starting with our for loop by saying for var equal to var I equal to 0, then I is less than snake dot length and snake dot length, and once I plus plus. Okay, later on we just use the option called create square, and in this create square we are passing snake position I dot x comma same snake dot y. That's it. So it's getting closed here, and after that we are calling the same option with this snake food. Let me copy this again, and here rather than using this we can say snake food dot x and snake food dot y. Okay, so now this values has been added into my code. Now we start working with your control. Control needs to take three parameters, x, y, and the array. So we are passing this option called control, and in this control we are taking x, comma, y, comma, array. Three parameters we are taking it. Later on we are using this option called for var I equal to 0, I is less than array dot length and I plus plus, and after that we'll be using this option called if condition, and here we say array I, which value we're passing, dot x double equal to x ampersand ampersand. Here we say array with a position called I, and in this we are saying dot y, and this position we are checking for the y condition. For the y condition, so it returns what? True. Return true. The condition. Okay, that is for if condition. Else return what? False. Now that's it. Now we are talking about this option name called write score. This write score we have to use the game area context. Game area context dot font equal to, here we'll be passing the situation. We are saying 50 pixels, and then sans hyphen serif. After that we are using call game area context again. Let me copy this, take it again, call game area context dot fill style equal to, here I'll be using the another color now. We say hash okay. Now after that we are saying once again the game area context dot fill text. Here we are saying score colon, and here we say plus player score whatever it is with game area width slash 2 minus 100, and then again game area width slash 2. So this is where exactly the right score where the data will be actually written. Okay, next we'll be having this option called create square, and this create square it takes two parameters. One we're talking about called x, second is taking y, and now here we're using this game area context same dot fill style equal to, let me give the color. After this we're using call same area and text game area text dot fill react. Here we are saying x multiply by cell width comma y multiply by cell width comma cell width comma cell width. This is what my create square is. Now we are left with only one option, that is known as change direction. It's time to figure out this last function called change direction, which takes one parameter called e. Typically we talk about for parameters. Now here we are passing this option called var keys equal to e dot, and later on we want to say if keys equal to 40, okay, ampersand snake direction equal to up. Okay, so here we say snake direction equal to down. So we are changing the directions here. Okay, now let me try to copy this, and here we use else if four times. Okay, so here we talk this 30, 40, and here we say 39, and followed by 38, followed by 37. 39, 38, 37, and here we say up. Let's change to what? Left, down, right. Here we say right, up, left. So three options we have changed, and last but not least here I will just use window dot on key down equal to change directions, and window dot on load, okay, equal to initialize. That's how exactly we want to use now. And this function what we have defined in initialize. Okay, so in this initialize we are having this game start dot on click in and all, so we have a call start game now. So this start game will be calling it here. Okay, so in start we have a call snake, we have a call snake dot push, and after that we are calling this function called what? Create food, clear interval, and here we say timer equal to here set clear interval, and here change game area slash speed size. Let's say we want to use it. Okay everyone, so our code is almost ready. So we have this complete JavaScript code ready with me. Now it's time to basically use within my HTML just to check how it may behave. So in my HTML page I have written this normal speed, number, game speed, value, button, start, we have a call game start. After that we have a call canvas where we written id equal to call game area, dev class equal to relative, and that's it. And here we have a call script src equal to app.js. So that's it what we have written now. Finally we would like to see how it may look if I try to use in my browser. Let me try to refresh. Okay, I really do not see any changes in my code. Okay, despite I'm having this, because the CSS content is actually missing. Okay, because there only my code will really look better, because if there is no CSS it won't really make good towards my application. Okay, and I also want to have certain images, but those images we will take it later on. Let me go back and try to bring CSS into this picture now. So first of all, have this index.html file with me, and here I want to use CSS. So inside my head tag we want to use link rel equal to style sheet, okay, href equal to app dot css. Okay, now here in my CSS we want to offer certain details. What those details I want to start working with? I will start with my body part. Body. So we want to offer the font family. So Font family, maybe a little bit later on I can use it. First I want to use margin. Margin 20 pixels. Auto. Later text align center. Next font size 150 pixels, also 150%, and here we want to say background image. Since I do not have any image, so I will just leave it as a blank. Okay, so just otherwise I have to say URL, and inside this URL give some values, but I leave it as a blank because I do not have any image. I will say background color. In this background color I can just use white. After that height I can just say 800 pixels. After that background position I want to use center. Then background repeat I want no repeat. Then background size cover. Okay, let's see if there's an effect in my. Okay, I see it's now in the middle. Better. Now inputs canvas, we have to basically take that. Here we talk about called input. Okay, in this input I say font size. Font size may be optional, I can make it, but let me say font size 100%. Then text align center. Then padding I want to say 5 pixels and 7 pixels. Okay, looks better now. Well, here after that I can use canvas. In this canvas I want to say the background color. I just say white. After that border radius I can say 20 pixels. Then shadow if I want to use it, so I just say box shadow. I can say 3 pixels, 5 pixels and 6 pixels, and the color is black. Let's check. Awesome. So I can see here the logic is there. So shadow you can easily see how it has been using, and that's it. And this div, I can say div dot relative position absolute top. Here I'm saying using 760 pixels. Left 120 pixels. That's it. So this is where exactly I program. Now when I say start, okay, so there may be some error here. Let's say cannot set a property of call on click null. So this we can just check this into this game start dot on click. Let's check. Anyways, we just try to fix that issue in while. But anyways, we have our created CSS, and now going forward we'll be implementing rest of the logic within my code. Okay everyone, so We have changed some names here because there was some value was mismatched, so we have basically changed those values with your properties. And now when I try to relaunch my application by this index.html file, so now in my index.html file when I try to add, so it's just as usual, same. Let me say start, and here you can see game start. When I go up, you see like it's starting right now. Okay, isn't this an amazing game right now, friends? Okay, that is the same game what you used to play it earlier. Okay, where you can just change the direction, go up, and you can see the score title being placed here. That's it. So this is where exactly the look and feel of your game has been taken, and you can just increase the speed. Suppose if you just put a value called what 0, it by default set whatever value you want to take it with a start. Now you can see based on that the speed can be justified and the example can be developed. Okay, you can see the start button is disabled because right now the user is still going on. Unless the user game is finished, this one is not going to work. Fine. So like that you can see, and automatically this will be positioned. There is one called food. That is how we have used it in my example now called app.js. You can see we are using this example name called food. Create food. So in create food of the specific interval time, this will be automatically created and the snake will eat and increase the size of the code. Okay, that's it. And now the CSS has been given. If you want to add certain image, certainly you can add it. Otherwise, this is the first game which we can see how it is running and giving you the better example.
And when it comes to programming, what's better than Java to start with? Its flexibility enables programmers to create code that works on any system, regardless of architecture or platform, thanks to its design. According to a survey, billions of computers and phones globally use Java in one way or another. Hello everyone and welcome to SimpliCode's YouTube channel. I hope you guys are doing well. Today, we'll be taking you through the Java projects and interview questions. Working on a project gives you an idea of how any programming language works. This tutorial will cover some to help you guys understand. Before we begin, updates on multiple programming videos. So if you are a programmer and want to learn something new, then consider getting subscribed to our YouTube channel and press that bell icon to never miss any updates from SimpliCode. Let's go through the agenda for today's video. We'll start this session by going through some interesting projects to work on using Java, followed by a hands-on demonstration of a few Java projects. Then, we'll go through some important Java interview questions. I hope I have made myself clear with the agenda. So without any further ado, let's get started with Java projects. Over to our experts.
The top 10 Java project ideas. So, the first project that we will deal today is the online career management system. So this particular project motto is to deal with the career management system. The system will be used for day-to-day activities like buy, return, booking, delivery and non-delivery, and self-pickup, etc. It is not easy to build this particular project all alone, as the technicality of the project is a little complex for a single programmer. I would suggest you that you get a team with you and also look out for some automation in the process by developing the relevant software. Robotic process automation is the new normal in today's life. The web-enabled interface allows the user to log in from anywhere in the world and track their career and also view the customer rating. The system is designed to integrate with financial accounting to eliminate duplication of data entry and is also scalable to grow along with your company. The system needs to be built with user-friendly screens, rich in functionality and features, and finally the major part, it should maintain a high level of data integrity. So with that abstract discussed, now let's look into the features offered by this particular online career service. As discussed in the abstract, this particular project should be providing the features of order and dispatch of the product, information regarding the customer, delivery executive, and followed by the delivery executive, we should be also having a payment window which manages the accounts and bill reports. So having said that, let's now move into the software requirements. So the software used in this particular project is the programming language, that is Java. Database is the Microsoft Access and some convenient RPA tools. And finally the IDE. The IDE for this can be anyone which has a good support for Java. The most preferable one would be the Eclipse, and then comes the IntelliJ, NetBeans, and many more. Now, creating this kind of a project will give you a valuable experience based on building a fully fledged e-commerce website or an application. I mean, this is how the world's leading applications like Amazon, Zomato, etc. are basically planned and have reached greater heights today. This kind of project on your resume could make a huge difference. And who knows, tomorrow you might even get into one of those companies and start working on their projects or build a company of your own. Followed by the online career system, we have the online voting system. Now, thinking apart from getting a job or starting a new company of your own, this is something that we all need today in this pandemic situation especially. In the current scenario, the internet has brought all the ease to our living room. It has replaced physical banking to internet banking, ordering food online, buying movie tickets, buying clothes and household items, to consult your doctor for minor issues, bill payments, and many more. Yet, for quite a long time, going to polling booth and standing in a long queue to cast a vote has been persistent, and it has been challenging for the government to motivate common people to participate in the election system and cast their vote, just because there is no other way to do such thing as such an online voting system. But all the credit can be achieved by software engineers who can make it possible soon for everyone to cast their vote to their respective candidate as their own choice with an unmatchable ease. This can be done just by click on their fingers. This is an advanced Java project developed to show online voting functionality. Followed by the abstract, we will get into the technicality of this particular project. So the first phase of this particular project has the admin phase, where the admin has the right to manage the candidates, manage the voters and their profiles and passwords, and finally election results. Followed by the admin, we have the voter or the user of this particular application. The voter or the user gets to register himself or herself into the application. Followed by that, he can use the login and logout options. And next we have the profile and password managements. So followed by that, we have the option to choose the positions to vote, and finally to cast the vote. Now, this particular project is an advanced level Java project developed to show online voting functionality. It showcases the use of Java servlets, HTML and CSS. Again, coming into the IDE. The IDE for this can be anyone who has good support for Java. The most preferable one would be Eclipse and IntelliJ. Followed by the online voting system, we will now continue with the online healthcare management. Named as the corporate Medicare management, this e-healthcare management system is a web-based project developed in Java. The main aim of this particular project is to provide effective management of data related to staff and patients in hospitals or clinics. The features offered by this particular project should be as follows. It should optimize bed occupation. The project should improve the use of operation theaters, avoiding the cancellation of operations. To know how much emergencies affect the administration of the hospital departments or services which include cancellation of operations. To optimize the allocation of human and material resources to wards and shifts. To detect the influence of certain diseases in the hospital services, and finally to find clusters of patients. The software requirement for this particular project are as follows. We need DHTML for the front end and Java as the programming language, and data mining tool which is Weka, and Oracle for the database, JavaScript for the scripting language, and finally Tomcat as our server. The e-healthcare management system is a web-based application that assists the management of staff, doctors, and patients in an easy, comfortable, and effective way. Here, the concept of data mining plays a vital role to develop an effective healthcare management system. The proposed application aims to create a friendly working environment for any healthcare centers to overcome the drawbacks in the existing system of healthcare management. This system is very reliable and flexible from all aspects, so new features and modules can be easily integrated into the system in the future. Followed by the e-healthcare management system, we have a new normal, online banking. Not interesting and arousing for a normal person, but for a hardcore programmer, it is as exciting as a roller coaster ride in an amusement park. because this is how the major national and multinational banks implement their banking facilities in a wide range so that their customers could experience the ease of banking at their fingertips. One such type of project on your resume could bring major highlight to the recruiter, especially if the recruiter is from a banking or financial based company. Online Banking System Project is a model internet banking site. This project should enable the customers to perform basic bank transactions by sitting at a corner of their home or office through a phone or laptop. The customers can access bank's website for viewing their account details and perform the transactions on account as per the requirement. Bank employees can log in and add customer and account information to perform transactions with internet banking. With internet banking, the brick and mortar structure of the traditional bank gets converted into a click and portal mode, thereby giving the concept of virtual banking a real shape. Thus, today's banking is no longer confined to branches. E-banking facilities banking transactions by customers round the clock globally. The features you can offer through this particular project are homepage for online banking site, creation of new accounts, login and logout, manage profiles and passwords, view the balance of the account, deposit the amount into the selected account, withdraw amount from the selected account, transfer the amount from one account to another, close the account. So the software requirements for this particular project are Java programming language and JavaScript for scripting language and Oracle for database and Tomcat for server. So followed by the online banking project, we have the online examination project. Online exams are normal for us nowadays, but this is totally limited to high-end exams like CET, GRE, CAT, etc. The requirement for this particular project is increasing day by day because of the current scenarios. Many schools and colleges have now turned towards the online education system and are looking forward to hosting online exams for student safety. Online examination is a simple project developed to provide an online platform for faculty and students to conduct online examinations and their evaluations. This particular project has two parts. First is the admin part. Admin has the right to add students, create one-time login, adding questions, receive answers, and finally to evaluate. Followed by the first part, we have the second part which belongs to the students. So the students can log in, update their profile and password, select answers for the MCQs, write answers to questions, and finally closing the session and log out. This particular project can be made a grand success by making use of simple Java servlets and Java programming languages and server like Apache Tomcat. Followed by the online examinations, we have the Smart City. Smart City Java project can be a web-based software developed to store the details of a particular city. The main purpose of the project is to help tourists and other visitors to a city by providing information about hotels, transportation facilities, air ticket booking, shopping details, city news, etc. The Smart City Java project serves the visitors as a guide of the city, and hence the project is called as City Guide Project in Java. Using this project, the details of the city can be accessed from anywhere at any time. The implementation of this city project promotes tourism and business effectively. Hotels can be searched more easily from anywhere. With the help of this online software, students can look out for academic institutes located in the city. You can view the complete map of the city using this project. Followed by the abstract, we have the features of this particular project. The features offered in this particular project are login, update profile and password, search for the options, select an option like booking a ticket or hotel or anything like transportation, etc. And finally selecting that particular option, booking that option and payment window. Finally, the confirmation of the order. This particular project can be fulfilled by using the following software tools as mentioned below. They are the Java programming language, Tomcat server, scripting languages like JavaScript, etc., and database as Oracle for interactive data storage. This could be escalated to another level by following. Design drones that can act like a cop, act as a tourist guide for the people touring the city, a drone that has capability to take pictures, videos of suspected activities and store it for future reference. A drone can intimidate a cop if any suspected activities are detected. There can be many drones in the city with different functionalities, and finally, you are required to implement the functionality of the drone to the users to interact with the drone. Users could be travelers or cops or travel agents or cab agents. The code for all these projects are provided in the description box below. Followed by the smart city, we have the bug tracking system. The bug tracking system is a web-based application developed by Java programming language for software companies. The main aim of this project is to manage the errors or bugs that occur during the software development phase and cycle. After the implementation of this project, the employees can update the issue details, solve the issues, and update the system for any location with internet access. Below are the features of this project, and source code of this project is linked in the description box below. Coming into features, the software is applicable in managing the bugs that occur during the development of software and tracking the older issues. It facilitates searching the facility to bug history and solution. The system is fully secured and authentication method is adopted to manage security. It stores the older bug reports so that they can easily be solved when they reappear. The application helps the project manager in evaluating the works of the employees. And finally, the proposed software is capable of auto update when the latest version is available. So the software requirements for this particular project are programming language, which is Java, web-based applications such as JDBC, JNDI, servlets, JSP, and Oracle database or Access database as the database. Followed by that, the server deployment is Red Hat, JBoss, AS, etc. And the client-side scripting as the JavaScript. And the IDE for this particular project would be Eclipse with all the My Eclipse plugins. And finally, the user interface can be designed using HTML and CSS. So with this, we can move ahead into the next project, which is the facial recognition. The face recognition with OpenCV is an open source computer vision library that has tons of modules like object detection, face detection, and augmented reality. The major features that this particular project offers are managing the use of faces, facilitate face identification, easy login and logout, store face IDs, identify suspects with just images, enhanced way to find cyber criminals. So followed by the features, now we should look into the software requirements to build this particular project. So the programming language we need for this particular project is Java, and followed by the programming language we need the Apache Ant framework, Ming W64, and finally the CMake framework. So followed by the facial recognition project, we have the next project, which is the vehicle recognition. So Java ANPR is a number plate recognition software which implements algorithmic and mathematical principles from artificial intelligence, machine vision, and neural networks. So the features offered by this particular project are high-level language for numerical computation, interactive environment for iterative exploration, mathematical functions, built-in graphics, functions for integrating MATLAB, and many more. So this particular project can be fulfilled by using OpenCV and Java programming language along with some natural language processing algorithms. So followed by vehicle recognition project, we have our last project, which is the speech recognition system. So speech recognizer converts audio to text. Java x.speech.recognition package defines the recognizer interface to build speech recognition plus a set of supporting classes and interfaces. So the features or stages in this particular project are to create a speech recognizer, allocate resources, load and enable grammar, attach result listener, commit changes, and finally provide the process results. So this particular library is readily available in Java, and you can code this project using the Java programming language and an IDE such as Eclipse.
So in this session, we are going to focus on a particular project. And the project we are going to focus is about an ATM application. So you might have interacted with different ATM stores in your cities where you go in, you insert your card, you enter your PIN, and then you can view the balance, you can withdraw some amount, you can also deposit some amount from the ATM. So we will try to look at it from that perspective, and we will see what kind of different Java and OOPS concepts we can use to build such ATM application. This is not a super versatile application, but this is just to give you the idea of how to use those OOPS concepts to build a simple or a complex Java application. So let's start from the options menu class, because that will give us the understanding of what kind of functionality I'm using. And here you will use that I'm using different concepts which I have taught you so far in this particular series. So for example, we are using the IO exception, we are using the hash map class, we are also using a scanner class, which is used to take input from the command line. So this option menu class is extending the account class, and I will come to the account class in a while, but let's see what this option menu class is doing. This particular class has it is using a decimal format money format class, which is to denote what kind of format of money you have. Then we have a hash map, which is storing the couple of records of account number to pin mapping. So we create a map, and inside the get login method, we add couple of entries to the map. Here, the first entry, the first integer is pointing to the customer number, and the second integer is pointing to the pin of the account of this particular customer number. So if we call the get login method, this method will insert the data. After that, it will ask the customer to enter the customer number, which has to be one of these two. If you provide any other value, then there should be a logic in the application to reject the input. So whatever customer number the customer inputs, we pass that inside this particular method called set customer number. Again, I will come back to that. And once you have provided a valid customer number, then this method is going to ask you to enter a PIN number. And remember, I told you this is the customer number to the PIN number mapping. So whatever customer number you select from here, you will be providing the corresponding PIN number. And again, if you provide an invalid PIN number, you will get an error. So that will all happen inside this try block. And if you enter any invalid characters in the PIN number or the ATM customer number, then you will get an exception, which I am writing inside the catch block. This is all what we have seen so far. After the successful enter of the customer number and the PIN number, I fetch those values from these two methods. Again, I will talk about what these methods are doing. And again, I'm doing some basic validation checks. But things get interesting in this method. So what we covered so far was the get login method. Let me close this method here. So we covered the get login method. The second method, which is defined in this particular class, is the account type. So here we will ask once the customer has provided the customer number and the PIN number, we will ask the customer to provide the account type. This application supports two different account types, which are checking account or a savings account. So the customer has to choose one of them. Again, we will be taking the input from the command line using the scanner class. And then I'm using a switch case. If the customer entered 1, then I will execute some code for the checking account, which is defined here in the case 1. And if the customer entered 2, then the case 2 will be executed. And if it enters 3, then I will exit the application by just printing a sys out. So here I'm using the switch case construct to provide different options to the customer. There's also a default case specified here, which says invalid choice. So this is what is happening in the get account type method. The next method is if the customer has used the option 1, then we call the get checking method. So let's go to the get checking method, which is the next method which is defined in this particular class. So if the customer has selected a checking account, then we provide the following functionality to the customer, which is the customer can view the balance, customer can withdraw the funds, customer can deposit the funds to the checking account, or they can just exit the application. And again, I'm using a switch case here. Based on the customer types 1, 2, 3, or 4, the corresponding case block will be executed. For example, if the customer wants to view the balance, then this block will get executed, and I call the get account type method. If the customer selects the 2 as the withdraw fund, then get checkings with withdraw input method gets called, and then get account type gets called. Similarly, if the customer enters 3, then we deposit the fund, and for that also I have defined a method. I will go to the definition of these methods as we go along, but right now we are just building the framework. So the get checking deposit input method will be called whenever the customer selects the option 3. And for option 4, we just exit the application. So this is what is happening in the get checking method. Now, if from the account selection, if the customer selected second option, which was savings account, then we were calling get saving method. So this is where the get saving method is defined. And again, it is following the exact same format as we saw in the get checking method, where we present the following options like viewing balance, withdrawing the funds, and depositing the funds in the savings account. And I have some methods defined here. For example, get saving withdraw input, get saving deposit input. So we define the switch case here based on the customer's choices here. And that is what is happening in the get saving method. So let me close this method as well. And that's all what is defined inside the option menu class. So we ask the customer to enter the customer number, the PIN number from this get login method. Then based on that, we provide the customer the options to choose the account type, whether they can choose the savings account or the checking account. And based on that, whatever account type they use, we call the get checking or get saving method. And inside this method, we provide the customer the other options to either withdraw the money, deposit the money, or view the balance. That is what is happening inside this option menu class. Now let's go to the account class, and all the methods which we saw here will be provided a definition in the account class. You also see this option menu is extending the accounts class, so an inheritance concept is being used here. Let's go to that is also defined here in terms of the getters, get PIN number and get customer number. Similarly, we also have the getters for the checking balance and the saving balance member variables. We do not have the setters for them because they are not technically setters, but we have to calculate the balance. It's not a simple setter where you can just return the value. So now let's look at some of the business functions of the account class. How do you deposit? How do you view the balance? How do you withdraw the balance, etc. So you see these two methods, which are specifically when the customer is trying to withdraw the money from their account. And these methods are basically called internally by other methods. So we will come to that. Let's just understand that we have two methods for calculating the withdrawable amount or executing the withdraw transaction for the checking account and the savings account. Similarly, I have two more methods here, which are calculating the depositing for the checking account and calculating the depositing for the savings account. And then we get the bigger methods, which are using these calculation methods. So I defined 4 calculation methods so far: calc checking withdraw, calc saving withdraw, calc checking deposit, and calc saving deposit, basically withdrawing and deposit for both of the classes. And then we have these business functions called get checking withdraw input and get saving withdraw input, get checking deposit input, and get saving deposit input. So these getter methods are something which were being called from the option menu class, if you remember. If you go back to the option menu class, and if you chose the checking account, you get these options. And let's say you chose option 2, which was withdraw funds, or option 3, which was deposit funds. Then the corresponding methods which were being called were get checking withdraw input and get checking deposit input. And this is the exact same method, get checking withdraw input and get checking deposit input. So if you see what is happening inside this particular method is a couple of sysouts. Then we take the scanner input amount and we convert that amount to the double. After that, we check if the amount which the customer wants to withdraw is smaller than the checking balance or not. And I'm running this condition to check that. If the amount is smaller than the checking balance, then we call the calc checking withdraw method, which was defined right here. Remember, I told you that these 4 calc methods will be used, and this is how they are used. So here I'm actually subtracting the value. So whatever amount the customer wants to withdraw, subtract that from the main balance and then return the new main balance. That's what you do, right? If you have 1,000 rupees and if you want to withdraw 500, you subtract 500 from 1,000 and then you send back the remaining balance. So that is what is happening when we call this method, and then we print the new checking account balance. That is what is happening in the get checking withdraw input method. Similarly, if you chose option 3, which was depositing funds to the checking account, then get checking deposit input gets called. and it is defined right here, get checking deposit input. And here, instead of subtraction, we are doing the addition. So here I'm again doing a condition check that the current balance plus the new amount which has been supplied by the customer from the command line, the total sum of it should be greater than 0. What if the customer entered an amount minus 5,000? I should not allow that. So that's the reason I'm putting this condition in place. And if the current balance plus the new amount which is supposed to be deposited to the account, the sum of it is greater than 0, then call the calc checking deposit method. And this is where the calc checking deposit method is present, and where I'm just doing present balance plus the new amount and returning the new balance. That's all which is being done here. And you will see exactly similar logic running for the savings account as well. If you look at the get saving withdraw input, which is used to withdraw money from the savings account. So I take the input from the command line and I run a condition check that the amount which the customer wants to withdraw should be less than the current saving account's balance. If yes, then call calc saving withdraw method, which is defined here, where I subtract the amount from the current balance and I return the new balance. And similarly, you will see the exact same functionality in the get saving deposit, where we add the money instead of subtracting the money. And this is all what is defined in the account class. So we talked about the option menu class, we talked about the account class, and now we have the ATM class, which is the entry point, which basically initializes the option menu class and calls the get login method. Remember, get login was the first method which asked you to provide the customer number, and then get login called the method to choose the account type, and the account type methods then called the method to choose the option to withdraw, deposit, or exit. So now we have built a fair understanding of what is happening in this application. So let's run this application. So I just ran this application, and let me bring the console here. It's first asking for a customer number. So I will go to the option menu class and I will pick up one of the customer number which I have hard coded here. So I will provide that customer number and hit enter. Then it asks me for the PIN number. So remember, you have to provide the correct PIN number corresponding to the customer number. So I'm taking this PIN number, just copying it and pasting it here. Then this whole code got executed, and then it called the get account type, and the get account type method provided you with these options, which you see here on the screen. So based on what you select, the case block will get executed. And let's say I want to go for a checking account. So I press 1 and I hit enter. Once you select the checking account, the case 1 gets selected and it calls the get checking method. And the get checking method again provides you with another menu, view, withdraw, or deposit, or exit. So let's say I want to deposit funds. So I press 3 and hit enter. It says the current balance is 0 and enter the amount you want to deposit. Let's say I want to deposit 500 and I hit enter. You get the message saying the new checking account balance is 500 and you have successfully deposited the money. And that is what I did for the checking account. Now let's try to withdraw something from the checking account. So you again get back the same option, because inside the get checking method, we call once we have successfully done the business operation, we again call the account type method to display the menu again to the user. So let's say again select the checking account class, and this time I want to withdraw the funds. Remember, I've added 500 there. So let's say I want to withdraw, so I choose the option 2 as the choice. Current balance is 500 and it's asking me the amount you want to withdraw from the checking account. So I enter, let's say 100, and I hit enter. When I do that, the new checking account balance becomes 400. So the 100 got subtracted from the 500 and the new balance is shown to your screen. You can do exactly the same thing for the savings account as well. And let's also run a negative condition. So I again select the checking account and I want to withdraw the funds. I choose the option 2. Current balance is 400 and I would like to withdraw 1000. What happens? If you do that, we get a message saying balance cannot be negative. And this is coming from the calc checking method, which is defined here. So what is happening that I wanted to withdraw the funds from the checking account, and here get checking withdraw input got called. Here, this condition was checked. So the checking balance was 400 and the amount I wanted to withdraw was 1000. So 400 minus 1000 is not greater than equal to 0. So it jumped into the else block and it said balance cannot be negative. So this is how you can also build some error conditions in your code which are mandatory and which should be built. Otherwise, your application will have a lot of bugs. We can also exit the application. So if you just type 3 and hit enter, you will exit from the application and it will again call the login method where it will again ask you to enter the customer number. So this is how you can run this application, and this was a simple use case for you to show how you can use the different object-oriented concepts like classes, objects, methods, setters, getters, switch case, etc. to build the application with the correct business logic. And this is all I want to cover in this particular session. And in the next session, we are going to have a look at another interesting core Java project just to build our understanding more better about the core Java concept.
Choose from over 300 in-demand skills and get access to 1,000 plus hours of video content for free. Visit SkillUp by Simplilearn. Click on the link in the description to know more.
Let's get started with walking through a core Java project using all the different OOPS concepts we have learned so far. So in this example, we are going to have a look at a calculator application, and this calculator application supports primarily 4 different operations like addition, subtraction, multiplication, and division. So let's see how do we build that app. So in front of me right now is open the main class. So I have a main app class here, which has a public static void main method. And the first thing we see is a read input class, which is calling a read method. So if you go to the read input class, it has a simple static method here, which is the read method, and it is using the scanner class. If you remember, I talked about the scanner class, which is used to take inputs from the command line from the user. So we initialize the scanner class and we start taking the inputs, and whatever the user inputs in terms of the expression, let's say the user entered 4 plus 5 or whatever, that whole expression gets sent back into this input line as a string. And that comes back here in the input expression. Once we have captured the input expression, the next thing we do is divide the input expression in the numbers and the operators. Basically, an expression would be either something like 4 plus 5 into 3 divided by 2, let's say. Let's say the user entered this expression. So this has either numbers or operators. So that's what we are doing here. We are using the split method of the string API, the string class basically. And this split method is going to split the numbers and operators into 2 different string arrays. And here I'm providing the split expression that split at every time you encounter one of these symbols. So this, when you execute this particular statement, it is going to return a numbers array, which will be created based on this expression. So you will get an array with 4, 5, 3, and 2. And similarly, in the operator array, you are going to split or pick out the elements every time you receive a number. So this operator array is going to hold this plus sign, this multiply sign, and this divide sign. Hope you get the understanding that we are just splitting the whole expression into 2 different arrays, where first array is holding only the numbers and no mathematical expressions, and second array is just holding the mathematical operators and no numbers. And we'll see why we need to do that in the upcoming lines. Once I've created this string array, I just want to store or convert these string arrays into a queue. So I convert this array into a list by calling the array.asList. So this expression is going to return a list. And then I'm going to convert this normal list into a linked list, and then going to store this linked list into the queue of numbers. And I'm going to do exactly the same thing for the operator array as well, converting this into a generic list, converting that generic list into a linked list, and then storing this linked list as a queue. So I have an operators queue and I have a numbers queue. Both of them have been stored into a queue now. And then I'm using the poll method. If you remember, the poll method of the queue is used when you want to fetch the first front element, the head element of the queue. So whichever element is sitting at the head of the queue will be taken out the moment you call the poll method. So I fetch the first number from the numbers queue. So in this case, 4 will be fetched here in this variable. And after that, I run a loop on the numbers queue. And I'm going to run this particular loop till this particular queue is not empty. If you see, there's a negation here. So I'm going to pick up numbers one by one from this numbers queue till the number queue becomes empty. And inside the loop, I do the exact same poll operation for the operations queue. So this operations queue is holding all these mathematical operations like plus, star, and divide. So I'm going to pick the head of it. So in this case, plus will be picked up and will be stored in this variable called OPR. And then I'm going to run a switch case on this OPR. Basically, as I told you, in this particular calculator application, we are supporting 4 operations, which are addition, subtraction, multiplication, and division. So I define a case for each of the mathematical expression. So you see there are 4 different cases here. And for each case, I'm initializing a class. If it's a plus sign, then I'm initializing the add class. If it's a minus sign, then I'm initializing the subtract class. For multiplication, I have a class called multiply. And for division, I have a class called divide. Let's have a look at what these classes are containing. So if I go to the add class, first of all, it is implementing an interface called operate. And this operate interface has just a single method called getResults, which is accepting a variable argument array. If you remember, I told you that you can also use a var_arg array. This is called a var_arg expression. This means that this numbers will be an array of arbitrary length. It can be a 1-element array, it can be a 2-element array, it can be a 4-element array, or whatever you supply. But it is still going to be a fixed length array, but the length is going to be dependent upon how much argument you supply to this particular method. So that is what this interface operate is doing. It just has one method declared, which is called getResult, which is accepting an array of numbers. So if the add class is implementing the operate interface, then it has to override the getResult method. And here it is just doing a summation of all the numbers which have been supplied. So if you supply 4 numbers, it is just going to add up those 4 numbers and return the sum. And the exact same kind of logic or similar logic will be seen in other operate classes. So if I go to the subtract class, it runs the exact same operation, but it subtracts the values. If I go to the multiply class, it is also implementing the operate interface. And in the getResult, it is just multiplying all the values. Similarly, in the divide class, it is also implementing the operate interface, and it is dividing all the numbers one by one. So it's doing pretty much the same thing in terms of the expression and the logic. The only difference is whether you are using an add operation or a subtract or a multiply or a divide. So we have checked all these classes and the operate interface as well. And let's go back to the main app now. Now you also see that I've defined a reference of operate here, and each of the switch case block, I'm assigning the object type to this interface reference. So I'm using the concept of dynamic binding, which we talked about when we talked about interfaces, that we can also do dynamic binding where we can assign an object to an interface type. And the object type will depend upon the expression. So once we have filled that based on the case, while filtering out this expression and picking up plus, star, and divide sequentially, then we go to the next line outside the switch case block, which is to pick the next number from the queue. Remember, we already did one poll here. So as per this example, 4 was here in this res. And now when we do this numbers.poll again, 5 will be picked up because that will be the next head of the queue. So we pick up 5 here, and then we call operate.getResult. Now this getResult will be called based on the expression which was encountered first in the queue. Again, looking at the example, the first expression encountered will be plus. So the expression was plus. So the operate type object is of add type. And when you call operate.getResult, the getResult method of add class is going to get invoked, and it is going to sum 4 and 5. This res is holding 4 right now based on what I described here, numbers.poll. And this num is holding the second operand, basically 5 here. So 4 plus 5 gets evaluated here in this case. And then it again goes back here and it checks if the number queue is now empty. No, it is still not empty because we still have 3 and 2 left there. So again, it does the operations.poll and it picks up multiply sign here. Then it again runs the switch case. Since it's a multiply sign, it will go here and it will initialize the operate interface reference as the object of multiply class. Then coming here, it will do a numbers.poll, and this time the numbers.poll is going to pick up 3. So 3 will be picked up here, and then the current value of result, which is already 9, 4 plus 5 was 9. The current value of result will be updated here. So res will be 9 here and num will be 3 here. And when you call operate.getResult, the multiply classes getResult will get called and it will say 9 into 3, which will become 27. It will again go back here to this particular line and it will check again if the numbers queue is now empty. No, it is still not empty because we still have one element left. Then it polls the queue of the operations where the expression divide is present there, which is the only element left in this particular operations queue. And since we have the OPR value as divide, this case block gets called and the new divide class gets initialized. The divide class basically gets initialized. And we come here and we do numbers.poll. Now the last number which is available in this queue is 2, which gets picked up here. And then we again call operate.getResult. This time, since the operate operate reference type was of divide class type, so when we call operate.getResult, the divide operation or the getResult method of the divide class, basically this method will get invoked and it will divide the current value of result, which was 4 plus 5, 9 into 3, which was 27. So it is going to divide 27 by 2, which was the last value of the numbers.poll. It is going to execute 27 by 2, and whatever value it gets, it is going to store a value back into the rest variable. And then it is again going to go back here and again going to check the condition if the numbers queue is not empty, but now the numbers queue is empty because 2 was the last element. So it is going to come out of the loop and it is going to print the final result. That is how this whole program is working. Now let's try to see this in action and we'll try to execute the exact same expression. So if I right click and go to run as and run this as Java application, and I supply an expression saying 4 plus 5 star 3 divide 2. And if I now hit enter, I get the value as 13.5, which is exactly what we ran through because 4 plus 5 will be evaluated first, which will result into 9. Then 9 into 3 will be 27 and 27 divided by 2 will be 13.5 exactly. So this is how this whole program is running, where we first take the inputs and then we divide the input into numbers and operation arrays or in fact queues. And once we have those queues built up, then we pick up the first number and we keep running this loop till the numbers queue is not empty. Inside the while loop, at each step, we pick up the first expression or the operator. We check what is the operator, whether it is an addition, subtraction, multiplication, or division operator. And whatever kind of operator we have, we initialize the corresponding class of it, and then we fetch the next value in the numbers queue, and then we call the get result based on the expression, and whatever result we get from the get result, we store it back into the rest variable. So we keep updating the rest variable at every step. So that's the reason the result of 4 plus 5 gets stored in the rest, and next time you are calling the get result for a multiply operation, here the rest value is 9 now, and it says 9 into 3. Again, in the next time, the rest value will be updated to 27 because we are storing the result back into the result variable. So this is all I want to cover in this particular session, where we looked at an example of a calculator application purely from the console standpoint. Obviously, there can be a lot more stuff which we can do into this particular application, make it more error-free and cover a lot of corner cases like validating the inputs, etc. Also, looking at putting some conditions around the exception handling the divide by zero scenario, etc., which is not here. But this is just to show you the basic idea of how you can build simple to complex CLI applications using the core Java concepts. So in this example, we are going to have a look at a calculator application. And this calculator application supports primarily 4 different operations like addition, subtraction, multiplication, and division. So let's see how do we build that app. So in front of me right now is open the main class. So I have a main app class here, which has a public static void main method. And the first thing we see is a read input class, which is calling a read method. So if you go to the read input class, it has a simple static method here, which is the read method, and it is using the scanner class. If you remember, I talked about the scanner class, which is used to take inputs from the command line from the user. So we initialize the scanner class and we start taking the inputs, and whatever the user inputs in terms of the expression, let's say the user entered 4 plus 5 or whatever, that whole expression gets sent back into this input line as a string. And that comes back here in the input expression. Once we have captured the input expression, the next thing we do is divide the input expression in the numbers and the operators. Basically, an expression would be either something like 4 plus 5 into 3 divided by 2, let's say. Let's say the user entered this expression. So this has either numbers or operators. So that's what we are doing here. We are using the split method of the string API, the string class basically. And this split method is going to split the numbers and operators into 2 different string arrays. And here I'm providing the split expression that split at every time you encounter one of these symbols. So this, when you execute this particular statement, it is going to return a numbers array, which will be created based on this expression. So you will get an array with 4, 5, 3, and 2. And similarly, in the operator array, you are going to split or pick out the elements every time you receive a number. So this operator array is going to hold this plus sign, this multiply sign, and this divide sign. Hope you get the understanding that we are just splitting the whole expression into 2 different arrays, where first array is holding only the numbers and no mathematical expressions, and second array is just holding the mathematical operators and no numbers. And we'll see why we need to do that in the upcoming lines. Once I've created this string array, I just want to store or convert these string arrays into a queue. So I convert this array into a list by calling the array.asList. So this expression is going to return a list. And then I'm going to convert this normal list into a linked list, and then going to store this linked list into the queue of numbers. And I'm going to do exactly the same thing for the operator array as well, converting this into a generic list, converting that generic list into a linked list, and then storing this linked list as a queue. So I have an operators queue and I have a numbers queue. Both of them have been stored into a queue now. And then I'm using the poll method. If you remember, the poll method of the queue is used when you want to fetch the first front element, the head element of the queue. So whichever element is sitting at the head of the queue will be taken out the moment you call the poll method. So I fetch the first number from the numbers queue. So in this case, 4 will be fetched here in this variable. And after that, I run a loop on the numbers queue. And I'm going to run this particular loop till this particular queue is not empty. If you see, there's a negation here. So I'm going to pick up numbers one by one from this numbers queue till the number queue becomes empty. And inside the loop, I do the exact same poll operation for the operations queue. So this operations queue is holding all these mathematical operations like plus, star, and divide. So I'm going to pick the head of it. So in this case, plus will be picked up and will be stored in this variable called OPR. And then I'm going to run a switch case on this OPR. Basically, as I told you, in this particular calculator application, we are supporting 4 operations, which are addition, subtraction, multiplication, and division. So I define a case for each of the mathematical expression. So you see there are 4 different cases here. And for each case, I'm initializing a class. If it's a plus sign, then I'm initializing the add class. If it's a minus sign, then I'm initializing the subtract class. For multiplication, I have a class called multiply. And for division, I have a class called divide. Let's have a look at what these classes are containing. So if I go to the add class, first of all, it is implementing an interface called operate. And this operate interface has just a single method called getResults, which is accepting a variable argument array. If you remember, I told you that you can also use a var_arg array. This is called a var_arg expression. This means that this numbers will be an array of arbitrary length. It can be a 1-element array, it can be a 2-element array, it can be a 4-element array, or whatever you supply. But it is still going to be a fixed length array, but the length is going to be dependent upon how much argument you supply to this particular method. So that is what this interface operate is doing. It just has one method declared, which is called getResult, which is accepting an array of numbers. So if the add class is implementing the operate interface, then it has to override the getResult method. And here it is just doing a summation of all the numbers which have been supplied. So if you supply 4 numbers, it is just going to add up those 4 numbers and return the sum. And the exact same kind of logic or similar logic will be seen in other operate classes. So if I go to the subtract class, it runs the exact same operation, but it subtracts the values. If I go to the multiply class, it is also implementing the operate interface. And in the get result, it is just multiplying all the values. Similarly, in the divide class, it is also implementing the operate interface, and it is dividing all the numbers one by one. So it's doing pretty much the same thing in terms of the expression and the logic. The only difference is whether you are using an add operation or a subtract or a multiply or a divide. So we have checked all these classes and the operate interface as well. And let's go back to the main app now. Now you also see that I've defined a reference of operate here, and each of the switch case block, I'm assigning the object type to this interface reference. So I'm using the concept of dynamic binding, which we talked about when we talked about interfaces, that we can also do dynamic binding where we can assign an object to an interface type, and the object type will depend upon the expression. So once we have filled that based on the case, while filtering out this expression and picking up plus, star, and divide sequentially, then we go to the next line outside the switch case block, which is to pick the next number from the queue. Remember, we already did one poll here. So as per this example, 4 was here in this res. And now when we do this number.poll again, 5 will be picked up because that will be the next head of the queue. So we pick up 5 here, and then we call operate.getResult. Now this getResult will be called based on the expression which was encountered first in the queue. Again, looking at the example, the first expression encountered will be plus. So the expression was plus. So the operate type object is of add type. And when you call operate.getResult, the getResult method of add class is going to get invoked, and it is going to sum 4 and 5. This res is holding 4 right now based on what I described here, numbers.poll. And this num is holding the second operand, basically 5 here. So 4 plus 5 gets evaluated here in this case. And then it again goes back here and it checks if the number queue is now empty. No, it is still not empty because we still have 3 and 2 left there. So again, it does the operations.poll and it picks up multiply sign here. Then it again runs the switch case. Since it's a multiply sign, it will go here and it will initialize the operate interface reference as the object of multiply class. Then coming here, it will do a numbers.poll And this time the numbers.poll is going to pick up 3. So 3 will be picked up here. And then the current value of result, which is already 9, 4 plus 5 was 9. The current value of result will be updated here. So res will be 9 here and num will be 3 here. And when you call operate.getResult, the multiply classes getResult will get called and it will say 9 into 3, which will become 27. It will again go back here to this particular line and it will check again if the numbers queue is now empty. No, it is still not empty because we still have one element left. Then it polls the queue of the operations where the expression divide is present there, which is the only element left in this particular operations queue. And since we have the OPR value as divide, this case block gets called and the new divide class gets initialized. The divide class basically gets initialized and we come here and we do numbers.poll. Now the last number which is available in this queue is 2, which gets picked up here. And then we again call operate.getResult. This time, since the operate reference type was of divide class type, so when we call operate.getResult, the divide operation or the getResult method of the divide class, basically this method will get invoked and it will divide the current value of result, which was 4 plus 5, 9 into 3, which was 27. So it is going to divide 27 by 2, which was the last value of the numbers.poll. So it is going to execute 27 by 2 and whatever value it gets, it is going to store the result value back into the rest variable. And then it is again going to go back here and again going to check the condition if the numbers queue is not empty, but now the numbers queue is empty because 2 was the last element. So it is going to come out of the loop and it is going to print the final result. That is how this whole program is working. Now let's try to see this in action and we'll try to execute the exact same expression. So if I right click and go to run as and run this as Java application and I supply an expression saying 4 plus 5 star 3 divide 2. And if I now hit enter, I get the value as 13.5, which is exactly what we ran through because 4 plus 5 will be evaluated first, which will result into 9. Then 9 into 3 will be 27 and 27 divided by 2 will be 13.5 exactly. So this is how this whole program is running, where we first take the inputs and then we divide the input into numbers and operation arrays or in fact queues. And once we have those queues built up, then we pick up the first number and we keep running this loop till the numbers queue is not empty. Inside the while loop, at each step, we pick up the first expression or the operator. We check what is the operator, whether it is an addition, subtraction, multiplication, or division operator. And whatever kind of operator we have, we initialize the corresponding class of it. And then we fetch the next value in the numbers queue. And then we call the getResult based on the expression. And whatever result we get from the getResult, we store it back into the rest variable. So we keep updating the rest variable at every step. That's the reason the result of 4 plus 5 gets stored in the rest. And next time you are calling the getResult for a multiply operation, here the rest value is 9 now, and it says 9 into 3. Again, in the next time, the rest value will be updated to 27 because we are storing the result back into the result variable. So this is all I want to cover in this particular session, where we looked at an example of a calculator application purely from the console standpoint. Obviously, there can be a lot more stuff which we can do into this particular application, make it more error-free and cover a lot of corner cases like validating the inputs, etc. Also looking at putting some conditions around the exception handling the divide by zero scenario, etc., which is not here. But this is just to show you the basic idea of how you can build simple to complex CLI applications using the core Java concepts. Let's get started with Spring Boot and how we can build a simple application using Spring Boot. Before we go further, let's understand why we need Spring Boot. And the basic idea of Spring Boot is to build RESTful web services. If you want to know more about what are RESTful services, please, you can read about the RESTful concept as a concept. What does REST stand for? But the basic idea is that if you are accessing anything over HTTP, then that
particular component can be built as a RESTful component. And Spring Boot is the most popular choice for building RESTful web services today. And even in fact microservices, which you might have heard about. So you can build microservices which also run on HTTPs using Spring Boot. So what I'm showing you right now is the official guide of Spring, which you can use to build an application with Spring Boot. It will list down all the requisites which you need in terms of the JDK installations, Maven, and how to complete this guide, etc., etc. You can again use the same Spring initializer which I talked about in the previous session. You can use this to generate a Spring Boot project for you specifically. So all those options are available here. So I've already done that, and I'm not going to repeat what I just did in the previous session, and will directly jump to an IDE where I have created a sample Spring Boot application. And the structure here, you can see the structure would look very similar with one change, that in the previous example, when we were dealing with MVC, we had an SRC main resources folder, and that SRC main resources folder was having all the web components or the HTMLs. But since in RESTful web services, you do not render the HTML, but you just send back the response. The response body can be pure XML or it can be pure JSON, but you do not send back an view, and that's the main difference between Spring MVC and Spring Boot. That in Spring MVC, you are required to return a view technology. Like in the previous session, we sent a thy_my_life template, which is basically an HTML. You can also return a JSP, but with Spring Boot, you do not deal with the view technology. And that's the world we are living in today. When you write Spring Boot, you do not have to worry about how this is going to be rendered on the web page, whether it is going to be rendered using HTML or whatnot. What you need to take care of using Spring Boot is to return the right response body, the exact text of the response, and that's it. So with that in mind, the Spring Boot was born, and the structure, apart from that, the structure would look very similar. There's a pom.xml here, which will provide all the list of jars and dependencies which are required for this particular project. So you can see all the dependencies here, pretty much the similar ones. We have a starter web, we have a starter test, and we have a Spring Boot Maven plugin. And we have an application file, which is the entry point, again having a public static void main method. So you need to put the @Spring Boot application at the top of the class to make it an entry point. If you don't do this, Spring Boot will not run this class, and Spring Boot will even not run your application. So what we are doing as part of this example, that we are just printing all the beans which are provided by Spring. That's all we are doing. Like I said, it's a very lightweight and an introductory session, so we will keep the logics to minimum. And I'm just getting all the bean definitions, sorting the bean definitions, and just printing them one by one. How do you get the bean definition? You get that with this application context class, which is returned when you run the application. And how you run the application is basically using this line where you say Spring application.run, and you supply application.class with any command line arguments which you might want to use. Once you do this, it is going to return an application context object to you, and the application context object can be used to get all the bean definitions by calling this method which says get bean definition names. So that's the basic logic which is being run in the main class. Now we also have a controller, but this time it's not a web controller, but it's a REST controller. So you see in the previous example, we just had written something like this. It was just a pure controller. But here we have become more specific. We are saying that, hey, this is not a simple MVC controller, but this is a Spring Boot controller, or technically a REST controller. So Spring provides a separate annotation for that, which is @REST controller. So you write that particular annotation or on the top of the controller class which you are creating, and then you provide a request mapping similar to what we did in Spring MVC. But while you return it, you do not return a view technology. You just return the raw response. Here I'm just returning a string, but you can return a JSON object, you can return an XML object or whatever you want to, but not a view technology. That's what I'm doing. Like you can see, there's literally nothing I'm doing in this. It's just a simple string return statement which I've printed here. And that's all the code I have right now here. I just have these two classes. Okay, so that was all about what I have written in the project, and now it's time to run the project. So I have just reached to the location inside my terminal where the project's pom.xml was present, and if I just do an ls, you will see that there is a pom.xml available here, and all the code directories are also available here. So now I will just run this application, and to run this application, I'm just going to type mvn spring-boot:run and hit enter. Once I do that, the Spring Boot application is going to get started. And let's go back to the controller and actually the main endpoint and see what we were doing there. I did a sysout here which said let's inspect the beans provided by Spring Boot, and then I was printing all the bean names. And if I go back to the output, I will see the same line being written here, which was around let's inspect the beans. So you can see that message which says let's inspect the beans provided by Spring Boot, and then all the beans which are available in the application context are printed here. So that's the basic idea which I want to give you, that you can actually build a Spring Boot application and you can write your REST controllers, return a string body from it, and once this is run, then you can also run your application from the web browser as well. So let's try to hit that particular URL which I wrote here. So the URL of hello country. So for that, let me just open a new Cognito window, and our application is already running. So if I just say http localhost 8080/, I get this message here which says greetings from Spring Boot. And this is the message which we were sending from the REST controller. So this validates our understanding that we can invoke a REST controller, which is a Spring Boot REST controller, via the same method, but this time we are not getting an HTML, but we are just returning this particular string. Now you can use the string in any ways you want, so it depends upon the consumer. So that's all I want to cover as part of the Spring Boot. Now Spring Boot is a huge topic, and we can spend hours and hours talking about Spring Boot, but since this is more of an introductory session, so I just wanted the concept to get introduced, and remember the value proposition of why you would need Spring Boot. The basic idea is to build RESTful web services or build RESTful microservices. That's the basic idea behind using Spring Boot in your applications. And also remember the difference between Spring MVC application and Spring Boot application. Spring MVC is for building web application. Spring Boot is for building RESTful applications which might not have a web interface integrated with them at that moment.
Let's get started with our demo of a project which is using Spring Boot to build a RESTful web service. So a RESTful web service is nothing but any endpoint which you can access or you can consume the data from via an HTTP layer or via a simply web layer, because most of the web traffic which we deal with is built on HTTP. So to take an example, if you go to any website where you sometimes see on the top right corner, you see today's weather. So how is that today's weather coming in? It's coming in via a REST web service. The website which you are accessing is basically hitting an HTTP endpoint, which is where the weather application is sitting, and it asks for the weather data, and that REST web application just returns the data, and that's how the website is able to show you the current weather. So RESTful web services are everywhere, and they are the most popular way to build applications today, where you just build your RESTful web service and you expose an HTTP URL. And then the consumers need to just access that HTTP URL to consume the data from your application. And you see, this makes it very easy because there is no data type restrictions. There is no tight coupling here. It's just an HTTP endpoint. So that's the basic idea. And we will look at a project where we will be using Spring Boot to build a RESTful web service. And then we will try to run that web service to save some data and also to return some data. So here on the package explorer, you see I have created a project called REST service. And let's just walk through the structure of it, and then we'll go into the details of it. So we have an src main Java where I have a package, and I have a bunch of classes here. And before we go to the classes, let's first also access the dependency file, because every project needs some dependencies, some jars to execute it. For example, Spring itself is basically a jar. So you need to include the Spring jar in your project so that your project can become a Spring project. And there are generally two dependency tools. One is Maven and one is Gradle. In this particular project, I am using Maven dependency tool for downloading and managing the dependencies which are needed to run this project successfully. And the way you will find if it's a Maven project or if it's a Gradle project, for a Maven project, you will see a file called pom.xml. And if it's a Gradle project, you will see a .gradle file. That's how you can spot whether the project is using Maven for dependency management or it is using Gradle for dependency management. So let's open the pom.xml. Since it's an XML file, it will be a bit verbose, but if you just read it piece by piece, it will become easier to understand. First of all, since this is a Spring project, I need to include the parent dependency, which brings a lot of good defaults, sensible defaults from Spring Boot automatically. And this is the jar name. This is the artifact ID, which is Spring Boot starter parent. So any Spring Boot project you are starting, do include this parent. This parent is basically bringing all the dependencies from some other jar, and you can make your project as a child of this particular parent. So all the Spring Boot projects have this as a parent as a standard practice. After that, you provide your own details in terms of what is the package name, how do you want to see the jar name, and what is the jar actual name, what is the jar version, etc., etc. You also set the minimum required Java version to run this application. And then you, in the dependency sections, you provide all the jars which you need to run your project successfully, both compile and run your project successfully. So we added the Spring Boot starter web dependency, which basically brings all the dependencies around making a controller or making a repository, context component scan, all the interesting features which Spring provides get wrapped up inside the Spring Boot starter jar. And you can actually go to the MVN repository and have a look at what all classes it provides. It's a lot of classes. So I'm just telling you in a brief that it provides all the RESTful functionality. Then you have the next dependency as Spring Boot starter data JPA, which is going to enable this project to also have a database. And if it has a database, then you need Java to talk to the database. And the way Spring suggests to talk to the database is via using the Spring Boot Data JPA library. We will see this how this library can be used, but basically this provides ways to represent your Java object in the database. And then you need to also add the actual dependency of the database. And in this case, we are using an in-memory H2 database. So I'm not using an external database like MySQL or Oracle or PostgreSQL, because that will just make more configurations more complicated. I just wanted to keep it simple. And generally, in this H2 database, you can easily access by adding this dependency, and it will be an in-memory database created for you. Then I've also added Spring Boot starter test here, which will be used whenever you are writing unit tests, and you must write unit test for your project. And then we need to add the plugin so that Spring Boot can run this project. That's all I have in the pom.xml. Now let's move to the interesting part, the Java section part. Let's start from the main class. So this is how the main class looks like, where you just create any name with the class, and then you add a public static void main method. Inside the public static void main method, you call Spring application dot run. And this run method is basically going to run your application, and you just provide the same class name which you just wrote here. So you just say dot class. And if you're supplying any command line arguments, it can interpret that command line arguments as well if you want. So you'd always need an entry point in an application, and this is the entry point which Spring Boot supports. And this is, if you see this code, this is just normal code. To make Spring be aware about this class being treated as an entry point, you need to add @Spring Boot application annotation on top of the class. This is one of the annotation which is coming directly from the Spring Boot library. You can see this import. So once you add this, then only Spring will be able to treat this class as an entry point. Otherwise, Spring doesn't know where to start from. So when you run Spring, it will try to find a class with an annotation Spring Boot application. And then inside the class, it will try to find a public static void main method. And once it has found both of them, then it will just run the application. So it's very simple, nothing fancy here. And what we are dealing with here is a student object. So we will try to insert a student object, and we will try to retrieve the student object. So if you ignore these annotations which I've added, it's just a pure POJO. It's just a plain old Java object. You create a student class. Let's ignore this field as well for now. I'll just come back to this annotation in this field. But this is just a student class. It has 3 fields as name, age, and address, an empty constructor and a parameterized constructor, and some getters. Intentionally, I have removed the setters because generally, whenever you are building any enterprise grade application, you would like to keep your objects immutable. Means once they have been created, you would not like somebody to allow to change the values of the object. This just makes programming much more easy if you treat all the objects in your application as immutable. That's why I have not added setters here. It's just considered a good practice. So apart from the standard things which we have already seen, there are two things here which I want to talk about. Let's first talk about this one. So @entity is the annotation which is coming from JavaX persistence entity, and this makes Spring Boot save this particular object into the database. This is the annotation which you need to put on your class so that Spring Boot knows that this class represents a table in the database. So you need to add this to make sure that this represents a table. Second thing, a table will have a ID. It will have sort of a primary key. So I've created a new column called ID, which is basically representing the student's roll number or something, or maybe a registration number. And here I'm using a couple of more annotations. If you see, these annotations are also coming from JavaX persistence library. And these annotations will basically allow a new ID to be created every time you create a student object. So you don't have to specify the value of this ID variable. Spring Boot will automatically generate a new ID value every time you create a new student object. And how does it generate? You can provide the generation type as well. So currently I've just set it as automatic, but you can set it as identity, sequence, or controlled by table. You can also see the explanation of each of these here. But I've just kept it as auto, which basically let the persistence provider pick any appropriate strategy for the particular database. In our case, the database is H2. So that's about the entity class. Let's call this as entity class. Now let's move to the repository. So you need a repository class. Like I explained in that 3-tier architecture, you always need a DAO layer or a repository layer to store your student object into the database. So we have enabled the student object to be saved, but we need a handler which can save this particular file, this particular object into the database. And the repository classes are the classes which will allow you to do that. So you create a very simple interface. You name whatever you want to name your interface as, and then you say extends JPA repository, the type of the object, and the unique identifier of the object. So the type of the object is student here, and the unique identifier of the student object is the ID, which is of type long. So you need to just supply the types: type of the object, type of the primary key, or the type of the unique identifier. And this annotation is coming from Spring Boot. You can see specifically Spring Boot data library, which we added. So you just need to create an interface, extend it from JPA repository, and make sure that you add this annotation as well. Spring heavily uses the concept of annotations, and this will help Spring understand that this is a repository layer class, and it will apply some more metadata to this class while this class is running in the JVM. So what happens here? You just created an interface. You did not provide any method to create or any method to delete or any method to get a student object, because all of that is automatically provided by Spring Boot via the JPA repository class. If we go inside this class, and if you scroll down, you will see the find all method, find all by ID, save all, flush, save and flush, delete, etc. And if you go further up, this also extends the paging and sorting repository, which provides pagination and sorting facilities. But the interesting one is that paging and sorting repository again extends a CRUD repository. And if you go to the CRUD repository, you will find all the basic methods to save an entity, save multiple entities, find an entity by the ID. That's why it needed that long type to make sure that it can execute this method. You can check the existence of an object, find all the entries, find all by ID, count them, delete them. So all the basic CRUD functionality. So we call them as CRUD because the reason it is called CRUD because create, read, update, delete. That's basically the generic acronym. So because this CRUD repository provides all the methods and their implementations automatically, we do not need to write any code at all. So that's why Spring Boot is so awesome, and that's why Spring Boot is very popular, because it's zero code in the repository and you still get all the CRUD functionality. So that's about repository. Now we have covered the entity class, we have covered the repository class, we have covered the entry point class. Now the only thing which is remaining is the endpoint, the HTTP endpoint, which I talked about. And that you can create by creating any class. Generally try to suffix it with the controller so that your core developers can easily find this class. And make sure that you put @REST controller annotation on top of it. This annotation will allow Spring to treat this particular class as an endpoint class. Then you can auto-wire the student repository. So if you remember, I talked about the whole dependency injection and inversion of control. So here dependency injection is in action. So here you're just telling student controller to auto-wire the student repository. And now what will happen that at runtime, student controller, or actually Spring, will automatically create an object of the student repository and supply that object of student repository to student controller. So you as developer do not have to create an object of student repository explicitly. That's the benefit, and that's how the dependency injection is working, because you inverted the dependencies now. The dependency is just injected into the class, and as a developer, you don't have to take control of creating the objects. It's the Spring which will automatically read the auto-word annotation and will automatically supply an object whenever it is required. Then I have two methods here. Since we are talking about HTTP endpoints, so I have represented a post method here and a get method here. The way you will write a post method is via @post mapping annotation, and then you can provide the URL path on which somebody should call your endpoint to save something. So for example, somebody can call it HTTP localhost 8080/student/create. Whenever they hit that URL, the control or that request will directly hit this particular method. Why? Because you have provided the URL mapping here in the post mapping annotation. So since it's a post method, there would be request body. What is the actual request body which the client is sending? And you can represent that request body with the @request body annotation, and you can provide the type of the request body. And here I'm saying that, hey, if you want to access this particular URL, yes, all good, but you need to supply me with a text representation of the student object or a JSON representation of the student object. And then inside the method, I'm calling student repository dot save, which is going to save the student object which is coming in. So you see there's a lot going on here. I will show you how the student is represented in the request body as well, and then I will come back to how it got converted from JSON to Java. But this is how you can store this particular student object. You can hit this API as many times as you want and keep inserting a new student object every time. Then if you want to fetch a particular student, then you can do that by supplying the /student. And then in the curly braces, there's an ID written here. So basically you can supply the value of the ID of the student. So generally there would be another method here, which would be find all, to see all the students and with their ID, and then you can pick a particular student's ID, supply that student ID value here dynamically. That's why at the curly braces supports dynamic value. So here it can insert 1, 2, 3, or whatever the student ID you want to fetch the value for. You provide that value in the student/ID, and all good. Then if somebody is hitting the URL with saying localhost 8080/student/1, then student with the ID 1 will be returned from the request. And you need to put @get mapping to make sure that this method is treated as an HTTP get method. And you can provide the type, you can say get student, and here this dynamic value is captured with the @path variable, because you need to know the ID, right? Whatever ID somebody has supplied it in the URL, you need to capture that IDE and then use that IDE for calling the repository. So you can do that by using the @path variable. So here I'm just saying whatever ID is coming in, I will store that value inside this IDE. Once I've done that, then I can again call student repository dot find by ID, which is again a built-in method provided to me by the CRUD repository. I can supply the ID, and this actually is going to return an optional object, which is an object which may or may not contain a value. So it's just a defensive programming style. So this will return an optional, and you can call a get method to return the actual student object. This will return an optional of student. So optional of student means that this optional object may have a student or may not have a student. Why did Spring do that? Because the ID somebody is supplying, that ID can be invalid also, right? So optional object takes care of that if there is no student found, then you will not get a null pointer exception. And if there's a student found, you can return that. So it's just a defensive programming style which Spring has adopted by returning an optional of the student object rather than directly the student object. But if you're confident that this particular optional of student object does contain a student object, then just call optional.get, which I've called here, which will return the actual student object sitting inside the optional object. You can read more about the optional object and its usage from the official Java docs, and there are tons of examples available on internet. So this is about the controller. We have covered all the classes. Now it's time to run the application. So you go to the command prompt, you go to the particular file folder location, and there you just say mvn spring-boot:run. So I just hit enter, and this is going to run the application. It's going to spit some logs here, and if everything is fine, you will not get an error, and you will just be getting a message saying that application got started. And it's running on Tomcat localhost 8080 with no context URL. So this is not a web application. This is a RESTful web service, right? This is a RESTful service. This is not a web application. So there is no web interface. So how do you access this? You just have an HTTP URL. So you can use any of the REST client available on the internet. There are probably hundreds of different REST clients available on the internet. You can choose any one of them. I am using advanced REST client, which you can also install as an extension from the Chrome browser itself. So if I just open the Chrome browser and I just say REST client, if you just write this and hit enter, you will get many different options. And the first option you get is from Google Play Store's App Store. So you can go to the App Store, basically the Chrome Web Store, not the Play Store, but the Chrome Web Store, and you can just install this. Since this is already installed, you can click on Launch App, and it will open this interface for you. So this is this is not a tutorial for advanced REST client, so I'll just be quick here. You can choose the method type which you want to hit. So let's say I want to do a post, and then you can provide the URL here. So remember the URL which we put here in the controller method, this has to exactly match. So HTTP localhost/student/create should be the URL. So let me just copy paste this one here. Okay, so the URL is good here. It's a post type of method which I want to do, and I want to hit this particular URL. Now I need to supply the content type and the body. So in the content type, you can choose application JSON because I'm going to supply a JSON object. And in the body, this is how the JSON object looks like. Advanced REST client also provides a nice visual interface to basically create this JSON. If you are thinking that JSON creation is very tough, it's not actually tough. It's just curly braces. And then you put key and value, comma, let me just put an enter here so that it's more readable. So you just put curly braces starting and end, and then you just put key value. You put a key, which is the variable name and the variable's value, variable name, variable value. And these keys have to exactly match the student's properties. So the student.java had this name, age, and address, right? So it has to exactly match. Otherwise, this request will fail. So this is all good. Now I can send this particular request. When you click send, it is going to hit my Spring Boot application, which is running on localhost 8080. It is going to call the student/create method. It is also going to convert this JSON into a Java object because here I'm supplying a Java object. So it will convert the JSON, which I'm sending from here, to Java object automatically, and it is going to automatically save it here because I've called the repository.save method. So let's hit send here. Once I hit send, I get a 200 OK. It means everything went fine. And in the response header, I get the object back because I have returned the object here. You see, this save method is going to return the same student object which you created. So everything is good here. My object has been stored here. And now it's time to fetch the object. So it has already been saved into the H2 in-memory database, and you can obviously go and connect to the in-memory H2 database and have a look at it. But for simplicity, I'm just going to do this here. And let's say the first object is generally added as the ID 1 by default by the H2 database. So let's hit this particular URL. When I hit this URL, it is going to hit the student controller here. And in the student controller, it is going to hit the getStudent method, which is having a student/ID URL. And it is going to find the database with that ID. And if it finds a student object with that ID, it is going to return that. So let's confirm that now. So let's hit this particular send button, and it is going to hit a get request with this particular URL. Spring Boot is going to find if a student with the ID 1 exists in its database. So once I hit send, I get a 200 OK. And you see in the response headers, I get the same student object back, which I added. Let's try with 2 now. Let's see what happens. I see 2 and I get 500 internal server error because there is no object stored in the H2 database of the Spring application with the ID 2 yet, because we only inserted one object. That's why only one student object is there, and the first ID which H2 database created for it automatically was 1. So when you hit for get request with a student ID 1, you get the object. When you put any invalid value, and you hit this, you get a 500 internal server error. You can also make it look nice by not sending the 500 internal server error and sending a nice exception from the backend. So from here, you can also send a nice exception that if this object is not found, you can say something like that, or else throw, which is again an optional object. And here you can supply a particular type of exception which you want to supply instead of just throwing 500 internal server error. But that's just additional defensive programming you can do. You can add more and more validations and constraints into this project as you build this project in a more complex paradigm. So this is basically what I wanted to show you, that we have created a Spring Boot application. We have connected it to a database. We have created also an HTTP endpoint with student controller. We ran that application. We used any random REST client. In my case, I used advanced REST client. And we first did a post request. We provided the exact URL. The URL has to exactly match with the controller URL. And then the body, the request body also has to exactly match with the student object's property, especially the case of the names have to exactly match. So if all this matches, then you will get a response back that the object has been created. If you want to fetch the value of the object, you're going to use the HTTP GET method, and you again provide a URL which has to exactly match to some method in some controller in the Spring Boot application, which is running on localhost. And if you provide the right ID, you are going to get a valid result. If you provide an invalid ID, you're going to get a 500 internal server error. And from here on, you can make this controller as robust and as mature as you want. You can add find all method. You can add a update student method. You can add a delete student method. You can have all different kinds of filters. Like, for example, return to me all the students starting with the name A, or return all the first students with the roll number 1 and 100, or between 1 and 100. So you can write as many endpoints as you want and build this application with as much maturity and as much complexity as you want.
And with that, we have come to the end of this tutorial. If you guys feel that we have missed out on some important topics that we were supposed to cover in this tutorial, then please feel free to drop them down in the comment section below, and we'll have your questions answered. If you guys like this video, then do give it a thumbs up. Please comment your doubts below, share it with your friends, and don't forget to subscribe SimpliCode. Thank you.